All right. Hello. Welcome to our very first ever Lowell Observatory Messier Marathon live stream. This is pretty exciting. We are up here at the Giovanni Open Deck Observatory, also known as the Godo. And we are actually waiting on a few clouds to break up so we can start taking some of these images and checking off items on our list. You can see this really cool poster behind me here. It lists all 110 Messier objects. And if you're not familiar, Charles Messier was an astronomer in the 1700s. Yeah. And he was looking for comets. And comets can appear pretty fuzzy in the sky. And so as he was scanning the sky for comets, because comets are what bring you fame and money, by the way. So as he was searching for comets, he kept on coming across these other nebulous objects. Nebulous just meaning kind of fuzzy and cloudy. And he was sick of getting tricked by these objects into thinking that they were comets. And so he started cataloging them, starting with M1, M for Messier, right, his name, and all the way through M110. And it turns out this list of 110 not comets is one of the best deep sky catalogs that we have, and a real treat for amateur astronomers and those who enjoy astrophotography or even just pointing manually a telescope or binoculars. You can do what's called a Messier marathon, typically right around this time of year. So in March, middle of March, we were going to do ours last week, but of course we got clouded and snowed out here in Flagstaff. But we are live today, this Saturday, and we have a little bit more moon than we would have had last week. But of course, you want to do it on a night where the moon is not too bright, so you can see some of these dimmer objects. And you have to start right as the sun's going down. And really continue all the way till dawn in order to be able to get all of these 110 objects, because they range, they cover the entirety of the Northern Hemisphere sky. And so we want to look for them. Well, what I was going to say is actually so that they're high in the sky at certain times of the year. And, some of them are known for being up in the fall, like Orion. But right now, we have to get them when they come. So some of them will be, right before sunrise. And some of them will be right at sunset. So I'm going to move the camera down a little bit so maybe you can see more of this poster here. A question in the chat, do we have to go in numerical order? That's a really good question. Actually, no, because if you did go in numerical order, these objects are kind of spread all over the sky. They were not all cataloged at the same time by Messier in the same part of the sky. And so you'll want to do them in a roughly kind of a right ascension order, actually. So not in numerical order, but in the order that they start coming up or going down, I should say, in the sky. So you'll start with the ones that are about to set right at dusk, and then you'll kind of go from there. So we have a list of all the objects that we're going to try to get tonight, and we'll be checking them off as we go on this beautiful poster back here. And we will, keep a tally through the night and hopefully get all 110 of them. So this poster back here is actually a small replica of a bigger poster that we have in our Astrolab classroom, which is up here at the Godo. And that poster was donated by Mark and Bonnie Howard for that Messier exhibit chart that's in our Astrolab. So this is just kind of a smaller version of it that we're going to use to put our signature on each time we find an object, and it'll be a cool reminder of this marathon. I also wanted to thank the donors of the 14-inch plane wave telescope that we're going to be using tonight, the Don Neerling Memorial Foundation, and the Malincam. Let's see. I think they donated for the 14-inch and the Malincam. So thank you guys so much, because we have really wonderful equipment for doing this Messier marathon tonight. We mentioned a 14-inch. Oh, that's right. I actually forgot Malincam donated the current Malincam that we have. So we had an older version, and Malincam donated us the nice shiny new version that we have right now. So it's a really nice camera that we have attached to the plane wave, which is a 14-inch telescope. and it is connected to this camera, then fed to a computer where we can move the camera around to different parts of the sky and take images. As you'll see through the night, we get to kind of play around with images. So we use the software, the imaging software from Malincam, to take long exposures, especially of really dim objects, so that we'll get more detail. And even for really bright objects, you can use a video mode, so you kind of see a live feed of what's going on. So it's a really a cool thing, and some of our educators have gotten really amazing results using this software and playing with the settings like the gain, saturation, the white balance, and then just the general amount of exposure that you're going to give, which is how much light is going to emit. So you'll see throughout the night our different educators trying to image these objects as we kind of frantically go through them. And they're actually, speaking of frantic, so there's times during the night when we'll have to get through a lot of objects very quickly. So like at dusk and at dawn, we're going to be wanting to go through these objects as fast as we can and even kind of cycle through them. If we don't get one, kind of cycle to the next one and go back. So we'll be doing that kind of rushed at certain times. But then there are other times during the night when it'll kind of slow down a little bit. And so we'll get to chat more about, the objects that we're looking at and questions that people may have in the chat, anything that you wanted to know. So we're also, I want to mention, on broadcasting on Twitch tonight. So this is a really cool opportunity. Hannah Zygo and Jacob Irish are educators who stream interactive stargazing on Twitch. And so tonight we're going to be there all night on Twitch at Lowell Observatory. So you should come say hi to us over there if you're into that, if you're watching us on YouTube right now. So again, we are having a little bit of weather issue right now, just some clouds coming up from the southwest. So actually we in Flagstaff have a kind of unique geographical position. So there is we're on the Colorado Plateau, which is a very high and large kind of arid, high desert region, like northern Arizona and southern Utah, all the way into kind of New Mexico and Colorado. And so we're on this Colorado Plateau, but the edge of it is just south of us, called the Mogollon Rim. And so a lot of times we'll get this flow of moisture up from kind of California, from the Atlantic Ocean, and that moisture will hit this Mogollon Rim, and then the air goes up, and that causes clouds to form. So that's kind of what's going on right now, and that's why we're expecting the clouds actually to start to break up as the sun goes down, because they need that atmospheric heating to be able to form and condense into clouds. And so as the sun goes down, that heating and convection element goes away. And so we should see them break up pretty shortly. So in the meantime, though, that means that I get to kind of ad lib and talk to you guys about all the things that we're going to be doing tonight. So one of the first objects we're going to be looking at once we get the sun gone down and these clouds out of the way will be the Pleiades, which is M45. And that's a really popular object. It's a really beautiful one, and one that we see pretty obviously in the night sky. So it's like a little mini dipper shape. And when we image it through the plane waves, we're actually going to be just kind of taking pictures of a few of the stars because it's such a wide star cluster. It's very close to us, actually, relatively speaking, in astronomical terms. So it takes up quite a bit of space in the sky. So we'll be imaging just some of the stars, the bright stars, and that nebulosity in the Pleiades. Do we get a lot of gliders? Oh, so we got a cool question in the chat from Chris. Do we get a lot of gliders soaring those thermals? That is not, it's a great question. It's not a good question for me because I wouldn't be caught dead on a glider soaring off of a cliff. But I imagine that they do. I don't know. I'm sorry, Chris. I wish I knew the answer to that. Maybe one of my fellow educators knows and will save me here. But that would be a pretty good place to do it, I think. Again, we are live here in Flagstaff, Arizona. I'm Kendall Edwards. I think I forgot to introduce myself at the beginning, but I'm one of the senior educators here at Lowell Observatory. You might have seen me this morning, actually. I'm just talking into space a lot today, into the YouTube world. I did a stream this morning because today happens to be the spring equinox. So today was the day that the sun crossed over to start being more northerly in our sky. So we are getting into the spring season here, a little bit warmer weather in Flagstaff. And unfortunately, that also means a lot of wind up here in Flagstaff. But today was a pretty windy day. We saw lots of clouds just kind of building up on the rim and flowing overhead. So hopefully those will start breaking up pretty soon here. I'm actually sitting in the telescope lab in the back of the Godo. So out front, if you've never been here before, this building is a plaza that has 6 telescopes mounted into the concrete. And then there's a stationary building behind that. But over all of it is a hangar, basically, that glides on tracks. And so then it comes out and covers the telescopes, and a garage door goes down when we want to close up for the night. And then when we open, that garage door comes up, we slide the building right back and expose the telescopes to the night sky. So it's a really nice, wide open field of view. We have a few limitations with this Messier marathon. As the building is lined north-south, it's aligned with Polaris. And so there are a few objects just right behind the building on the northern side and the northeastern side that may be a little bit blocked by our building. But I think it's only really one star cluster in Cassiopeia that we're worried about might be a little too far down on the horizon. But we really do have a pretty great field of view up here. And if you were to be standing up here at the Godo Plaza on a nice dark night, you would see the city of Flagstaff down below. So we're on Mars Hill, and you can see the city, you can see downtown about 200 feet, 200 to 300 feet down below. And you can see the city lights, which thankfully are quite dim and appropriately colored because Flagstaff is an international dark sky city and was actually the first international dark sky city. And so we have a lot of light pollution regulations here that allow us to keep a dark sky, which is amazing for us here on the Hill, that we can be next to a decently sized city with a college and with kind of a thriving population, lots of science going on up here, but we can also still have our telescopes and see really faint things like some of these Messier objects in the night sky. So I have a question from Twitch from Pandemic Watch. Is this building new since the telescope was acquired? So that's a good question. So the building itself and the telescopes were all constructed in around 2019. We opened up the Godo to the public in October of 2019. And it was really a lot of fun when we opened it for the first time. This was pre-COVID, of course. And so we had general admission, and just people would come in and really get to see a lot. We have a 32-inch telescope up here that is, I think, one of the biggest that's available for public programming for people in the general public to use. So that's a really cool experience to look through this 32-inch telescope that can give you really amazing images of things like the Orion Nebula, a lot of the dimmer objects that are, and globular clusters actually too. We'll talk some more about those tonight, but globular clusters look really nice through the 32-inch. But then we have telescopes that are kind of good for all different kinds of things. Our Moonraker is really good at planets and kind of tight star clusters, whereas our Tech telescope has a really wide field of view, and you can image things or look at things like the Andromeda Galaxy, that's M31, and really get to see the whole angular diameter of it, which is, and so that the Tech telescope is actually probably most of our favorites up here because it's really got great optics. It's really easy to use, and it always gives an amazing view. And then, of course, we have our plane waves. So one of the plane waves is a 17-inch, and it's got some instrumentation attached to it, including a spectrograph. So we use that to look out at things in space and see what they're made of. And we can talk a little bit more about spectroscopy later in the stream, and how we find out all kinds of information about things in space that we can't touch by looking at the light patterns that they make. So I answered the question from Twitch that yes, this building and these telescopes are all fairly new, and sadly, just in March of 2020 is when we had to shut down for COVID. So we really didn't get to use them with the public and with big groups up here for very long. Luckily, we are moving into phase 2 of our reopening right now. And so that is going to bring a few more people up to the hill, safely, of course. And we will be, having a little bit more action up here, some daytime tours that are going to be going on. And also I moved kind of to a model where we were only bringing up, maybe 10 people at a time that were cohabitating or co-traveling together. And that protected those people, and it also protected us at the telescopes. We had to get really creative up here too, actually. We had to find a way that we could clean the eyepieces between people viewing, or especially between guest viewing and our educators viewing. But the chemicals that you would want to use to clean with would not be good for the optics in the eyepiece. So our awesome supervisors came up with an idea to use Petri dishes. So they are optically clear. So they use Petri dishes and just put Velcro on them and put them over the eyepiece. And that way, between each person viewing, we're able to spray it with a high alcohol content spray and wipe it down. And so we're sanitized that way. And of course, we're out in the open air here at the Godo. We have this big open space. So it's a really great place to be. And I look forward to moving into this phase 2 and hopefully eventually back to the good old days. After everybody is vaccinated and after we're able to meet all of those CDC guidelines for reopening. So that'll be really awesome when that comes. But to go kind of circle back again, if you're just tuning in, again, my name is Kendall Edwards, and I'm a senior educator here at Lowell. And we are kind of on a weather delay right now. So you can imagine me as the announcer on your favorite baseball game when there's a rain delay, who's trying desperately to find things to talk about that will keep you interested and viewing. So we're clearing out, and we're getting some views of the moon, I've heard, now on the plane wave. So I think that hopefully these clouds will clear out sooner than later, and we'll begin to start imaging these Messier objects. Again, I said we were going to start with M45, which is the Pleiades, but we're going to start cycling through. It's going to be really exciting first hour, actually, because we're going to start cycling through a lot of objects right away. Some star clusters, a lot of galaxies, and yeah, it's going to be pretty exciting. So during each section, you'll have a host that's sitting here. That's me right now. But we'll be switching off throughout the night because we will, again, be here until dawn. Not me personally. I'm only here till 12:30, so I'm a little too old to do the all-nighters anymore. No, we split up into 2 shifts, so we can take half and half. And some of our fearless leaders are going to be here all night long, and we appreciate them very much. So feel free to tune in and tune out, kind of come in and come back. We'll be talking about all the things that we're looking at in the night sky and answering your questions and streaming over on Twitch. We actually have a question from Twitch right now from Sky Detective. What is the bottle on top? Oh, what is a I don't know what that actually means. Okay, well, I am stumped by that question, and hopefully I'll get some clarification soon. Oh, it's the dark sky rating, the Bortle rating for on top of Mars Hill. And I don't know offhand, actually. We have a poster in our astrolab that talks about light pollution and that Bortle rating for dark skies. And it shows an example of what Flagstaff, the dome of the city lights, looks like as compared to like Cheyenne, Wyoming, and more rural places and more urban places. So that is a good question. And hopefully I'll get somebody to look that up for me, and we will get that information to you. Thank you for that question from Twitch. I have another question here from Jonathan Walker. How does a barred spiral galaxy get its bar? Wow, diving in right away with this good stuff. So the Milky Way is a barred spiral galaxy, and that is actually some complicated astrophysics on how that bar happens. So the spiral arms on a galaxy come from the spin, the spin of a galaxy, and then these spiral density waves that kind of flow through and create this pattern of star formation that leads to these spiral arms. But I'm going to have to defer to one of my colleagues actually to find out how the bar is actually formed in a barred spiral galaxy like the Milky Way. So Jonathan, we will get back to you on that question. Oh, and thank you to Jeff Hall, who let us know, that's our director, that we're about 4 to 5 on that Bortle scale of dark skies that we were talking about. We have a question from Kathy Anderson. Have we spoken about the meteor coming by Earth tomorrow? No, we have not, actually, and that's a good thing to talk about. So yeah, tomorrow there's going to be a close approach by a meteor, but of course there's nothing to fear. It'll be whizzing past Earth at a nice safe distance, and this actually happens quite a bit. And these near Earth objects are well tracked, and actually one of our astronomers here, Nick Moskowitz, has an all-sky camera mounted up here on one of the buildings and is able to look out and track really everything that's coming into the sky. And a lot of our researchers are looking at all of these near Earth objects, asteroids and such, making sure that their orbits do not come too close to Earth. And so there was a good article on Earth Sky this morning about the one that's coming by tomorrow. So I don't know all the details on that one, but if you want to check that out on Earth Sky, that would work. So it looks like we've got something here on the plane waves. So we're trying to start doing some images. You can see those clouds floating in on the screen there. So we're still working with some clouds here. Still got a little bit of that wind flowing up the Mogollon Rim that we talked about, and bringing that cloud cover up to us in Flagstaff. But we're hoping that it'll clear out. And of course, there's a little patch of clear sky right there. So that's good news. Are we on the Pleiades right now? Let's see. I'm gonna have to find my chat buttons again. Okay, this one is M52, which we got 1 star of. Yeah. All right. So it's a start, and it's our first object, M52. So I'm going to make a little tally mark here. And again, this is an open cluster in Cassiopeia, and one that we didn't know if we were going to actually be able to get tonight because it is kind of low in the horizon and to the north. So I'm going to initial it and show everybody on the poster how we're going to be doing it throughout the night. So we're going to break in our shiny new poster here. So M52, right over here, this open cluster. Sign my initials, and we can show everybody here a nice awkward view of the poster. So hopefully the idea is by morning time tomorrow, we will have signatures on all of these little boxes. So that is going to be a lot of fun. All right, we got the first one, M52. So this is one of the clusters that actually, or one of the Messier objects, I should say, that was actually found by Messier. Some of them were kind of well known before, and some were found by his assistant, Pierre Messier. I'm not saying that right because I'm not French, but he found a lot of these Messier objects too. So let's see, we're moving on now and to see if we can get any of M103. All right, so M103 is another open cluster in Cassiopeia. So Cassiopeia is a northern constellation. It's a little bit clouded out right now, it looks like. So we didn't get M103 just yet. But Cassiopeia is circumpolar. So you can see it orbiting from a northern latitude. You can see it orbiting around the Polaris, the North Star. Looks like a little W, sometimes like an M or a 3, as it moves around Polaris. So it's actually got a pretty cool mythological story associated with it too. So we'll get into that in just a minute. I've got another question from Twitch, Orion. So that's the question, Orion. Are we going to see Orion? I hope so. So Orion is right now kind of setting pretty early in the evening by like 10ish or something like that. But we will be doing and some Orion objects around there around 8ish. So if you stick with us, we will definitely get there. And Orion is, it's kind of in the, let's see, southwest sky right now. And so, yeah, it'll be setting fairly early. So we'll get around to that one pretty soon. The Orion Nebula is a really amazing object, a star forming region that we're going to catch in Orion. So again, we were trying to get M103, which was another open star cluster. And I didn't actually explain what open star clusters were yet for anybody who's not familiar with them. Open star clusters are groupings of stars that were most likely born together in the same big cloud of dust and gas. So stars are born out of these clouds, big clouds of hydrogen, and mostly H2 regions. So there's gas and there's dust and a little bit of spin, and eventually gravity starts doing its job and pulls pieces or molecules of hydrogen closer to each other. And then as they build up and create some mass, through gravity, they attract more and more mass. And so what you end up with is a big enough ball of hydrogen and dust and other elements that it actually starts to create fusion in the center. So there's enough gravity and enough heat to start creating nuclear fusion in the center. And at that point, a star or a protostar is born and strikes a balance between that fusion pressure from the center and gravity pushing from the outside. But so these stars in an open cluster were all born of the same kind of big molecular cloud, and they are fairly young usually and just haven't moved very far away from home yet. So they're very loosely gravitationally bound, kind of moving off into their own places in the world. So we're about to try M31, it looks like. So that's Andromeda Galaxy. And I am hoping that we can get this one. Andromeda Galaxy is a little bit faint. Just because it's so low on the horizon and we're not quite all the way at dark yet. Let's see. Andromeda Galaxy, if we're able to get it, that's actually one of the furthest things that you're able to see with your naked eye if you're out in a really nice dark sky place. You can look up in the direction of Andromeda constellation and star hop around and see this kind of smudgy space in the sky, especially if you don't look directly at it, if you use what's called averted vision and take advantage of those parts of your eye around the outside that see better in the dark. You'll be able to see kind of a little smudge there where Andromeda is, and you're seeing light from 2.2 million light years away. So that's pretty cool. We got a question from Twitch again, from Sky Detective. Are all the Messier objects up this time of year? And is that the reason for having the marathon now? That's right. Yeah, so this time of year gives us there's really a very small window in which you can do a Messier marathon. It's around March, April, when it's possible to image, if you, like I said, start right at dusk. Oh, a fuzz. Look at that. If you start right at dusk and go all the way to dawn, you'll be able to, at this time of year, get all these objects. Okay, so M31, there was a fuzz, and we're going to mark it off. So I will ceremonially sign the Andromeda Galaxy. Let's see, M31. Here it is. So Andromeda Galaxy is part of our local group. It is a spiral galaxy, and like I said, it's about 2.2 million light years away from us. We got M32 as well, also a tiny little fuzz. And M32 is a companion galaxy to Andromeda. So that's pretty cool. Let's see, I'm gonna mark it off. So M32 is an elliptical, but it's part of a group of galaxies that are satellites of Andromeda. So we got M32, and that is cool. All right, so moving right along here. We are trying some open clusters again now. We're going to go back around, circle back around to M34 and M103. So M34, actually, I don't know if we tried that one yet. Oh, 34 is good. All right, so we got M34. That is an open cluster in Perseus that was discovered actually well before Messier's time, located about 1,500 light years from Earth. So we got M34. I'm going to mark it off here, an open cluster. All right, we are cooking now. So we are at, let's see, 1, 2, 3, 4 objects. I keep forgetting to do my tally marks here. So again, we are we got M103. All right, so M103 is good. And that one is also a, let's see, what is M103? An open cluster in Cassiopeia. That's right. So M103, we're going to sign it off. It's kind of interesting how 2 open clusters, both in Cassiopeia, have numbers so far away from each other. We're going to M74 now, and everybody needs to keep their fingers crossed. We're going to have to get lucky, I think. But M74 is a spiral galaxy in Pisces. So this one's going to be pretty faint if we are able to get it. Let's see what I've got on M74. This one is actually called the, it's also known as the Phantom Galaxy. And like I said, it's in Pisces, the constellation, about 32 million light years away from Earth. And it's actually, let's see, I don't see it yet, but it's actually a really great example of a grand design spiral galaxy. So it's got these really nicely defined spiral arms, and we can see, and it's actually face on to us as well. So it allows for seeing this grand design spiral and studying it, which is pretty cool. So let's see, we are working our way down the list here. So M74 is actually one of the hardest ones to image because it is pretty faint. So we'll keep trying here. If you're able to see the Hubble images of M74, this spiral galaxy or the Phantom Galaxy, you will thank me later. So you should look those up, M74 pictures. So it's a really, really beautiful face-on galaxy. All right, so I see that the telescope operators out there are really doing an amazing job to cycle through these first objects and get us going into this Messier marathon. We're going to try M110 again here. So M110 is one of the satellite galaxies of the Andromeda Galaxy. So if you remember, we got M31 and M32. But M110 is a dwarf elliptical galaxy, satellite of Andromeda Galaxy. It's located about 2.5 million light years away from Earth, so that's pretty good distance. Let's see what else we can find out about it. Let's see. Okay, has a magnitude of 8, so it's pretty faint. And this one was actually discovered by Messier as well. So that's interesting to note the ones that he actually discovered and ones that were, either well known before he came along or were discovered by, people, his colleagues around him. So we're trying M74 again, kind of going back and bouncing around so we can find some holes in the clouds and find some of these fainter objects as the sun finally kind of sets down and we get true darkness out here. So again, when it's really dark, it's a lot easier to image some of these fainter objects, which is why we're glad we have dark skies here in Flagstaff, of course. So let's see. Not seeing anything yet, but we're going to keep on trying with these objects here. So let's see. We have a couple more galaxies that we're going to be imaging in this segment, also a globular cluster. So we've got some good stuff coming. We're going to try M77 right now. So this is another spiral galaxy. It's in Cetus. And we have kind of a limited time to try to grab this one before it sets, but also it's kind of a balance with waiting out the sunlight. So if it's too bright outside, you won't be able to see it because it's so dim. But also as it gets lower in the horizon, it gets harder to image as well. So kind of got to balance that out there. So M77, let's see, is another barred spiral galaxy. And I still haven't answered that question from one of our viewers about barred spirals, but I'm hoping that someone will get back to me on that one. So again, it's a barred spiral, M77 in Cetus, also known as NGC 1068, about 47 million light years away. So that's pretty far. This one was discovered by Messier's assistant. I'm just going to call him Pierre from now on because his last name's a little hard to see. Oh, look at it. There it is. Do you see M77? We got it. So this is another signing ceremony here. M77, spiral galaxy. Got it. All right. Put another tally on our list, our object list here. Actually, we're up to 6 now. So we found 6 objects. All right. So let's keep it going. So 6 down, 104 to go. Pretty good, right? So I hope you plan on being here with us all night. We're on Twitch as well, streaming there. So you can say hi to us over there at Lowell Observatory. And we are going to keep on going all night until we find as many of these 110 Messier objects as we can. And now we're going to M74 again, trying it again, that spiral galaxy in Pisces. Again, this is going to be a difficult one to get, but we're going to keep on keeping on with it. Again, this one was called the Phantom Galaxy also, and it's just a really beautiful face-on galaxy, spiral galaxy. So that means I like to think of galaxies kind of like a fried egg. So if you've ever seen a fried egg in a pan, you got the white all around it. That's like the spiral arms in the star forming region. And then you've got the little yolk in the center. That's like the halo, the center of the galaxy where there's the most concentration of stars. And sometimes when we're looking out, we see that galaxy, some galaxies face on. So meaning that whole spiral structure, it'd be like looking down at the top of your pan with your fried egg in it. So you'd see the yellow circle and the white all around it. But some galaxies that we're looking at, we're actually looking at edge on, like some of the, like M80, let's see, one of the Bode's nebulas, nebulae, the cigar galaxies. We're looking at it side on like that. So it'd be almost like being an ant on the side in the pan looking at the fried egg. It's a weird analogy, huh? We got a comment from Christopher Dix. Can we highlight the objects with anything besides the hand cursor? We can try a pen. Right now, they're fighting the clouds pretty hard out there. Oh boy. So there's just not a whole lot to see. As you can tell, it is windy. So I got a little bit of the poster on my shoulder there. All right, so we are fighting hard to get some of these first objects still, but we have 6 down. Let's see, we've gotten M31, the Andromeda Galaxy, M32, an elliptical galaxy, that's a satellite, M33, the triangle, no, we haven't gotten that one yet, M34, an open cluster, and let's see, M52, another open cluster, M77, a spiral, and M103, an open cluster. So we are moving along here. I mentioned that Pleiades was going to be one of the objects that we were going to do first, but it'll be up for a little while still. So we're going to wait on that while we try to get some of these sneaky ones that are going to set soon, like M110. All right, so we're going back to M110 again. That's the satellite galaxy of Andromeda. You might notice that M31 and M32, that's the Andromeda galaxy, and one of its satellite galaxies are very close together in the numbering system. But M110, although it was found right around the same time, it wasn't documented. And so it was added later on to Messier's catalog. It kind of got lost in the shuffle. So we are, let's see, we're waiting on some clouds. They're breaking up, but off to the west of us, it's still pretty bad. And I mentioned that, we get a lot of that flow from the west-southwest, from California and from the Atlantic Ocean that through geographical features kind of goes up, convex, and gives us some cloud cover. It's moving fast, and we're hoping it'll break up soon because we've lost the sun now and some of that convective heating. So we're hoping they'll break up soon. But meanwhile, we are powering on. All right, so right now, can't tell what we're looking at here. Let's see. We're going to stay on M110 for a bit, it looks like. So we're hoping that the clouds will break up enough to get just an image, a vision of it, maybe. And so we're just going to stick here for a little while on M110 and see what we can see. All right. So you've heard me mention some different kinds of galaxies, that this one, M110, is a dwarf elliptical galaxy. So there are several different kinds of galaxies. There are spiral galaxies, like our own Milky Way, which is a specific type of spiral called a barred spiral. There are these ones that are just magnificent spiral galaxies that have these really symmetrical spiral and defined spiral arms that we call grand design spirals. And there are elliptical galaxies, which are, I typically think of elliptical galaxies as being the product of galaxies that have merged together, and they're kind of this big blob. They're also usually not as active as spiral galaxies, not forming stars as actively, although there are some examples of elliptical galaxies where we still see some star formation, just a little bit more slowly. We're going back again to M74 here, the spiral galaxy in Pisces. And as you can see, we're kind of going to just keep toggling back and forth while these objects are up until we find that hole in the clouds that we need. Because again, we want to get all 110 objects in order to complete the Messier marathon. Of course, if you were doing this yourself, it is very hard to get all of these objects. We have quite a bit of human power up here tonight. We've got people that are hosting, that are helping research these objects. We've got people that are running our plane wave computer and telescope. They're imaging these objects for you tonight. And we've got people who are helping us with this stream. And we've got people on Twitch. So we really got a lot of human power up here tonight, bringing you this really cool stream. And I have never participated in a Messier marathon before, so I'm excited to be here. And hoping that we get to check off more of these objects than not. We are on M74, still hoping we're going to get a break here because we're going to lose it soon. So we'll just keep on this one for just a little bit. All right, so we were talking about the different kinds of galaxies too. So there are also some irregular galaxies. There's a catalog of galaxies that have the name ARP attached to them, ARP, that are all very irregular and weird. And if you ever get a chance to look at some of those irregular galaxies, you should really do that. A lot of them are so weird because they're interacting gravitationally with other galaxies. And so you'll get these kind of streams of star formation because of the tidal forces and really interesting shapes of galaxies being kind of pushed and pulled apart. So I highly recommend taking a look at some of those ARP galaxies. We're still on M74, hoping to catch a little glimpse of it before we lose it, so we can sign off another block on our Messier chart back here. And I mentioned earlier that Mark and Bonnie Howard are the ones who donated a copy or oh, we found it. Hey, M74. Anyways, we have a copy of this chart in our Astro Lab, and we thank them for that donation. So we got M74, yay. I'm going to check it off. All right, so M74 initialed, add another tally mark, we got 7. All right, so again, M74 was that spiral galaxy in Pisces, and we got it right before we lost it to the horizon. So that is very exciting. We are making our way through this object list tonight. Oh, that looks like a good view. Which one is that here? That is M110. Okay, so you can see that we're not getting the best quality of images right now. This is because this is the kind of dusk rush time that we talked about. So that's M110. I'm going to go ahead and sign it off here. That was that other companion galaxy or satellite galaxy of Andromeda. All right, look at us go. All right, so again, these images, because we are at dusk, so not complete darkness, and because of some of the clouds, we're not getting the best images yet. But as the night goes on and as things clear out and as it gets really nice and dark, we're going to get some really amazing images for you. So hang in there with us. We're going right now to M33. This is the Triangulum galaxy. So named because it's in the constellation Triangulum, which is a really, it's really interesting constellation. It looks like a triangle. So you can try to find that one out there in the night sky. So M33, let's see, we're working on it here. So Triangulum galaxy is about 2.73 million light years away from Earth in Triangulum. And it's part of our local group, like Andromeda, and let's see, we got it's part of our local group, and it is the 3rd largest member of the local group of galaxies behind the Milky Way and Andromeda. And then we saw those satellite galaxies too that are all kind of part of our local group. But we just want to celebrate because even though we got some pretty dim images, we have gotten 8 objects so far. And that is pretty exciting. So thanks for sticking with us as we're fighting off some of these clouds and this dusk rush to get in some of these objects before they set. As the night goes on, it's going to kind of be a different flow depending on the different times of night. There are going to be times that are slower, and we'll be able to really get some good long exposure images of some of our objects that we're going to be looking at. So hold on for that later in the night. We're on M33, again, trying to get Triangulum. Should get a view soon as the clouds break up. We got a question here from By the Sea 760. What does Messier stand for? So good question. So these M's that we were talking about in these objects, like M33, stands for Messier. And Messier is the last name of an astronomer who's French. He was a comet hunter in the late 1700s. And comets were big business back then. You found a comet, you got your name attached to it. I guess they're still big business, but now we have computers doing all the looking and it's harder to find one by yourself. But Messier was looking for these comets, and as he would scan the night sky, he would see other fuzzy objects, other kind of nebulous things out there in the sky that might be a comet. And then he'd look closer and realize, no, that's just that open star cluster again. And so he decided to start cataloging these Messier objects, these things that were out in the night sky that were kind of fuzzy and nebulous, so that he wouldn't keep mistaking them for comets, and nobody else would either. So the Messier catalog, this list of 110 objects that we have, is a list of not comets made by Charles Messier, the French astronomer. So it turns out that the Messier catalog are some of the coolest deep sky objects that you can look at. So we like to look at those up here at the Godot, and there have become really cool traditions around these Messier objects, like the Messier Marathon, that you can do in March, April, in this kind of small window where you're able to find all 110 objects if you really work from dusk to dawn. All right, so it looks like we're moving to M76, the Little Dumbbell Nebula. So this is actually a different kind of object than we've looked at so far. It looks like we might not be getting it yet. Back to M33. Okay. So M33, again, Triangulum galaxy. We're going to see what we can get here, part of our local group of galaxies. Astronomers are really creative. We come up with names for things like, the group of galaxies surrounding us, like local group. It's a pretty good name. Hearing from the telescope operators that there's some nasty clouds right now that we're fighting with, but we just got M33, the Triangulum galaxy, however faint it may be. So let's celebrate. We have 9 objects now, and I am going to sign off on Triangulum. Again, that's a spiral galaxy in the Triangulum constellation. All right, so let's get a quick update here, an image for all you at home. If you're looking, we are 9 down, 101 to go. It's a little daunting, I would say. But we are looking at M76 next, back to M76 again. So again, this is a type of object called a planetary nebula, and it's different than any of the ones we've seen thus far, because a planetary nebula is actually the remains of a dead sun-like star. So a star that's around a similar mass as our sun, so kind of a not too big, not too small star, if you will undergo a process at the end of its life where it runs out of hydrogen to fuse together, and then it tries to fuse heavier and heavier elements. Kind of the interior of the star will squish down and create the heat and gravity needed to start fusing heavier elements. Meanwhile, these outer layers kind of poof off. They expand and bloat. Oop, there goes the wind again. Bloat off, and eventually are kind of blown off altogether. What's left at the center is the kind of the skeleton, I guess, if you will, of that old star. It's just a lump of matter, kind of planet-sized, not undergoing fusion anymore, but still hot, still glowing, hot, white hot from its time doing fusion. And then you have that kind of shell of gas and dust that it expelled at the end of its life, and that's being illuminated, it's being ionized by that white dwarf at the center. So planet nebulae are actually some of my favorite objects, and they got that, if you're wondering about the name planetary nebulae, it's kind of a misnomer because they don't have anything to do with planets, right? But when people were looking back in the 1700s at these objects, they didn't quite know what they were. So they said, well, they're round-ish like planets and they're fuzzy like a nebula. Nebula just means cloud. So hence planet, I think I see the little dumbbell. There it is. Okay, so we got the little dumbbell nebula. That is 10 objects. That's M76. So let's sign it off. M76, the little dumbbell. Oh, it looks like it's AKA the butterfly nebula too. I've heard some other ones like barbell and cork, because it actually kind of resembles an apple core when you look at it with these two lobes. Some of these planetary nebulae we look at, I like to think of them like a squishy Coke can, a Coke can that's been squished in the middle. Some of them we're looking at from the end, like the Ring Nebula, which is a little bit later. So you just see that circle, but some of them you're looking at from the side, and so you actually get to see these kind of lobes off of the central white dwarf. I saw someone type in moon. Looks like we're going to do some Moony McMoon face here. Oh, there it is. Let's hang out with the moon for a while, guys. So when we do the moon on this Malin cam, we actually switch from trigger mode, which is where we're taking photos with a set exposure time, to a video mode where we're actually looking live. Looks like we've got some cloudiness out there, but hopefully it'll come back soon. But this video mode is just taking live feed and streaming it to the, and on objects that are really bright like the moon, you don't need a long exposure. You can get blown out pretty easily. So it's kind of a balance here between, wanting to see the details and having the color there. And you can see the clouds coming and rolling across the moon. That's pretty cool. Those dark spots are the lunar maria. Those are remnants, or I guess you would say the scars of old effusive volcanoes. So not explosive volcanoes that like send lava high into the air, but effusive, meaning when a crater or when a meteor or something would hit the moon, it would kind of put a crack in the surface and iron-rich lava would just ooze out of these effusive volcanic areas. And that's what creates those lunar maria. The word maria means sea, because people looking at the moon in old times would think that those darker areas were actually oceans or seas on the moon. So they've kept that name, but we are aware now that, of course, they're not. There's no liquid water on the moon. So we're getting some people back here. We're back. We've done 10 objects now, so we've done quite a few, and they have been all pretty fuzzy and faint so far. So we're going to hope to get some these clouds breaking up soon and some longer exposures. We've got a question from Bruce Wayne. Does the telescope we are using tonight have adaptive flexible mirrors to adjust for atmospheric distortion? Oh, that's a really good question. So no, this lens is small enough that we don't have those adaptive optics. But at the Lowell Discovery Telescope, which is our 4.3 meter telescope about 40 miles southeast of here, we do have adaptive optics. So it looks like I'm going to be signing off here pretty soon. I'm going to give you guys over to a new host. I think it's going to be Victoria, so you'll be in good hands. And I will be making my way off to the telescopes to do some operation as well. Oh, there's a nice view of the moon. So we are going to sign off here, take a little break for a few minutes while we switch hosts. We again have 10 objects checked off, so stick with us. Come back and see what we're going to find right after the break.
everyone, and welcome. My name is Victoria, and I'm one of the educators here at Lowell Observatory in Flagstaff, Arizona. We are live streaming tonight our Messier Marathon. A Messier Marathon is where we try to find all 110 Messier objects. These are all objects that an astronomer named Charles Messier found on accident as he was trying to find comets in the sky. So he came across all these 110 other things that you can see behind me here. These are all really awesome objects like open star clusters. Right now, we've currently got the telescope pointed at an open star cluster called the Pleiades. Once we start picking up a few stars, I'll go ahead and check it off on our nice poster behind me here. We are marking these objects off as we go so we can keep a record of all the ones that we've taken images of. I do want to introduce our telescopes a little bit. So tonight we are using a 14-inch plane wave telescope, and that was generously donated by Don Neerling, the Don Neerling Memorial Foundation. So we really appreciate that donation of our plane wave telescope that we use for imaging up here at the Giovanni Open Deck Observatory. There are 5 other telescopes of the Godo, as we call it, but 4 of them are optical telescopes, so we use our eyes to look through them, and the other one is also a 17-inch plane wave that we use for other instruments. And it looks like we've got a star of the Pleiades. Yay! So I'm going to go ahead and check off M45. So there we go. It's this one here. You can see all that blue stuff around it is actually gas left over from the formation of those stars. So next we are heading to another type of star cluster. This one is called M79, and it's a globular star cluster. Globular star clusters are some of the coolest objects in general, in my opinion, because they're the old cores of galaxies, or we think they might be the old cores of galaxies. The wind is not playing nice with this sign. In our little break, it attacked me like 3 times. Okay, so globular star clusters. Globular star clusters are these giant star clusters that are made up to about 500,000 stars. Some of the larger ones, especially ones that you'll see later on in the night, like M3 and M13, are really, really big. So they've got hundreds of thousands of stars in them. And they're very densely packed. So all these stars are gravitationally bound. So they move as a unit throughout the galaxy. But now we are switching to a different kind of star cluster, so we're going back to an open cluster. This one is called M37. So open star clusters are these groups of stars that were all formed together and are now moving away from each other as they spread out across our galaxy. So we'll just wait patiently for some stars to pop up through the clouds. And I almost forgot to mention, we wanted to thank Mark and Bonnie Howard, who donated the money for the Messier exhibit in our Astrolab up here at the Godo, which is a kind of warm room area up here that we use during our public programs. And we are live streaming both on YouTube and on Twitch tonight. Oh, and it looks like we did get M37 for a brief fleeting moment. So I will go ahead and sign off on M37. There it is. Can barely see that. Ta-da! M37, yay! M36 now. So we've got M36, which is another open star cluster. There's a bunch of these all clustered around each other. They're relatively close. They likely didn't form from the same groups or from the same big nebula, but each star cluster itself likely formed from one nebula. So now it looks like we are moving on to M35, which is yet another open star cluster. And there it is! Yay! Okay, so we did M35 and M36. Boom, boom. Yes! All right, so we are right now struggling very hard. I was just the telescope operator, so I can speak to this. But we are struggling it's very difficult right now for us to actually find these objects because we have to do what we call cloud hop. So we're kind of bouncing between the clouds, but this looks like M38. Yay! M38. Okay, and I completely forgot to mark tally marks down, so I have no idea how many we're at. 1, 2, 3, 4. Okay, we just did 4. All right. So, we do have a correction about a previous question. The Lowell Discovery Telescope does not have adaptive optics, so it doesn't use lasers to control or account for atmospheric turbulence. But what it does have are active optics, which means we have a bunch of little tiny motor things on the back of the telescope that push it and keep it the same shape. So as it moves and turns, it doesn't warp under gravity because the mirror is so big that would happen. So that was a correction from a previous question we had on the but it looks like right now we are on M79. So this is that globular star cluster, and it does look like it's in the middle of some clouds right now. And it's that little fuzzball. That little fuzzball is M79. Yay! But you can see that it's very dense in the center. Yes! Yes! I'm so happy. M79 is a globular star cluster, so you can see how much more dense it is in the center. Because we think this was a core of another galaxy that the Milky Way kind of shredded apart and ate and tore the stars up and strew most of the stars throughout the Milky Way in these big streams. But yeah, these globular star clusters are really, really cool. They're these giant star clusters. M79 is one of the smaller ones, though. That being said, it still has over 100,000 stars in it. So I'm going to mark off M79. And put a tally mark down so we know how many we're down. Got another 5 objects down. Let's see, where should we go next? So we did M37, M36, M35, M38. Let's try M42, the Orion Nebula. So the Orion Nebula is one of the most prominent star-forming regions in the entire night sky. We can see some stars. Yes, we got it. So this is one of the most beautiful star-forming regions in the entire night sky. It's giant also. And it's part of something called the Orion Giant Molecular Cloud Complex, which is just basically the whole constellation Orion is full of this hydrogen gas. And like Kendall was saying earlier, the hydrogen will collect, and under gravity, it'll start forming these big balls of hydrogen gas. And that hydrogen gas eventually becomes other baby stars. And that's what's happening right now in the Orion Nebula. Hydrogen is collapsing into bigger balls of hydrogen. And yeah, it's pretty neat. So we can also try M43 next, which is right next to Orion, or the Orion Nebula. Yeah. It's actually the little fuzzy part. We can actually get it often in the same field of view as the Orion Nebula. Looks like there are some clouds right now. So this is what I was saying before about how we are dealing with some clouds up here right now. So we're having to kind of jump between them. And it looks like that fuzzball is what we're looking for. So that little star with the gas surrounding it, I'm thinking the picture is going to get better soon. But that little star with the fuzzball surrounding it, there it is! Yes, we got it. So you can see the Orion Nebula up towards the top of the screen. That's the Great Nebula in Orion. And the little fuzzball underneath it is called Marian's Nebula, or M43. So I'm going to check that one off. Okay, now I have to 1, 2, 3, 4, 5, 6. I missed something. M77. Okay. So now let's go back to the Pleiades. And fingers crossed we'll be able to get some stars out of the Pleiades. There it is. There's some stars. So these are some of the Pleiades. The Pleiades is actually, as a whole, too big to fit in the field of view of our telescope. It's much more suited to something like our TEC telescope at the Giovanni Open Deck Observatory, which is very good at wide field. So we often look at things like the Pleiades with our TEC telescope because it has such a wide field of view. But that one just has an eyepiece on the end of it, no camera, so we can't show you guys the images that we would have through the TEC quite yet, or with this setup. We have a question from Tom Palaikis. Were we able to get M74 and M77? And I believe we were. Yes, we did get both of those. And we've got a question about how much laser power and at what frequency and duty cycle do those artificial guide star systems use? And I have absolutely no idea. I have no idea. So if any of my telescope operators have any inclination of how big of a laser we use for those adaptive optics systems, that'd be great. Okay, and we did get M45. Cool. So now let's head to M78. This is a reflection nebula in Orion. And it was actually discovered by Charles Messier's assistant, Pierre Messier. I think I'm saying that right. I'm not sure. The interesting thing is it has about 45 T Tauri stars, which are young variable stars that are before they've left or entered into the main sequence. So these stars are very young and they're variable stars, so they're changing their brightness and things like that. They haven't entered into the main sequence. So there's this graph that we often show in astronomy called an HR diagram, or Hertzsprung-Russell diagram. and that's where we plot the temperature and the brightness of stars, and we show, oh, it looks like we've got something, a little nebulosity in there. Yeah, maybe if we up the exposure a little bit more. Got a break in the clouds. So again, this is M79, which is a reflection nebula. So it's it's a nebula that's reflecting the starlight around it. The stars aren't like energizing the gas, but the light is reflecting off the gas. So we will call M78 good. Alrighty. Looks like it's clearing up again a little bit for M78. Yeah, you can definitely see some nebulosity in there. And clouds. Of course, we've got clouds tonight. Alrighty, so let's try something else at the moment. We'll do M1. So M1 is the first object that Charles Messier listed on his big list of objects that are not comets and therefore boring to him. But it's also the first object that was connected to a historical supernova observation. So this was actually observed, the supernova was observed by mostly Asian astronomers in the year 1054. And they saw this bright star that just appeared one day in the sky, stayed for several months, and then disappeared. And they had a lot of record, but they had a lot of records of this guest star, as they called it. But they had no idea what it was. Nowadays, when we look at that same spot in the sky where they recorded that guest star being, we see this big nebula, and which we call the Crab Nebula. And it was coincidentally the first object on Charles Messier's list because it looks like a big fuzzy thing, and so he originally thought it was a comet. Right now we're seeing clouds sweeping through the image. Maybe if we up that exposure a little bit. Crop. And a cloud. So, sorry, I'm losing my voice a little bit here. Whew. I'm losing my voice. Oh no. So, we are going to hang out here on M1 for a little bit. And see what we can see. We also can try a couple of clusters of stars, like M41. So M41 is an open cluster of stars. So these are these stars that all form together and are now moving away from each other as they spread out across our galaxy. So these are open star clusters, and it looks like we've got a couple stars on this one. We did for a second there. So these open star clusters are all stars that form together from the same nebula and are now spreading apart from each other as they move across our galaxy. So each star is trying to find its own happy orbit around the center of the Milky Way, And in doing so, they spread out and they sort of like find their own way. So they're kind of like, so they're kind of like kittens, I like to say. And they, there they are, stars, yay! But these stars are all moving away from each other. And Kendall has brought me water, God bless her. Okay. Okay, now that my voice is back, we're gonna head back to M1, so that's that supernova remnant, which is a big cloud of gas left over after a big star explodes. So only really big stars will actually explode. Stars like the sun will fizzle out into those planetary nebula, which we saw one of earlier. And am I seeing something in the Crab Nebula? Maybe? There it is, kind of. The moonlight is not our friend tonight. Normally we love looking at the moon, but not when you're trying to find something really dim that's right next to the moon. And M41 was the one we got. So, we are trying to pull out the Crab Nebula from the surrounding moonlight and clouds. So both of either one of those things are bad enough on their own, but it looks like we've got a little bit of the Crab Nebula, maybe. It's there, but very faint. There it is. So that little fuzzy spot in the middle there, that's the Crab Nebula, or it was the Crab Nebula, which is the remains of a big star that exploded and left its guts out in space. Oh no. So this is about the best image of the Crab Nebula we can get tonight. I urge you to go look up the Hubble images of the Crab Nebula because they, of course, don't look at it when it's right next to the moon. And they can see it in incredible detail. You can see these like filaments that like kind of arc towards the middle. Yeah, it's a really incredible object. We do have a couple of questions on Twitch from It's Charlie Allen. We have, what telescope are you guys using tonight? We are using our 14-inch planewave telescope at the Giovanni Open Deck Observatory located in Flagstaff, Arizona. This is a telescope that we have here for public programs, so we generally use it for our public education programs, whether that be things like this or actually inviting people up in more normal times, so not during COVID. I've also got a question on YouTube from Paulette. I'm going to butcher your last name, I'm very sorry. So how does this work? Are you just starting with M1 and going down the list or what? No, so we don't do them in order, in numerical order, because they're kind of scattered across the sky, and they follow kind of a different, so we follow a different order. We follow them kind of as they're setting in the sky. We try to grab those ones early on, and then we go out and around and find other ones that we can throughout the night. So it does take from dusk until dawn to get all of them, but we don't do them in numerical order. So we have to follow their right ascension through the sky. So we did have M93 there for a minute. Looks like there's some clouds. And I was neglecting the chat. But we did get M93, so I should check that off. We've got a comment about why was that the best picture we could get of the Crab Nebula. Unfortunately, tonight, the Crab Nebula, which is already a very dim object, is right next to the moon, which is very, very bright. And so the moonlight is kind of shining all around the area of the sky nearby the Crab Nebula, and that makes it very difficult for us to get a picture of the Crab Nebula itself. And we've got M93 again. So the good news is a lot of these open star clusters like M93 will shine beautifully through the clouds because they're just stars. So we can see them very well through the clouds. We are now heading to M46, which I believe is another open star cluster, but let me check. And it is an open star cluster. It is one of the few Messier objects that was actually discovered by Messier. It has about 500 stars in it, but about 435 times the mass of the sun. This one is really neat because there is a planetary nebula in this field of view. We can't quite see it right now with this exposure, but there is a planetary nebula within the same field of view. So if we up our exposure a little bit more, you might be able to see this little circle. And that is actually a planetary nebula that we don't think is within the same within the cluster because it has a different radial velocity. So it's moving around the galaxy at a different speed than the cluster. There it is, that little, but we did get 46. And Soft Spun on Twitch left a very nice comment. Thank you. I appreciate it. But yeah, we've got that tiny little planetary nebula. Sign attacked me. Alrighty. That didn't happen. You saw that. So, and it is also very windy up here tonight. During the spring and the fall, it's always very, very windy in Flagstaff. I don't have Kendall's background in meteorology, so I can't tell you all the specifics of why it is. But it's very windy up here in Flagstaff this time of year. And yeah, and I'm sitting next to an open door for some airflow. So because I'm not wearing a mask right now. Yeah, my sign keeps blowing over and attacking me. But next we're gonna try and head back to M42, which is the Orion Nebula. It's one of the most star-forming regions in the sky. But it's so it's one of the most beautiful objects in the sky, and there it is. Now we can see a better image of it, and we can start to see some structure in the gas and dust around it. So you can see some of the gas around it even. That gas is being lit up by those stars in the middle, which we often call trapezium. Here they're kind of blurred into one because our exposure is high enough that they all kind of blow out. Yeah. It's a big cloud of hydrogen gas that is making baby stars. Looks like on Twitch we've got a poster attack counter. Poster 5, educator 0. I think I knocked it over once, so maybe educators won, but we're still losing. Looks like we have been clouded out of the Orion Nebula. The clouds said, nope, not tonight. But we did get to see a good image of it for quite some time. Let's see what else we can grab. So we got all the ones that I had listed. Let's see if we can go to something like the moon, maybe. So the moon is always beautiful. And we've got a question from John Larson. And with the moon near M1, does it affect how well you can see it? And the answer to that is definitely yes. Our picture of M1 tonight was not the greatest because it is right next to the moon. So the moon is very, very bright. You can see we need a very short exposure time. Our operator is actually lowering the exposure time so we can see the moon very well. But yeah, it does affect how well we can see it. Just because it's so close, the moon is lighting up the sky all around it, which makes it more difficult to see dim things like M1. M1 has a pretty low surface brightness, if I remember correctly. So it's brightish, but it's spread out over a bigger area. So it's very dim, basically. So we are ahead of schedule. I need to make sure I've marked all these. So we saw M35 through M38 earlier. We can head back to one of those. So we can start with M35. Okay. Okay, I'm all caught up. We're keeping a count of how many objects we've so we've got a question on Twitch of off topic, but how does the term nebulosity refer to the state of being cloudy or something else entirely? You're correct. It does refer to just being cloudy. So nebulosity kind of refers to like the haziness around something, or like general haziness. But yeah, cloudiness is good. We do have a request from By the Sea 760. We've got Mars, so we can definitely head over to Mars. Mars is another one of those objects that's awfully bright compared to a lot of other things. So it punches through the clouds pretty nicely. And there is Mars. It is tiny, so we can zoom in a little bit more on it. There's Mars. So you see it jumping around on the screen. That's because of our atmosphere. So there's a lot of movement in the atmosphere, and the atmosphere is kind of wiggling around. It's like a bowl of water. When you like set it down on the table and it like wiggles and jostles. So like if you have like a penny at the bottom of a swimming pool, it looks like wiggling, or it looks like it's wiggling around. But that's just because the stuff between you and the penny at the bottom of the swimming pool is moving around. And the same thing goes with our atmosphere. So it's not that Mars is actually jumping around back and forth like that. It's moving slowly through the sky. but it's stationary in the same spot for our purposes. And it's just moving around because the stuff between us and Mars, the Earth's atmosphere, is moving around. So, yeah. I do want to mention that we are streaming on both YouTube and Twitch tonight. So if you're with us on our YouTube channel, you can also pop over onto our Twitch channel, and we can see you there as well. It's the same stream, but through 2 different avenues. So if you like Twitch, you can subscribe to us on Twitch too. More Lowell all the time. Yay. And it said, according to our counter, we've got 23 objects. I have 22 listed. So where did I lose one? And 1, that's what I forgot. There we go. Alrighty, so now we can head back to M35, just to recap on what we've already gone over. We can go back over them. We've been really trying to make sure we get things before they cloud over, or in between them being cloudy. So we've been hopping around between lots of different objects. So we're going to work our way back through some of those open star clusters. There are some stars. You can see how zoomed in we were for Mars. Now, M35, I believe, has 1 star in it that is more red than the rest. Never mind, I don't think it's M35. I think it's M37. But this is an open star cluster. It's in the constellation, and it's about a little over 3,800 light years away. So the light we're seeing actually left those stars almost 4,000 years ago, and has been traveling through space ever since then, just to hit our CCD and get trapped in there, and then go through some cables, and through the magic of the internet, it's there on your YouTube screen or your Twitch stream. Yeah. I think it's pretty incredible that this light has traveled almost 4,000 years through space just to go through a bunch of other cables and the internet, and you're seeing it on your TV screen or your laptop screen or your phone screen or something like that. That's always mind-boggling to me. I think it's equally mind-boggling when that light just hits your eyeball. And that is that's just really, really cool. Sorry, this is not a CCD. It is a CMOS detector. So it is not a charge-coupled device. Sorry about that. So we are on M35 right now. Let's head over to M36. We'll do them in alphabet or in numerical order, not order. But there's a bunch of these star clusters all right next to each other, so it's kind of convenient. Telescope doesn't have to move much. But this telescope also moves very, very quickly. They're actually fast enough to track the ISS from horizon to horizon, and the ISS will move from horizon to horizon in a couple of minutes. So these telescopes are really fast. But this is M36, another open star cluster. So again, these open star clusters are these big regions of stars where all these stars form from the same big cloud of gas and dust, and now they're all moving away from each other. So all these stars all formed together, and now they're all spreading apart. Each star is trying to find its own happy orbit around the center of our Milky Way galaxy. So each star is trying to make its way around the Milky Way, but they're all going to do that in a slightly different way. So all these stars end up all the stars end up moving away from each other. So I always liken them to kittens because you start off with a bunch of kittens. Like, you never have just one kitten. You always have like 20 or something like that. And as cute as they are, you can't keep all the kittens because it's way too much for one person to handle. So you start, selling them to people, giving them away. And you end up like kind of spreading them out. So that's how stars are like kittens, I like to think of them. We've got a question from Hannibal on Twitch. Are we going to be able to see the ISS? No, unless something really strange happens. But generally, the ISS is visible earlier on in the evening. As the geometry kind of works out, where like you're here on Earth, and then the ISS is above the Earth, and the sunlight has to be like only so far away for it to catch the ISS. But it does pass over the Earth, or it makes an orbit around the Earth about once every 90 minutes. But the best chances for seeing it are earlier on in the evening, where that whole geometry works out a little bit better for you in your favor. So no, we're not going to be able to see the ISS. There is an app put out by NASA, I believe, called Spot the Station, and you can download it onto your phone, and it'll use your GPS location to actually figure out when a good time for you to spot the ISS would be. And so it'll tell you, like, hey, in Flagstaff, you'll be able to see the ISS on this night. And it'll tell you, so you can actually go out and look at the ISS. It's a pretty cool thing to see. I always like to wave, because those are the only humans who are not on the surface of the Earth. There's generally about 6 of them. You can also go to my favorite website, which is howmanypeopleareinspaceriightnow.com. And it will tell you how many people are in space right now. But looks like we're getting some clouds in over M36. So let's try M37. They are all right in the same part of the sky. So might not do us too well to move, but we'll try. There it is. What a nice open star cluster. So this is the one where one of the stars is actually a little bit red, and so that means it's probably an older star. But these stars are likely very young, and they all likely formed together. So that red star in front of it might actually be literally in front of the cluster, not a part of the cluster itself. But it looks like we're zooming in on that red star. And it looks like we're getting a little bit of clouds in there. But one of those stars is slightly more red than the others. It's difficult to tell with the clouds passing through, but oh boy, looks like something's moving. So that was probably just our atmosphere. Alrighty, so as a little recap, we went through a bunch of open star clusters, and we're going to take a break for about a couple more minutes. I do want to thank you all for tuning in, especially those of you who've been here for a while. We appreciate you tuning into our stream tonight. We're having lots of fun with it. Yeah, we're having a blast up here trying to find these Messier objects. We've been largely successful. We've got 23 down. I can't do mental math. We've got some more to go. But we will be here until about 6:15 in the morning, Arizona time. So you may have to convert that to your time zone. That'll be about 9:15 on the East Coast and about 6:15 on the West Coast. I do want to thank our donors again, including the Don Neerling Memorial Foundation, who donated the 14-inch PlaneWave, the Mallencam Company that donated their Mallencam camera that we're using tonight, and Mark and Bonnie Howard, who donated the Messier exhibit in our astrolab up here at the Giovanni Open Deck Observatory. So we are going to take a little break here, and we'll be back in about 7 minutes or so to bring you more Messier objects. Thank you, everybody, and have a great rest of your night.
everyone. Hi, I hope everyone's having a really nice evening here at Lowell Observatory. Here at Lowell Observatory, we're on our third hour of the Messier challenge that we're doing here. This is our continuous of our 12-hour live stream that we're doing. I hope everyone is doing a good evening. I hope everyone's having a really good evening tonight. We're going to continue with more of the open star clusters. So currently, right now, we have it on M47 right now. So speaking of open star clusters from Victoria, these are more like stars that left their little like stellar nurseries, and they all come from the same forming gas region they were in. So these are like stars that are pretty have an open size distance to each other. They're close, but they're not super close, you know? So we have our first object for this part of the hour is M47. I did forget to introduce myself. My name is Catherine Turrentine. I'm an educator here at the Lowell Observatory here in Flagstaff, Arizona. It is a little chilly. We've had a little bit of wind, and cloud coverage has been covering the area, and but it's starting to get clear. Hopefully, let's cross our fingers because we love clear skies. And so we're at M47. We're at M47. I'm so sorry. We're at M47 right now. I think we're gonna go back next to our next object. Our next open star cluster is gonna be M50. So this is going to be another open star cluster that we're going to be going to. Is called M50. It looks, again, it's another open star cluster that, there are stars that are kind of far. They're, super young, more young stars. I would always call them the young teenager stars that are trying to fit in, about to maybe go their separate ways, you could say. Also, we do have a question from our YouTube from Jeff Hall, who's our director here at Lowell Observatory. We do have open star clusters. We're going to have little open star clusters maybe around 11 or so, 11 later in the evening. So, sorry, globular. I'm so sorry. And so we have another, look at M50. M50 looks so awesome, looks so pretty. There's so many stars you can point out to. They're so they're very spread out. They would have a little more of a distance, or have their orbital distancing to each other. So our next object I think we are going to be going to is M44, which is one of my favorites, is the Beehive cluster. So this is a pretty big open star cluster that we have that is visible out in the night sky, but we'll get a good portion of it. We're waiting a second just to filter, get the object. Oh, there it is. It looks so good. This cluster of stars is in the constellation of Cancer, which is kind of in the middle of the constellation. And in the middle of the constellation it's in the middle of the constellation, and it has such a big, wide field of view to it, and we can only capture maybe a little bit of it at a time, only a little bit of the cluster because it's so big out there. And we've done a few objects so far. I'm going to check them out. I think we started our first one with M47. Let's check that off in our wonderful Messier chart that we have. Ooh, let's go to M47. We can check that off. It's a beautiful open star cluster. The next one I did was M50. Let's jump back to M50 right here and sign it off. And again, one of my other favorites is going to be Beehive cluster. gonna go again to a different type, to another type of open star cluster. It's gonna be M48. We have right now, we're slewing the telescope to M48. Give it a second because the telescope just moved. Ooh, looks like shooting stars. Oh, there it is. M48, look at that. Look at that happy little cluster out in space. It looks so good. I'm so glad that it cleared up. It's been clearing up. We're really excited up here because we want to get every single object down here. So look how pretty and distant they are from each other. Ooh. Maybe we can pull out maybe a couple colors out. I can see it's, maybe try to get some maybe blue. So far what we've been doing since we've started this stream around 6:45, we started at all the evening. We wanted to get a lot of the evening stuff and to get logged in for the evening for any Messier objects. We got we wanted to get some final fall objects this evening. Like we got Andromeda earlier this evening, and then the Orion Nebula, because now winter constellations are slowly coming back. So they're slowly setting in for the season, but they'll come back at the end of the year. But we'll see them again. But ooh, satellite. Look at that. Oh, we got a little satellite in the photo. How cute. Oh, there it goes. You see it down on the low. Could be a little spaceship, maybe. Ooh, who knows? Ow. It's just like, woof. Ow, it's just going. This is like going and going. It's pretty slow. Yeah. It's pretty, yeah. It's just pretty hanging out. That satellite is just hanging out on the bottom of the cluster. Look at that. Oh. So maybe let's get a little time. Let's talk about a little bit the moon. Let's go back to the moon from earlier. Ooh. So we're going to the moon. So we're going to change up to a video mode right now that we have on, because we were at more of a trigger mode to take more photos with a longer exposure, because the moon is so bright. We want to get very, 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 some good details of the moon. We love, the moon is very pretty. You can see the Maria and then the craters of it. It's at a first quarter phase right now. Speaking of the moon, a little bit about the moon. The moon has important observatory with our 24-inch refractor telescope, which is our Clark telescope here on the hill. And so back in the 60s, we did do some moon mapping here with the Clark telescope for the Apollo missions, because we wanted to get people wanted to study the moon and what's the best spot to go to the moon on. And so the moon, we did a lot of moon mapping up here in this area, because the Clark telescope can get a really beautiful view of the moon, one of my personal favorites. And speaking of hopefully the moonlight, when we got M1, which was the Crab Nebula, which was the Crab Supernebula, we probably want to go back to it, because it was a really rough, it's a very faint object right next to the moon, and so it's very not the best ideal to take a picture of it so close, but let's try to get back to it and see if we can see more nebulosity to it. Oh no, maybe it's the moonlight. Let's hope. Oh, I can see something in there. You see it? So we have the evidence of that supernova that's out. So this star exploded in like around in the 1050s in 1050, and so all this light came to Earth, and this nebula was like super like visible to the sky, visible to us. We could see it. It was mentioned that astronomers could see it for about 3 weeks or so, and it was visible during the daytime sky. And like this was before telescopes. Like that's, if you saw something like explode in the sky, I would like kind of like freak out myself. That would be like, oh no. This looks so awesome. I love it. So this is M1. We're back at M1 today because this is called the Crab Nebula. And this is the first Messier object that is logged on the Messier catalog that I have right behind me. So we have a giant one of these that is out in Argoto because we are here at the Geovalley Open Deck Observatory at Lowell Observatory. And so this exhibit was provided by Mark and Donnie Howard, who provided this really awesome, like big, picture, big, nice scale of the Messier object catalog. And has every single one. There's 1 to 110. Starting with our wonderful Crab Nebula that we have up here that was logged in by Victoria, and then one ending at 110, which was logged by our Kindle. So now we're gonna end up with we ended up with open star clusters that were so beautiful in distance. They're young, hanging out there in space. Now we're gonna head to galaxies. Galaxies, they're out of this world, I would say so, Talk about a galactic adventure. And so this one we're going to sorry, that's not it. Sorry, I got it mixed up. So we're gonna go to another one more open star cluster. It's gonna be M68, M67. And so look at that. We got one more awesome open cluster of stars. Look at them. They look so happy. Looks like we see some like color detailing with maybe some like maybe blue and some yellow out there. And so this one, an M67 it's logged as one of the oldest open star clusters out there. From estimates, it could be about 3 to 5 billion years old. Look at that. Looks so good. Looks so happy. You can kind of see some like yellow in it too, and like maybe some blues, more some of the younger stars. So now we're gonna go to galaxies that I promised everyone. But I have to log in M67 really quick. Probably one of our final little open star clusters, M67. Here we go. So now we're going to be starting with a galaxy. We're going to be starting with M81, which is called the Bode's Galaxy. We're hoping to get a more longer exposure of this because it is a galaxy and it's pretty far away. This galaxy is about 12 million light years away. And a light year is just how much light that travels in 1 year, and talk about in just, 15 times million. That's really long. Talk about a really long, commute. Oh, look at that. It looks so good. Looks so happy. So M81 is a little spiral galaxy that's located in Ursa Major. And so it also has a friend that we're going to be going to. Oh, look at the spiral arms. Oh, it just looks so happy. You can like give it a hug or so. It looks just like spiraling out in the pic. Oh, looks so happy. Space is cool. I like space. It's really, happy. It looks like, mysterious. And so we're getting a little 20-second exposure. Let's see how we can get more details of these arms. Oh, look at the core, and like you can say the galaxy. You can see the arms. The spiral arms look so awesome. We get some really, really nice detail of this galaxy. This is awesome. So the next galaxy we are going to, this galaxy is actually kind of next door to it. And so this one's going to be the Cigar Galaxy, or Bode's Nebula, you could call. Let's head out very, very soon. Oh, let's maybe do a few more seconds on this galaxy just to get an awesome, awesome picture of it. Let's see. Oh, there it is. There it is. Look at it. It's so happy and so like spirally. Next one, we're actually going to go next door, called M82, which again is called the Bode's Nebula or Cigar Galaxy, and it's going to be very different than our spiral galaxy that we're seeing here today. We're going to get a lower exposure picture of it, and then work our way up to get some more details of this object, because first we want to get an idea. Oh, there it is. There it is. Oh, look at it. It looks so pretty. Look at that. You can see the colors of it. It's on it sideways. And so it's a pinnacle galaxy. So it's like hanging out like right here. And so, again, this galaxy is right next door, like right next door neighbors to M81, which is the Bode's Galaxy. And so they're estimated about 15 million light years away from each other. And so we're going to check these two little guys off. They look absolutely wonderful this evening, and the sky is just looking way more amazing than during sunset today. We're going to check these off. Look at we got M81. Let's check him off. M82. And now we're going to head to our next galaxy we have a couple more galaxies. So we're going to be heading to M65, which is starting to become, this will be in the Leo triplets. This is in the Leo galaxies. These are in the Leo constellation. And so they're kind of more of a cluster of galaxies that are hanging out. It is a wonderful time for galaxies. You can see so many different galaxies out there. Oh, these are just pictures that are overlapping right now with the Cigar and M65. Oh, what telescope that we are using? We have the wind. No wind. It's a little windy because we have the doors open right here. So we are using a 14-inch plane wave telescope. That is right here at the GeoValley Open Deck Observatory here at Lowell. And so this 14-inch telescope is taking some photos of it. Nice picture of this object, and it was donated by the Don Meerling Memorial Foundation. So we're using a Malley cam, which was donated by Malley. And so we have that little corner guy is going to be our next galaxy that we're going to be talking about. So that's M65, and then we have M66. They're right next to each other, and the image is probably inverted in there. We're going to give it a couple more seconds, but they are very, very close together. They're like, little next door. Oh, looks like there's 3 galaxies, but there's the pictures are just overlapping each other. Looks like there's kind of a satellite, but that's just a star. And so we're going to wait. And let's see. Oh, looks so pretty. I love it. I love it. It looks amazing. So these 2 galaxies right here they're M65 and M66 are they're about, I would say maybe a short distance of 35 million light years away. That's a little bit of a short commute in galactic terms, maybe. And so this is another kind of it looks like kind of a spiral galaxy. We have the core out in the middle, and so we have the arms kind of surrounding it. It's like kind of on its side. just hanging out. There it is, just like on its side, you know, maybe when it wants to go on vacation one day. So we're gonna maybe talk about some other objects. Maybe we'll go to some like maybe binary stars too. These galaxies look so good. They're like little, you can see the cores of each one. There's so many different stars. So many stars in these galaxies, because you know galaxies are made out of stars, and they're, you know, this is out of our galaxy, but we're seeing these. I love them. So we're gonna give it a few more seconds to get a more clear picture of more. Let's kind of see some more blue in the galaxy. We're just adjusting a few more settings in it. So speaking of which, I will log these down. We have M65 and M66 of part of the Leo triplets, but the third Leo triplet galaxy is actually an NGC number, which that means it's part of the new general catalog. And so the new general catalog is you know, range of so many different, there's a lot of galaxies in there. But we are going to go to a third one, NGC 3628, just to, you know, get off the little Messier chart. But we are going to go back to Messier objects, of course. We're going to log those two objects right that we have here. We have M65 and M66. You can execute order M66. Ooh, now we're going. Look at that. We have to give the camera just a few more seconds to get the picture out and show like more detail of the object. Ooh, it's like on its side. Ooh, ooh, this is nice. Look how pretty it is. You can kind of see the core of the galaxy that's like this like really, really like the kind of that bright object, and like you see, you know, the edges around it. Okay, so I do have a Twitch question. We are streaming here on Twitch at the same time here on YouTube and Twitch, so feel free to ask any questions that you like or any comments. And so we do have a question about what is a plane wave? What is a plane wave telescope? So it's actually just the company that is the company of the telescope that was made out, company that was from. And so these plane wave telescopes, we have a couple on campus, and they're really nice. So it's the manufacturer of the company that, you know, created these plane waves, these telescopes. So this telescope is a CDK correct Dale Kirkham telescope, and so this is using it has a corrective lens and two mirrors to it, and so it's using mirrors to bring in the light from the object that is super, you know, probably really far away or super close, like Mars, for example, and it focuses into the telescope. But we are taking pictures using an instrument camera called Mali. So Mali helps us take photos of like NGC over here, hanging out here. Oh, looks like there's like, looks like wind turbulence out probably in the atmosphere. Looks like kind of stars that are hanging out. So our next object, we are going to be going to a binary star called a different type of binary star, just to look at it, what it looks like. And we're heading out to our next, this kind of type of binary star, which is in the constellation of Cancer, it looks like, on the right up kind of above the M44 that we were looking at earlier. Actually, now we're going to go back to a more video mode to get more kind of a longer, you know, like a live view of what's going on right now. So it looks like we have a kind of big, a really, really massive star, and then a little small blue one. So these are kind of like a binary star. So this is a binary star system that is two stars that are kind of orbiting around each other, and they are orbiting around each other out there in their little system that is probably really, I don't know how many light years this is away from us. I would probably estimate maybe in the 500s or maybe up to around the thousands. So this must be kind of like close by to each other. And so looks like kind of that massive star is maybe a younger one from just looking at it. And so we have, you can kind of see like kind of the gap between the big star on the right, or the big star, and then there's like kind of a bluer one on the lower side of the star. Look at his little buddy. You're just hanging out. So speaking of which, a lot of star systems do have like binary system. They have like, companion stars to them. And so our closest star that is about 4.2 light years away, Proxima Centauri, actually is like has 3 stars in them, which is kind of weird. It's interesting how our system, our sun is just one single star. We have the sun. We love the sun. The sun gives us energy in life. We need the sun every single day. The sun is gorgeous, but obviously don't look at the sun because the sun is super bright. You don't want to burn out your eyes. But there are safe ways to view the sun too. Look at it. They're just hanging out. Look, you can kind of see the twinkle of like a little star. Looks so small. Yeah. So we logged to recap from this, so far, we logged down some open star clusters around Beehive, and then we went to like M47. We did the Bode's Galaxy and Cigar Galaxy, and then we just did earlier was in two galaxies of the Leo triplets. I'll see the third Leo triplet star too. We're going to go back again to one of the fan favorites here at Lowell, is M42, the Orion Nebula. It's really pretty. It's a star-forming region out in the constellation of Orion, and it's kind of on the lower side. It's on the bottom side of of Orion's belt. It's around where Orion's shield is. And so you can kind of see maybe the for the surface. Oh no, we have word that a cloud just passed by. We've been having a little bit of interference so far, which is, the clouds, they like to do what they do, It's just the life in the astronomy world. You have clouds, bad weather, but up here in Flagstaff, it gets really nice and really clear. The scene, which means like perfect, like nice, atmosphere conditions, so we can see some more like objects pretty clear, and then see some faint stuff out in the distance. And so up here is really sunny and dry, and so it makes perfect atmosphere, perfect viewing for like stars and such, and like seeing galaxies and the nebula. Hopefully, maybe we can see. It's okay. Maybe we can get back to it very, very soon. And so I did mention we are here at the GODO, which is it stands for the Geo Valley Open Deck Observatory. So this is a facility that is brand new. It opened up in late of 2019, and so it has six telescopes on the deck. And so 4 of them are optical telescopes that you can view like using an eyepiece and look at the Andromeda Galaxy, like different, open star clusters or globulars, which we'll go to globulars later on in this evening. And so, and then 2 of the telescopes are, again, the plane wave telescopes. These are just the company name for the telescopes. And so they're taking pictures of objects that we are viewing tonight. So we are using the 14-inch pole. We have some of the nebulosity, some of the cloud, We're getting it. We're pulling through it. We're pulling through the clouds. So we are using the 14-inch planewave telescope here at the deck. And so this is the one that's taking photos of the Messier objects that are out there. And so let's see, maybe we can get M42. M42, you know, the meaning of life, everything in the universe. Oh, I think we are getting really some bad clouds out in the western part of this southern western part of the sky right now. And so, oh, we see it. We can kind of see some of the hydrogen gas surrounding the object, and where the center of the Orion, around the Orion center of the Orion Nebula is like 4 big stars called the trapezium. And so these are like kind of 4 different stars that are like in a small little cluster together. It's really bright because we are taking a longer exposure of that nebula. And so it looks like, oh, that's there it is. Look at it. It looks so pretty. You can kind of see like the gas. You see the gas surrounding it. Looks like kind of like a bird, like, you know, flying around it. Like, you kind of, maybe there's like there's like the head and like the wings, and right below the Orion Nebula, where the cursor is actually another part of the net is M43 that we logged in earlier this evening. So this is like 2 Messier objects in one. Like, nice. It's a nice 2-in-1. It's awesome. And so we're getting really awesome detail of stars out in the gas. And so that means the clouds finally cleared out that area in the Orion Nebula. And so look. This all looks so pretty. And like, this is one of my favorite objects that I could, you know, if I could ever visit to, I would just love to take a nap there. It looks so peaceful and so happy. And so, yeah. The next, we are going to go to a different nebula just to, you know, wait for the Earth to spin. We're going to go to the Flame Nebula. It's called, if you want to get the official name for it, it's called NGC 2024. Let's go to it. We're waiting for a few more seconds for, you know, we want to get a nice picture of it, and also the telescope's fluid. Oh, there it is. This looks like I think a dark nebula. I know a little bit about this. I've heard about this nebula before, and I'm assuming that is a little bit of maybe moonlight in the area. And we have a star, really bright star next to it too. Oh, I think that was maybe a high temperature, little higher exposure, but maybe. Or the moon one. The moon. We love the moon. The moon gives us tides and everything, but the moon is a little, you know, the best time to go outside and view the stars is maybe away from like a city and there's like no moon, for example, or like a small crescent. And we have back to the Flame Nebula. Look at it. Like, looks like a flame. Aha! Flame Nebula. Aha. Nebula that looks like a flame. Flameo. And so look at that. Look, you can kind of see the dark, like, detail of the clouds, like the dark void. Oh, that little star is so bright next to it. Or cloud. Okay. Oh, yeah, that's the cloud. Yeah, so we're going to go to a star in Orion's belt, the signature Orion's belt. And so Orion is a very viewable constellation, especially a lot of people know about that constellation and they know about, you know, the Orion belt. It's a, you know, I'm going to get to see, that's where we are right there. Looks like we're going to Betelgeuse. One of my favorite stars. And also, you know, don't say the name 3 times. So this star is a super red giant. That means this star is going to explode into a supernova like we're waiting for this star so this star is about 600, light years away, about estimated about 500 to 600 light years away. So it's maybe on the span of becoming a supernova. Like supernova was a supernova replica that we were looking at M1. The Crab Nebula is one. And so we're waiting for this light to return, get to Earth, because in astronomy, you're kind of like looking at the past, like whoa. And so we're looking at Betelgeuse. So Betelgeuse, we're waiting for that star to return to us, and so to become a supernova. There's estimate maybe like if it explodes tomorrow, for example, it will take, about 500 to 600, I think 600 light years, for the light to return back to Earth. And this, the supernova is going to be visible during the day, and that's going to be, super, super like cool, like, whoa, like everyone's going to be like blown out, mind free, but it's kind of like, it'll be visible, like kind of like a full moon, especially during the day. So we are going to one of I call the Sirius stars out in the night sky. It's called Sirius. It actually is the brightest star out in the night sky. It's a very bright star out there, and it's in the kind of like neck of the of Cantus Major, which is the dog constellation of Orion. And so so this star is really bright, and so it's kind of like right next to the Orion constellation. And so a lot of people like, hey, what kind of star is this? Like, because it's so bright compared to like all the stars nearby. And so you see it, it's twinkling. Yeah. Also, so this star has a little companion called, like, I think Sirius maybe AB or so. And so this is again kind of like a little system that is out there. But this star, because Sirius is so bright, the little companion star is so dim you can only see it around like after the sun goes down during twilight. And so that's the best time to see it. I've seen it before and I was like, whoa, look at it's a little star next to Sirius, because Sirius starts to pop out around like maybe later in civil twilight, after when the sun goes down and such. And so because when the sun goes down, now the stars come out and like start to twinkle, and you can start to get love. And after when we get into nightfall, all the stars come out, and then the stars, and then the sun comes back in the evening. In the morning. Look at it, it's twinkling. It looks so cool. If anyone has any other questions or comments, or like, we are streaming here on Twitch, so we have a new Twitch channel that a couple of our awesome educators do work on, and they're going to be streaming on the Twitch channel later this evening too, and a couple awesome more educators this evening. And so we are streaming here on YouTube and Twitch, so check us out on their new Twitch channel. It's like Twitch is like cool, like people love Twitch and like people love YouTube. And so we have some awesome news. We are at 32 Messier objects. Like, we're almost 1/3 the way there. Like, that's super exciting. Like, yeah. Like, I'm so excited. Like, we're going to complete this. I'm so thrilled. So, thinking about maybe we should want to like revisit some objects. Maybe if Crab Nebula is too low, I think Crab Nebula is maybe too low, because like we want to maybe one more picture of that, or is it so too low? Oh, it's right next to right next to the moon. Maybe that next, and then do you want to go maybe next, let's say, the Mars? I don't know. Let's see. Favorite. Oh, let's go. Oh, no. Yeah, I think we're losing M1 for the evening because of so much so much of the moon. Maybe let's try and go to Mars next. If maybe it's too low, get Mars one more time for the evening. Oh, look at that. Ah, look at Mars. So we do have a question. Hello, Amanda. How are you doing? So I got asked of what's my favorite constellation. One of my favorite constellations is Orion's because it's such a prominent constellation that I learned how to really learn how a lot of things in the winter sky myself. One of my favorite stars, Betelgeuse, is one of my favorite stars out there, and I love the Orion Nebula because it's one of my favorite objects because it looks so peaceful. We also have the the Horsehead Nebula is up in the Orion constellation too, which is beautiful to see. Let's try to get Horsehead. Yeah, let's try to get the Horsehead Nebula. I think it's a kind of more of a dark nebula out there in the up part of the Orion's belt. So we're gonna give it a couple seconds to get more of an exposure picture because we want to get some awesome really nice detail of this object. So usually it has kind of a horse, kind of a horse head to it. That's why it's called the Horsehead Nebula. And that's oh, let's see. Looks like we're having some, oh, we see some of it. Yes, there it is. Look at that. Oh, you see the stars that are twinkling. It looks so you can, oh yeah, we see kind of it looks kind of the pink nebulosity out in the area region. So we're gonna give this picture a little more of a time. Little more, because especially when it comes these little faint objects like Horsehead Nebula, you want to give a picture more of a longer exposure to capture more detail to it and such. Ooh, but that's okay that we're gonna go down maybe to get a little better of a picture, but that's okay. Sometimes when learning about taking pictures of the nice sky, usually sometimes it can be overexposed, but it's a learning lesson. But unfortunately I got word we got the clouds. Gosh golly darn it about clouds. Oh, the clouds. I mean, clouds are really fluffy and they look kind of you want to take a nap, but they're just condensation water. Hopefully, maybe we can get one more photo of it. I don't know how the clouds, again, they have been kind of little fun. Let's see. Oh, there he is. Oh, you can see it if you kind of tilt your head a little bit. You can see the horse, the nose and little ears, and goes to the neck. It's just maybe a little horse that is peeking its head over a fence and stuff. But we did it. That was an awesome photo of Horsehead. So to recap, oh, the wind! No, we have the door open right now so we can have air circulation because we want to keep everyone distance and such, and so it's a little chilly. We got another photo. And so to recap, we did a little bit of To recap, we're gonna talk. We had our open star clusters, some galaxies, but we have a couple more minutes. Look at that. Looks so pretty. Look. So I think there's some more, maybe we can get some more next objects. 6 posters and 0 educators. Thank you, Hannah, for that. Look at that. We talked about a little bit of some open star clusters and then some galaxies. We're gonna go next to some more galaxies because they're all galactic neighbors. So we're gonna be wrapping up very soon. We're gonna take a really short break and then we're gonna go transition to some more galaxies, and we'll be coming in about like 7 minutes or so. Yeah, thank you.
Hey, everybody. We are back live, and welcome back to our 2021 Messier Marathon live stream. We are here from Lowell Observatory. My name is Kendall Edwards. This is my second turnaround on the hosting mic, and I am a senior educator here at Lowell Observatory in Flagstaff, Arizona. We are up here at our GODO, the Giavale Open Deck Observatory. That has 6 really amazing telescopes, one of which we're using tonight. It's the 14-inch plane wave donated by the Don Neerling Memorial Foundation that has a Malincam attached to it, which was donated by Malincam. And we are up here taking pictures of all 110 Messier objects, at least hopefully. We are on the right track so far. We've got 5, 10, 15, 20, 25, 30, 33 objects already checked off of our list. So we're doing all right. 32 says, so 32 objects, and we are well on our way. So again, we'd also like to thank Mark and Bonnie Howard, who donated the money for the Messier exhibit chart that's in our Astrolab classroom up here at the GODO. And we have a small version of that chart behind us today of all of those 110 Messier objects. And we are initialing them and checking them off as we go along all night long to try to complete the marathon, to try to get all of these objects imaged tonight. So we are, let's see what we're starting back up with today. All right, is this at M95? I can't, okay, well, we are gonna start with M95, which is a galaxy in Leo. So while the telescope moves over there, we can talk a little bit more about this galaxy. It's approximately 33 million light years away, has a magnitude of 9.7, so not very bright. So we probably will have to get a long exposure to really get some detail here. But this galaxy has around 40 billion stars, so that's quite a few. And it's a spiral galaxy, and if we're able to get some detail, they are really intense with star birth activity. So they're really producing a lot of new stars, and they're very tightly wound, these spiral arms around the galaxy's core. So this object actually is just bright enough to be seen with a pair of binoculars on a really dark night. And it's very close to M96 and M105, which we're going to get to here in just a little bit. In fact, it's part of a group. Since they're all gravitationally interacting, it's called the M96 group. So that's looking pretty good there. Getting a little bit of detail of the dust lanes around this spiral galaxy. So again, this is M95 in Leo. I'm going to go ahead and check it off here on the chart. Whoops. Hopefully I don't bring the whole thing down. This is great. Okay, so wrestling with the chart. Can everybody see that there? All right, it's M95. Let's see. Spiral galaxy in Leo. Check it off. So now let's go search for some of its companions. But first, we have a question from Paulette. How do you estimate how many stars are in a galaxy? Wow, that's a really good question. So we are able to estimate the masses of galaxies, I think based on spectroscopy. If anybody of my colleagues wants to give me a better idea of this, I'm not exactly sure. I think, based on the distance, how much star formation we see, how big the galaxy is, how wide it is, we can do some of these estimates, but there's probably also ways to determine kind of the total mass of the galaxy that help you estimate how many stars. And I'll have to, I don't know more information than that right now off the bat, Paulette, but hopefully we can get you some better answers there. So again, this one was M95, and we are going to head on over now, I think, to M96. So this one is also a galaxy in Leo. It's a neighbor, and let's see. This one we should be able to get a pretty good image of, it's kind of got really interesting spiral arms on it, weak spiral arms, and they're kind of asymmetrical because of some gravitational interactions that it's going through. I mentioned this was part of a group of galaxies that are all gravitationally interacting. So you're able to see that bright core right now, that core that consists of the majority of the stars in the galaxy. But I think if we get a longer exposure, we'll be able to make out a little bit more detail there as well. So the M96 group that I was talking about, this galaxy group, it also includes M105 and M95 and some smaller and fainter members as well. Looks like we've got a little bit of detail there on the spiral arms. That's looking really nice. I'm going to go ahead and check that one off while I'm thinking about it. M96, spiral galaxy, and a neighbor of M95 in Leo. I just wrote an M instead of a K for my name, thinking about Messier. Probably going to be dreaming about Messier objects tonight as well. And Paulette, you could probably, we have a comment from Paulette that asking if she gets points for stumping the educator. And yes, by all means, we're giving the poster points tonight for hitting the educators. I'll give points for stumping me. It's really not that hard. So my formal education is in meteorology, math. I have a degree in secondary education, but I'm just now getting a degree in astronomy. So there are a lot of things you could probably stump me with. But I am learning more every day. And it is, I see that I might have a correction that I need to make. Okay, so we're about to head over to another object since we've gotten M95 and M96. We're going to head over to M105. And so this is another galaxy. Again, this is part of that M96 group. So we'll see if we can get a nice long exposure of that one. If any of you guys were with us earlier, you noticed that we were having some issues with the clouds. So we had quite a bit of cloud cover this evening, and we thought it would break up a little bit earlier, but it kind of stuck around for a while. It's also very windy. With the coming of spring in Flagstaff, we get these high winds here. And so we're kind of feeling the effects of that. So I do have an answer, Paulette, about the how we estimate the number of stars in a galaxy. And the main way of estimating is by determining the galaxy's mass, which is what I was thinking, but I didn't know exactly how you do that. And it is by looking at the galaxy spectrum and also how it rotates. That is like kind of its angular momentum and the speed, its radial velocity and things like that. So there are ways of estimating the number of stars, and that's a really good question. All right, look at this. It looks like we've got, is that 3 galaxies in this field of view? That is looking really nice. We'll see if we can point out M105. Which one of those is M105? It's to the left there. And again, this is part of this local, or not local, but this M96 group that's within Leo, the constellation. Now, Leo is coming up right now, pretty much at the beginning of the evening, and you can tell Leo by its bright star Regulus. That's kind of like the neck of the lion, and a hook shape that's very prominent in Leo's constellations, known as the sickle. It's an asterism or a grouping of stars that is not a constellation, but is a kind of prominent grouping. So here we see M105 to the left, NGC 3384 to the bottom right, and NGC 3389 on the top right. And for anyone who's wondering about all these crazy numbers and letters, M again stands for Messier. That's Charles Messier, who is the French astronomer in the 1700s who was searching for comets, but ended up giving us this awesome 110 item long list of deep sky objects that are not comets, but objects that we really like to look at anyways. And NGC stands for New General Catalog, I believe. Just another catalog of objects out there in the night sky. So this is a pretty awesome image here. I like this one. All right, so I think we're going to move on from the galaxies a little bit. We were talking, just before we move on though, we were talking about how Messier actually didn't discover all of the objects in his catalog, or even most of them. Some of them were kind of known already. Some of them were co-discovered by other astronomers who were working at the same time as Messier. And some were discovered by his assistant, whose name was Pierre Messier, which I'm sure I'm butchering the French pronunciation there. But M105, was one of those that was discovered by Pierre in 1781, along with M96. So these galaxies that were pretty visually close to each other in Leo here. One other interesting fact about M105, again, which is the one on the left. So it's known to have a supermassive black hole at the center, which we believe that most, if not all, galaxies do have this supermassive black hole at its center. But this one is a special type of galactic center. It's called a weak active galactic nucleus. So you probably have heard of it. Maybe I've heard of a active galactic nucleus. So these are galaxies whose center, probably the supermassive black hole at the center, is very active and eating material and spitting out material. So this one is very weakly active, and it has a special acronym, which I think is funny. It's called a liner type active galactic nucleus. Say that 5 times fast. But this liner stands for low ionization nuclear emission line region. I really love astronomy acronyms. So this is this type of galactic nucleus in M1. If it's, you should probably Google it. All right. So we're going to keep moving here. Did I check off M105 on the list, though? That's a real question. I did not. All right. I get to initial another square. And we move on. All right. So the next object I think we could talk about is M40. And this one is a pretty interesting object for the Messier catalog. So you may have noticed that we have been imaging a lot of open star clusters, a lot of galaxies, and a few other things like these, like the Orion Nebula, a star-forming region, or the Horsehead Nebula. So some of these different kinds of things, but M40 is one that'll shock you. It is one of a kind in the Messier catalog because it is not really a nebulous or cloudy type object at all. It's actually a binary star pair. And so you may ask yourself why this particular pair, this binary, it's actually an optical binary most likely, which means that these two stars are not actually gravitationally bound to each other in the sight for us from Earth. So probably not a true binary pair, but still a nice optical binary all the same. But it turns out that Messier was looking through Ursa Major. So this is a binary in Ursa Major, looking through for some other nebulous objects that he was looking for and stumbled upon this pair. So I just got the heads up that there's more clouds moving in. And I'm wondering if that means we should kind of move to some other objects and come back and talk some more about M40 in just a minute. And I think we will do that. So let's hit up M97 first. Now this one is the Owl Nebula. We just don't want clouds to get in the way of us. The Owl Nebula is a planetary nebula. So we have seen one of these already at least. There's only 3 or 4 in the entire Messier catalog. And again, these are the remains of dead sun-like stars. So stars that are not too big, not too small, like kind of Goldilocks stars. And once they run out of hydrogen to fuse, they start trying to fuse some heavier elements, but these are not super big stars that are going to be able to fuse and then eventually blow up into a supernova. Instead, the core kind of collapses a little bit and heats up so that the star can begin to start fusing heavier elements like helium and on up. But it gets to a point where this core can't fuse any more objects or fuse. I was reading while I was talking. That's not a good idea. Can't fuse any more atoms, molecules together. And so as the interior is kind of squishing down, the exterior layers of gas and dust are kind of being poofed out, bloated out from this planetary, or from the center. And so what you're left with at the very end, kind of after this whole process, when there's nothing left to fuse, is a tiny little white dwarf, which you can actually see there in the middle of the picture, which is pretty cool. And then around that, a cloud of gas and dust that has been expelled from the star and is now being lit up or ionized. And that's what we're able to see here, like in the Owl Nebula. So apparently this one is called the Owl Nebula because if it's imaged in a nice big telescope, you can get these two dark patches that almost look like the eyes of the owl. And actually, you can kind of see it even in this picture here. It does look a little bit owl-like. So planetary nebulae are pretty cool. Again, has nothing to do with planets, but it's a fuzzy round thing. So we've first of all, I want to remark that we've now surpassed 1/3 of our objects, which is awesome. So we are 1/3 of the way done, and I'm going to go ahead and check off the Owl Nebula right now, which is M97 right here. I think my signature is getting worse as the night goes on. Got cold hands. Okay, we got 37 objects so far. So this is awesome. We do have a question from Christopher Dix. Please explain what a plane wave telescope is. So good question. If you haven't been watching since the beginning here, what we're using tonight is to do our imaging is a 14-inch plane wave telescope. Now, plane wave is just the name of the manufacturer. They're out of California. And this type of telescope that we have made by them is a CDK, or corrected Dahl-Kirkham telescope. So this is going to be a design that allows for optimal coma reduction and reduction of things like other visual effects by using 2 mirrors and then some lenses for correction. So it's kind of a hybrid telescope. It's on the Planewave L350 mount, which is a really sweet mount that makes the telescope move super fast. And that is powered by some gears, I believe. It's kind of on a resonance and it moves really quickly. So yeah, Planewave telescope's pretty cool. Our Planewave here, this 14-inch, was donated by the Don Neerling Memorial Foundation. We're so grateful to have it, as well as our Malincam camera that we're using to take these images. So again, this one is the Owl Nebula, looking pretty good. So it looks like there may be some clouds around a few of our next objects, but we might go ahead and try them and see what comes through. So we're going to go to M108 first, but we're going to be doing this kind of pair of galaxies in Ursa Major, M108 and M109 right now. And we'll see what we can see. So M108 has by far one of the coolest kind of nicknames in the Messier catalog. It's known as the surfboard galaxy, and hopefully we'll get to see why here in just a second once these images come up. Oh yeah, there it is. So again, we're looking at this galaxy not quite face on, and so that's what gives us this kind of elongated shape, almost like a surfboard, you may say. If you remember back to M81 and M82, the Bode's nebulae, M82 is known as the cigar galaxy, and it kind of has a little bit of a similar shape as far as I'm concerned. But yeah, that's some good structure that we're seeing there in the gas and dust. And let's mark it off. So M108 down here, wow, almost to the bottom. A spiral galaxy in Ursa Major, I believe. That's right. Check it off. All right. So we don't have to move very far to go to M109, which is going to be another spiral galaxy. All right. That's like 2 points for the poster right there. When you knock down the entire easel. Hello. All right, it's going to be all right. So we're going over to M109. Sorry about that, folks. So M109 is going to be another spiral galaxy. Again, we're still in Ursa Major, which is the Big Bear, which is part, if you know the asterism, the Big Dipper, that is part of Ursa Major. And so we can look at, probably get a little bit more detail, a little bit more zoomed in on this one, but yeah, there it is. Starting to come through. Oh, wow, there we go. The Twitch stream is saying that the poster versus educator score has become the meme of the night, and I agree. I like it. Look at those spiral arms, guys. That is really pretty. Okay, so M109, we're going to check it off. Spiral galaxy in Ursa Major, looking pretty good. Look at that tight center there, really bright with a concentration of stars, and then the structure of those spiral arms. Really nice. All right. So we are, let's see. I think we should go back to M40 for just a second, since we've gotten, I think, all of the objects that we need to image besides M40. And I was in the middle of talking about that one, and I'm going to cross it off here on the sheet. M40, again, is not like any of these other objects that we've been looking at. It is a binary star pair. So some people have taken to calling it Messier's mistake, which is kind of funny. It also has another designation as well. It's known as Winnicky. I don't know if that's how you say that, but that's how I think it said, Winnicky 4 or Messier 40. So this is, again, an optical double binary pair, so not actually gravitationally bound, but in the same line of sight for us. Messier would have seen it while he was scanning the sky for comets and other nebulous objects. I guess maybe he thought it could appear nebulous. It could be confused for a comet if you were looking for through maybe a lower power telescope. Maybe that's why he included it there. But the reason it has that other designation, Winnicky 4, is because a century later, after Messier cataloged it, another comet hunter named Friedrich Augusta Theodor Winnicky, I probably butchered that, rediscovered this object and cataloged it as a double, so two categorizations in two different catalogs. This one is pretty easy to find, although it would be very dim. But if you start at Delta Ursa Major, so the Delta star there, which is actually, let's see, yeah, and then you would want to move about a degree to the northeast. So yeah, you can find it fairly easily. We have a question that just came in from Susan Shankles. What camera are you using? So thanks for that question. We are using a Malin cam, which was donated to us. We had a Malin cam before, and it was a lower model, but it was donated. Let me start over there. Our representative from Malin Cam switched it out for an even better model for us, which is awesome. So now we have a Malin Cam DS26C Tech. So a Malin Cam, for those who don't know, is a camera or Yes, it's a camera that is attached to an instrument panel at the back of a telescope. So the light from the telescope then comes in and it exposes that camera. This is a CMOS type of camera. And then the CMOS detectors are very sensitive. So they collect all that light that's coming in, and we're able to take actually really very short exposures and get a lot of detail, and then display these pictures on our computer, or we actually have TV screens out at the Godo too that allow for our guests to see live what we're looking at in the sky. And actually, it's interesting that we mentioned that. We are going to have to take a break in just a little bit because we actually do have one of our premium access programs that is going on right now up at the Godo, and we're going to donate the Malin Cam to them for a little bit so the guests can see some of these awesome images that we've been looking at. Another cool thing that I forgot to mention about the Malin Cam is it's also in full color, which is very cool. So it's a great camera. Malin Cam is probably the top of the game in that these type of cameras that take these are able to take these short exposures and give this really cool images that we're looking at. So we got some more nasty clouds on the way, but let's see, maybe we can head over to M94 and M106. So these are in Canes venetici, which are the hunting dogs. And let's see, they are spiral galaxies as well, just like the ones we were just looking at in Ursa Major. So let's see what we can get on M94. So one interesting thing about, oh, that's pretty nice, about this constellation, Canes venetici, which I also might be saying wrong, the hunting dogs, is it's really just two stars, and one of them, the brighter one, is named Cor Caroli, or the Heart of Charles, like the King of England back in the day. So kind of interesting. So we've got that one, M94. I'm going to go ahead and cross it off the list. There it is. I wrote an M again. My initials are in fact KLE. No M's. All right, M94. All right, so it looks like we're getting some clouds maybe moving in. Once we've taken this 20-second exposure, probably move over to M106, which is a neighbor optically, and see what that one looks like so we can check another object off the list. Okay, so we're going to M106, another spiral galaxy in the hunting dogs. Constellations are funny, that you can have a constellation of like two stars that are meant to represent hunting dogs. You can do a lot of imagination there. All right, that looks pretty nice. Seeing some of the structure of the spiral arms there. Those dust lanes popping out. So we're going for a 16-second exposure now. See what that gives us. But I'm going to go ahead and mark off M106 because we've definitely got it. Oh, wow. Looks pretty good. Let's see what happens on the next one here. So again, we're dealing with clouds tonight and some pretty fierce wind. So it actually can knock around our telescope a little bit and cause a few issues. But we are right on track to complete this Messier marathon. We have imaged all the objects that we've needed to so far, even through the clouds, which is pretty cool. So we're getting pumped up. We're excited to keep on going tonight with the opportunity to actually complete the Messier marathon, to find and image all 110 objects that are part of his catalog. So that was M94 and M106. It looks like M106 is not really coming through anymore. So let us move over to M63, if that's all right. And this one is another spiral galaxy, also in Canis Venatici, the hunting dogs, but it's known as the Sunflower Galaxy. So that's a really fun name. And let's see. We'll wait just a second on that one. So this is a really nice spiral galaxy that we're going to see here. There is a big cloud in the way right now, but we're going to wait it out. But really, we're able to see kind of almost face on this galaxy, the Sunflower Galaxy, which gives it its name, seeing kind of like all the petals around the central core of the flower. Oh, still clouds. It's all right. We can also try to revisit some of these objects after the break, especially this one. We're not really getting anything on M63 right now, but I think we did pretty well on all those other objects during this period. So we are going to go ahead in a couple minutes here and take a quick break, about 10 minutes for us to share our camera outside with one of our premium access Goto groups that's up here. Sort of there, yeah. And after that break, we'll come back and keep on imaging and keep on trucking down the Messier list. I'm calling that good. Let's mark off M94. Wait, not M94. M63, I'm sorry. All right. So we're not getting a lot of detail there, but it's definitely there. And like I said, we might try to revisit that one, M63, after the break. All right. Well, thank you guys for staying with us. Keep sending us your questions, and we can't wait to see you back here after our 10-minute break. We'll be back right around 10:30. Thanks for watching. All right, thanks for sticking with us. We are back here live at the Giovanni Open Deck Observatory at Lowell Observatory here in Flagstaff, Arizona. And we are going to find, we're going to find an object right now called M64. Thought we maybe had missed it, but it looks like it will be up for a while, but might as well go ahead and get it out of the way. So M64 is a fun galaxy. It's in Coma Berenices, Berenice's hair, which is technically part of the Leo constellation. It's for a long time, well, actually, I don't know if it technically is. It's always been associated with Leo as kind of like the puff of the lion's tail. It's just this little bitty nebulous patch of stars. And it's actually the only constellation named after a real person, Berenice, Queen Berenice. Look, we got it there. But this Black Eye galaxy, which is in Coma Berenices, or Berenice's hair, was quite a few times, actually. It looks like first discovered by Edward Pigott in March of 1779. And then again by John Bode. You'll recognize his name from the Bode's Nebulae in April of that same year, 1779. And then also by Charles Messier in 1780. So yeah, we've discovered this one. The Black Eye galaxy is really easily identifiable, especially if you start to look at some of the Hubble images, because it has this kind of obscuring cloud of dust or gas that blocks out some of its bright central core. So it almost looks like this galaxy has a black eye. So very appropriate name. It also has some very weird internal motion where some of the things on the outside are moving differently than the things on the inside in different directions. So a really neat galaxy with lots of cool stuff going on. I encourage you to go look up maybe one of those Hubble pictures of this one because it's really worth it. Let's see. I'm going to go ahead and check off M64 since we have that one. There it is, the Black Eye galaxy. All right. And I had said we were going to go back to a few of the things we were doing right before the break, like M63. Let's go back and see if we can get one more good picture of M63, and then maybe we will kill some time with some other cool objects that are up in the sky right now. Let's see. So again, M63 is known as the Sunflower Galaxy, and it's got one of my favorite kinds of names for a spiral galaxy. It's known as a flocculent spiral galaxy, and that sounds exactly like what it is. To me, that word sounds like there's little like poofs coming out of it like this, and it actually is known for its star formation. It doesn't have well-defined spiral arms. It actually appears to have like these spiral arms that are all discontinuous and multiple that wind around the corner, but not the same organization, say, as like a grand design spiral galaxy. So astronomers like to study these flocculent spiral galaxies to try to determine the mechanism for star formation within them. And again, this is a really pretty one if you're looking at maybe some NASA pictures of this one, where you really can see the bright blue, hot new stars that are being formed in the spiral arms. Let's see. Oh, that one looks really nice. Starting to see a lot of structure and dust lanes. So I think we already marked this one off, if I'm not wrong. M63, we'll just double check. Yep. Okay, so that one's already marked off. And it looks like we might maybe do some stars. So we're going to move over to Castor, actually. So Castor is part of Gemini. Castor and Pollux are the Gemini twins. And they're the bright stars that kind of appear to be the heads of the twins, and you'll see their like they're holding hands and their bodies kind of go down like that. So Castor is the one that is not part of the winter hexagon. So if you joined us on any of our live streams recently, I was talking with Dr. Jeff Hall about the winter hexagon, which is a grouping of 6 bright stars that are pretty easily visible in the winter months. And Pollux of Gemini is one of those stars that we kind of trace out the hexagon with. But Castor is not, even though it's kind of its little twin next door. They are not actually twin stars. They're actually quite different, but we can see in this picture kind of how you get those little diffraction spikes out to the side. That's, of course, an artifact of how the light comes into and out of the telescope, but I think they're really beautiful. It actually kind of reminds me of like Twinkle, Twinkle, Little Star, like a diamond in the sky. And that's how we look at stars. We see them scintillating and twinkling, and that is because of our atmosphere. These stars, unlike our sun, oh wow, are we resolving a binary there? The binary? Oh my goodness, look at that. So Castor, like many stars out there, is part of a system. Actually, maybe up to like 6 stars in the system, but it looks like we're resolving right now at least 2 of those stars in the system. So that is really neat. And look at them wiggling around. Again, so stars being so much farther away from us than, say, like planets or our own sun, they come into our atmosphere as point sources of light, so almost like a laser. And as they enter the atmosphere, the gas and the wind and everything that makes up our atmosphere wiggles that light around, because it is just this little tiny pinpoint of light, and it gets wiggled around. And so it's almost like looking up from the bottom of a pool up at a light. It would appear to wiggle around, and that's because of the medium that's above you. Kind of like Vic was saying earlier, Victoria was talking about how you're looking through all of this atmosphere. So yeah, she was talking about looking at a penny in the bottom of a pool. And for some reason, I always imagine it the opposite way, like laying on the bottom of a pool, looking up at something that's outside of the water, and how everything kind of dances around and sways. So that's pretty cool. All right, so I think we've gotten pretty caught up on our objects for right now, which is really cool. So let's see, let's get a count if we can. I think we've lost track on our little tally sheet over here. We're somewhere around 43, I believe. And so that is, yeah, 43 confirmed objects out of Messier catalog, again, out of a total of 110. So we are coming up on halfway. So that's going to be awesome. We are going to take a quick another break in just a few minutes here, just to switch hosts. Victoria's coming back to talk to everybody here, and we will continue on from there, looking at some more cool galaxies. And looks like there's even a globular cluster maybe in this next set of objects. Again, globular clusters, those really dense spherical collections of stars that are gravitationally bound and just kind of weird. Don't really even know where they come from, kind of. So stay tuned for that for sure. Let's see, maybe before we go, we can look at one more thing. How about maybe the moon. Yeah, let's go back to the moon, because we haven't been there in a while. We're right around a first quarter moon, so not enough to give us real problems on some of the dimmer objects. But if we were to have waited another week, the moon would have been a big factor. And you can see that when we image the moon on this software, we actually turn from trigger mode, which is where we're taking these longer exposure photographs, to a video mode, where we're just taking really short, in the milliseconds time exposures, and streaming those live. And so you can see this is a nice kind of up close zoomed in view of some of the Maria. Those are those darker spots that are, again, kind of iron rich leftovers of the moon being hit by meteors and effusive volcanic activity from when this would have been a long time ago when the moon still had a warm core, and some of that molten rock, iron-rich rock, would come out from the inside when the moon was hit, and causing these areas of darkness, the lunar maria. And you can see really nice views of some of those craters there. And I really always like to look, when I'm looking at the moon, it's nice to look at it when it's like this, like a first quarter, so you're not blowing out your eyes. And right around the terminator line, which is that line where it turns from night to day, you really can start to get that's where you're going to pick up, a lot of the subtle elevation changes in the craters, even some of the little pin marks at the center of the crater where the dust pops back up. You can kind of see some of that. So the moon is always a favorite for sure. We have one telescope up here called the Tech, up at the Godo, that has a really nice wide field of view and pretty amazing optics. And looking at the moon through that scope, I'd say it's life-changing. You really feel like you're there. Like you feel, one of the most common comments we get from guests is that they want to see the flag on the moon, which of course we can't. If there was a football on the moon, so like 100-yard kind of football field, I think it would resolve to like 1 pixel on a really nice telescope that we would have. So not seeing things down to flag size, but seeing quite a bit of detail there. And again, Tech, it stands for Telescope Engineering Company. Again, that's the manufacturer of the telescope. Often the telescopes are named after their manufacturer. So that middle blob there, actually, that in what we're seeing on the moon there, that part of the lunar maria, is actually the Sea of Tranquility, where Neil Armstrong and Buzz Aldrin took their first steps during the Apollo 11 mission. So, yep, there it is right there. So those two areas of Maria on the left that kind of go up like that, those are kind of like the bunny ears. And then the Sea of Tranquility is in that little notch right there. And so man has stepped on the moon right there. And hopefully we'll get back there someday soon. All right, so I am going to we're just going to take a really brief break, about 2 minutes to change hosts. Thank you guys again for listening, and we'll kind of do a recap when Victoria gets back up here. So thanks again. Oh, wow. That was good. Out of your way.
Oh, no, you're fine. Alrighty, hello everyone, and welcome back to our Messier Marathon. My name is Victoria, and I'm one of the educators here at Lowell Observatory, bringing this Messier Marathon to you tonight. We are working our way through all 110 objects of Charles Messier's famous catalog. So Charles Messier was a French astronomer back in the 1700s who made a big list. He made a list of things that were not comets. You see, Charles Messier was a comet hunter, and he wanted to find as many comets as he could because this was his money-making scheme. He set about finding comets and then naming them after various French nobility, who then paid him handsomely. This worked out pretty well for him, but he also found a bunch of other things that were small and fuzzy in the sky and looked an awful lot like comets, but weren't. So he made a list of all these objects so that no other astronomer would have to make the same mistake and find these not comets and get excited only to have their hopes crushed because it's not a comet. Tonight we are using our 14-inch Planewave telescope. Planewave is the brand of the manufacturer of the telescope. At our Geovalley Open Deck Observatory here in Flagstaff, Arizona. The 14-inch Planewave is donated by the Don Neerling Memorial Foundation. We also want to thank Malencam for donating the camera that we use, which is a DS26C Tech camera, and it's a wonderful camera that allows us to take both short and long exposures. So we can get beautiful detail out of things like M51 here. We also want to thank Mark and Bonnie Howard, who donated the money for our Messier exhibit in our Astrolab up here at the Godo as well. So we are working our way through the Messier catalog up here. And right now we're going to start talking about something called galactic cannibalism. And this is what happens when two galaxies interact and they hit each other in kind of this collision. This is actually really, really common. It happens all over the night sky. The Milky Way even has a system of small satellite galaxies that we interact with. So small satellites can pull on the spiral arms with the force of gravity, perturbing them slightly, or they can actually plunge into the spiral arms of the larger galaxy and cause a burst of star formation. All in all, though, galaxies colliding is very common. It happens all over the night sky in various stages, allowing astronomers to piece together what a typical merger looks like. That being said, collision is kind of a misuse of the word, because galaxies are mostly empty space. So in general, the galaxies really pass through each other and create a bigger galaxy. If there's a significant mismatch in the size of the two galaxies, the larger one will remain mainly the same, and the smaller one will get its stars stripped away and added to the larger galaxy. Then the core of the smaller galaxy can remain as something called a globular star cluster, which we're pretty sure are the remains of old galactic cores that the Milky Way has shredded, or other galaxies have shredded. Galactic cannibalism typically occurs with at least one larger member. The other one can be smaller or around the same size. And galactic cannibalism results in something called irregular galaxies. So often we get galaxies that are kind of funky shapes. They're no longer these nice spirals. And this, of course, is happening to the Milky Way. We do have a system of small satellite galaxies that we interact with, like the Small and Large Magellanic Clouds. But we are also going to undergo a significant merger in about 4 billion years. Make sure to put this one on your calendar, folks. We are going to collide with the Andromeda Galaxy, which has about 1 trillion stars in it. We managed to get a very fuzzy picture of the Andromeda Galaxy earlier. But we are going to collide with the Andromeda Galaxy, and we're going to make a bigger galaxy. But the most mind-boggling thing, in my opinion, is that the odds of two stars hitting each other is pretty much zero. Because there's so much empty space in each galaxy that the odds of two stars hitting each other is so low. So that is one of my favorite facts ever, is that out of those 1.4 trillion stars involved in that collision, will hit each other. So right now we are looking at M51, the Whirlpool Galaxy. It looks like we've got a great picture of it. This one is smaller than the Milky Way galaxy, so it's at about 76,000 light years in diameter, whereas the Milky Way is somewhere between 100 and 150,000. It was the first galaxy to be classified as a spiral galaxy, and it's between 23 and 31 million light years away. So the light you're seeing is old. It left those stars millions of years through space ever since then, only to hit the detector of our camera. It was discovered by Messier, but he did not discover the companion. So the bright little fuzzball down at the bottom there, that's the companion to M51, as we often call it. And it's not quite, or it wasn't discovered by Messier. He just discovered the main part of the galaxy itself. 40 discovered to have spiral structure, but it wasn't shown to be a galaxy until Hubble's time in the 1920s. Radio waves showed that M51 is interacting with its companion galactic nucleus, and that interaction is likely why M51 is so active. It does have an active nucleus. The absolute coolest thing about this, though, about M51, is that there is actually a planet candidate inside M51. So we think we've discovered another planet in another galaxy that's up to 31 million light years away, which is just mind-boggling to think about because planets don't give off their own light. We have to measure them essentially by eclipses. So this was detected from eclipses of an X-ray source. So we were watching this X-ray source in the sky, and we watched as this planet candidate crossed in front of the this X-ray source, dimming it for a little bit, and then it would go away, and the X-ray source would be back to full strength, and this would happen over and over again. So this is how we discover planets. We often do it with optical light, with light waves that, like the same ones we're using to look at this galaxy right now. We often use them to look at stars in our own galaxy and try and find planets around them. But yeah, we can find a planet candidate in M51. So we do want to, or we've got a request for a negative view of M51. So we're going to invert the colors. So all the blacks will become white and all the whites will become black. So there's a fun fact about M51 from our historian Kevin Schindler. And he says that in the early episodes of the TV show The Big Bang Theory, there's a picture of the Whirlpool Galaxy in the living room of Sheldon and Leonard. And on that same wall hangs another picture of another astronomical icon, Lowell Observatory's 24-inch historic Clark telescope, which was actually used to discover the first evidence that the universe is expanding way back in the early 1900s by one of our astronomers named Vesto Slipher. He did this through a method of spectroscopy, where he would look at these galaxies and take their spectra. So he would split up the light into all of its different components, into all of its different colors, and then he would look at the spectral lines. So he knew where the lines should be, and the problem was they were in the wrong spots. This is because most galaxies are moving away from us, with the notable exception of the Andromeda Galaxy, which is moving towards us, as I mentioned before. But it's, yeah, so I forgot what I was saying. Yep, that thought has left my brain. So, next we can head on to M53. All right, I was talking about Slipher. So he found or you knew these spectral lines should be there, but they were in the wrong spots because of the Doppler shift or the Doppler effect, which happens whenever something is moving towards or away from us. And that causes the light to stretch if it's moving away from us or shrink if it's moving towards us. Another one for the poster. Alrighty, almost forgot to cross off M51. And 51. And we've got M53 too, so I'm gonna cross that one off while I have it. Yay! So this is a beautiful globular star cluster. Again, globular star clusters are these big collections of a lot of stars. So these stars we think were the remnants of a core of another galaxy. So another smaller galaxy, the Milky Way, ate up and cannibalized and kind of like sucked in and then tore apart all the stars and then tore everything apart and left behind the core of this galaxy. It was discovered by Johann Bode, who discovered M81 and M82. It's 58,000 light years away, and most of its stars are first generation stars. So these were the first stars that came to be in our universe. And the other thing about these globular star clusters is they're really old. I tried to save it. So these globular star clusters are really, really old. They're some of the oldest objects in the universe. In fact, this one is 12.67 billion years old. It also has a surprising amount of blue stragglers, which are blue stars, so they're supposed to be younger and hotter. So you've got a question on Twitch from Pandemic Watch. Open or globular cluster, how do you tell? I normally tell just by looking at them, but these globular star clusters have this kind of like ball shape, like they're a sphere of stars, and they're very, very dense in the center. Whereas a lot of open star clusters, they have less stars, first of all. Open star clusters have in the hundreds of stars. Globular star clusters have in the hundreds of thousands of stars. So you can tell by the number of stars as well, their structure. Globular star clusters will have like this little blob in the center that's really, really bright, and then they kind of spread out around it. Whereas open star clusters are kind of like just like a smattering of stars, which are also really pretty. We are going to go on another quick break here in a couple of minutes. So right now we are doing our premium access programs, and we'll continue doing those nightly or at night until April 26th. But starting on April 2nd, we are moving into our phase 2 of reopening, where we will actually have guided tours, and we will start slowly over the month of April, increasing those guided tours throughout our campus. So take a look on our website and explore a little bit more about those programs if you're interested. We also do have premium access programs at our Dyer telescope, which uses a similar type of telescope to the one that we're using tonight, only it's 10 inches bigger. So it's a 24-inch plane wave telescope with an eyepiece on the end of it, not a camera. And so that will continue indefinitely, but we will end our GOTO premium access in April. That does mean, though, that the GOTO will be open for those tour groups that I mentioned, and so we'll have guided tours that go through the GOTO, and you're able to look through all the telescopes, weather permitting, of course. So, let's see here. Yeah. We're going to break, and we will resume with more fun objects. Alrighty, everyone, welcome back. We're back from our short little break. But now we are looking at another globular star cluster. This one is M3. So you can see this one is a little bit bigger and brighter than the other one we were looking at before. This is the third Messier object in our list of objects to check off tonight. It is a globular cluster in the constellation Canis Venatici, and it is actually the first Messier object that Messier discovered himself, though he studied any stars. I think that could not be any more incorrect. This is, in fact, a whole bunch of stars with no nebula. In fact, there's a large population of variable stars in this cluster. There's 274 of them, out of up to 500,000 stars. It's also 11.4 billion years old, almost 34,000 light years away, and a little over 30,000 light years above the galactic plane. So that means this thing probably did not originate within the Milky Way, because it's so far out of the plane of the disk of the Milky Way. Like I said before, these are probably the cores of other galaxies that the Milky Way has torn apart. So we've taken most of the stars out of this other small galaxy, and what's left over is just the core. And that's what this globular star cluster is. So this is M3 again. I'm going to sign it off. Cool. So we are now at 46 objects. Let's head back to M64 for a little bit. We did get M64 earlier, but let's go back to it because we've got time, and it's a really cool galaxy. This is the Black Eye Galaxy. So the Black Eye Galaxy is also known as the Evil Eye Galaxy, and it's in the constellation Coma Berenices, or Bernice's Hair. This is a relatively isolated galaxy, so there's not a whole lot of other galaxies around it. And the coolest thing about this galaxy is that the gas in the outer regions is rotating opposite from the gas in the inner regions. So this is causing a bunch of star formation in the region where the gas collides. We think this could be the result of an interaction with a smaller satellite galaxy or from continuous accretion of gas from the intergalactic neighborhood. So that means it was either a small galaxy that kind of passed around M64 and kind of perturbed it, or it was something, or the galaxy is taking on gas from around itself in the intergalactic neighborhood. So like around it, like outside the galaxy, but in the same area. All the stars are rotating in the same direction, though. And it does have about 100 billion stars in it. It's also approximately 70,000 light years in diameter, making it much smaller than the Milky Way galaxy. Another fun fact about this galaxy is that it does not have any Cepheid variables, meaning that we don't know its distance precisely. Cepheid variables are a type of star that its brightness is directly correlated with how often it varies, and so we can measure how often the star is varying or like changing its brightness, and we can correlate that with how far away it is because of how bright it appears to us. So Cepheid variables are a very useful way of telling how far away other galaxies are, because we can directly figure out how bright that star should appear based on its brightness. So our next object is going to be M98. This is another galaxy in Coma Berenices. I think we should have like Jeopardy theme music playing as we're waiting for the image to take. That'd be fun. I don't know what the like copyright issues on Jeopardy theme music are. So there it is. This is what we call an intermediate spiral galaxy. So it's sort of like in the middle of being a spiral galaxy. This one is a lot further away. It's 44 million light years away. So the light has traveled for over 44 million years just to be hit by to hit our detector, which I think is really, really cool that we've taken, or that this galaxy is so far away from us. It's also pretty big, so it's 160,000 light years in diameter, making it a little bit larger than the Milky Way galaxy. It is also one of the few galaxies that is blue shifted, meaning it's moving towards us. However, since it is 44 million light years away, it's going to take a while to get here. These galaxies move nowhere close to the speed of light, and so even at the speed of light, it would take 44 million years to get here. So I don't know how fast it's moving towards us, but it's probably not fast at all. And we may have to worry about a collision that will likely be after the Andromeda Galaxy has collided with us. So that'll be a very large galaxy colliding with a large galaxy. We think it may have interacted with M99 about 750 million years ago, but they are now 1.3 million light years away from each other. It also is 76 billion times the mass of the sun, meaning it has, if you took the mass of the sun and you multiplied it by 76 billion times, you'd have the mass of this galaxy. Since there's probably more stars in this galaxy than there are stars in the Milky Way, which has about 100 billion stars, a lot of these stars are probably less massive than the sun. It also has an active nucleus, and the center is in fact more luminous than the rest of the galaxy combined. So you can see that in the image, the center is very, very bright, but the rest of the galaxy around it is kind of smudgy and faded out. That's because it has an active nucleus. So the nucleus is continuously like taking in stuff and pushing stuff out. It is also a member of the Virgo cluster and is one of the faintest Messier objects that we have. So we are lucky, very lucky, to have our 14-inch plane wave telescope with our Cam on it that allows us to take these pictures of very dim objects. You can imagine that finding these by eye would be a lot more tricky. Luckily, we have this nice telescope set up that allows us to kind of point the telescope automatically. I need to check this one off. This one is M98, right? Yeah. Cool. So let's head on over to M99. This is called the Coma pinwheel sometimes, but it is a grand design spiral galaxy. So this is another one of those galaxies that has very like spread out, sprawled out spiral arms that are gorgeous and like well defined. We can see the stars moving. That means that as we were moving, we were taking a picture. So the pixels kind of got spread out. But pretty soon we should be seeing a picture of M90. There it is. So as you can see, if we zoom in a little bit, you can see that it has these very nice spiral arms that are very like delicate and beautiful looking. So this is why we call this a grand design spiral galaxy, because it has those beautiful spiral arms that are very nicely defined. This is another galaxy. It's in the constellation Coma Berenices, or Bernice's hair. And this one is 49 million light years old. And as I mentioned before, it might have interacted with its partner, M98, about 750 million years ago. And it has 3 times as much star formation activity as similarly classified galaxies. And this was likely the result of interacting with NGC 4262 280 million years ago. It also has a star that has defied classification. It is brighter than a nova, but less bright than a supernova. So it could be a giant planet plunging into the star, which I think would be really, really, really like a star eating up a planet. You also might notice it's a little bit asymmetrical. It's kind of lopsided. This is because that of those past interactions with other galaxies that kind of pulled on it and tugged on it in different ways to kind of shift its spiral arms to where we see them. So yeah, this is M99. I gotta cross this one off too. I set the cat flying. Okay, we're all good here. Except I have marker ink on my hands now. Oh well. Anyways, this is M99. Yeah, we are dealing with a little bit of wind problems with the scope, so yeah, it's wiggling things around a little bit, making things a little bit fuzzier than we would normally like. But this is a beautiful spiral galaxy. It's small looking, but remember these galaxies are thousands of light years across and contain billions of stars. They're small because they're far away, or they're small looking because they're far away from us. We can head over to M100, or actually, let's try looking at NGC 4262. I don't know if that will go where you want it to go. So this is this other galaxy that may have interacted with this one in the past. So I think you might have went to the wrong NGC. It's 4262. I think. Yeah, 4262. You have to click on the thing. So you've got a good question from Cecilia. What is my favorite Messier object? My favorite Messier object is M13, which you should be seeing in the very early morning here. It's my favorite because it is one of the first objects that I ever found through a telescope all by myself. And it's also really pretty. It's a globular cluster, which are those big clusters of stars that are the remnants of other galaxies that the Milky Way has shredded. We'll be looking at M13 at around 2 in the morning here, so that'll be about 5 a.m. on the East Coast and about 2 a.m. on the West Coast. We've also got another question from Paulette. How do we make a decision about what we want to view? Well, we have this whole schedule of objects, so based on where the objects are at in the sky, we have to look at them at certain times of the night. And that's how this whole schedule works. But I've decided to look at NGC 4262, which I think is that fuzzy thing in the middle there. because it interacted with M99 a while ago. So this is another galaxy in the neighborhood of M99. So next, we are going to head on over to M100, which is a grand design intermediate spiral galaxy. So we should be heading over to M100. And there it is. There's M100. So this is a grand design intermediate spiral galaxy. So we've got a whole bunch of spiral arms there that you can see kind of spreading out from the galaxy. And again, it's got this very nice like face on, kind of like nice shape to it. So we call this a grand design spiral galaxy. It's also in Coma Berenices, and it's one of the brightest and largest galaxies in the Virgo cluster. It's about 55 million light years away and 107,000 light years in diameter. It contains the youngest black hole observed in our cosmic neighborhood as well. And it also has 2 satellite galaxies connected by a bridge of luminous matter. So I think we might be seeing some of those little spirals, or little, not spirals, satellites. Yeah, so we've got all those little satellites around it as well. Most galaxies are not alone. They've got all these little galaxy friends around them. Yeah. So we're gonna cross this one off. Yay! So we are going to take a quick break in a couple minutes to move some stuff around up here, and we'll be changing hosts. So Catherine will be your host again. And we'll be moving some things around up here, but that'll happen in a couple minutes. Until then, bask in the glory of M100. I wonder if Messier had like a celebration when he hit 100 objects. Like, that's kind of a big deal, I think, hitting 100 objects in your catalog. I wonder if he felt the same way. Like, I know we're going to be celebrating when we find our first 100. Alrighty, break time. We will see you guys in a couple minutes. It's been wonderful talking to you all this evening, answering your questions and seeing them come through our feed. Thank you everyone for tuning in. We really, really appreciate it. Make sure to subscribe on your platform of choice, whether that be Twitch or YouTube. And we would like to thank you all. So thanks again.
Oh my God, that's awful.
Hello and welcome back, everyone. So we are currently now in the middle of the night during our Messier challenge, and so we are going to start a little bit. We're going to continue with galaxies at the moment, and so welcome if you're tuning in right now. We are currently streaming right now on YouTube and Twitch at the same time, so welcome. So we are currently doing the Messier challenge. I would say it would be probably like, there's March Madness for basketball, but this is March, March Messier Challenge Madness. Woo! And so we are currently here at Lowell Observatory at the Giovanni Open Deck Observatory. And so we are currently taking photos of the Messier objects to keep track for them for the rest of the night. So our first object we are going to go to M85. So M85 is a spindle galaxy. It's called the spindle galaxy, and also it's going to be a type of spiral galaxy that we're going to view. So right here we're using our 14-inch plane wave telescope that we have here on the deck at the Godo. We call the Giovanni Open Deck Observatory the Godo, just for short. And so we are taking pictures, little longer exposures of galaxies, so we can take, we can get some more details of the images that we're viewing for the evening. And so we want to get some details of like the spiral arms and maybe some stars or even like little satellite galaxies. Oh, so here we are. So this is M81. It looks off. M85. My apologies. So this is M85 that we are at right now. It looks like, I think this is an elliptical galaxy. Sorry, not elliptical, and it's not an elliptical galaxy. And so we kind of see like the core, like it's very, very condensed and the center of the galaxy. And then we can kind of see like, the a range of like kind of like stars that we can see that we can examine. And so this is a really, really big, significant part. We are at 50 Messier objects, which is woohoo. We have 60 more to go. But let's check this one off on our handy dandy Messier object list. So this is what we've been doing to track the Messier objects down, what we saw from the previous evening. We're gonna go to M85. That's where we're at. Little spindle. Look at it. Speaking of which, of this Messier object board that I have behind me, this we have a room here at the Godo, which is called the Astrolab, and this exhibit, we have a giant exhibit of this, and it was donated by Mark and Donnie Howe. We love this. It's a great reference board for us because we use the Messier catalog here a lot here at Lowell, because there's amazing like objects to get off from this object and from the list. So the next object we are going to go to is another fan favorite here up here. We're going to go to M101, which is actually the Pinwheel Galaxy. First, we just slew the telescope, so we have to wait a couple seconds for the new image to reappear. So the telescope just moved, and so we're gonna maybe see a funky kind of image on the next part. Yeah, or the previous. We're getting the spirals of the spiral arms of M101. So we're gonna wait for one more second. It looks like it's like a little satellite kind of star, but that's just the telescope that moved a couple seconds ago. Ah, there it is. Right there, you can see the spiral arms of the galaxy of Pinwheel, and so you see the galactic core just in the center of the galaxy. We're trying to pop out the more like maybe blue part, just to get a more clear image of this object. Galaxies are they're very, very awesome to look at. And so this galaxy that we have here is about 21 million light years away from us. Yeah, million light years away. That's a big number if you put it into perspective. And so a light year is just how much light that travels in 1 year. And so that number, if you put that into miles, is like trillions of, it's a lot of zeros if you add that. And so we have light year as a nice component to, you know, help us with the math. It makes the math a little nicer so we don't have to put so many zeros. I feel it would break everyone's minds. And so this is about 21 million light years away. And this is a really nice, like, low, like, kind of like, it is visible in the night sky. This is in the Ursa Major constellation, which is the same constellation where the star pattern of the Big Dipper is. And so the next galaxy we're going to be going to, we'll be talking a little bit about M102, which is right next to in the same catalog. As we're going to be moving to the galaxy, I am going to be checking off this board right here behind us. Again, we are going to go to M100, the Pinwheel Galaxy. It's a beautiful little spiral galaxy that we saw this evening. M102. So we're waiting again for the, you know, the next image of the image to pop out, because the telescope did, when it was moving, it did take a picture. It looks like there's moving stars, like kind of like shooting stars in them. There we go. Looks awesome. Looks really nice. Like, you can kind of see the dense, like, core of the galaxy to it. And so a little bit about this galaxy, Spindle Galaxy. And so it's, again, another type of galaxy. I think this galaxy is in the constellation of Draco, which is the dragon constellation. And so this galaxy is, you know, just roughly about, 50 million light years away. That's a really far commute galactic-wise. And so from looking at galaxies, and so we're waiting from that galaxy, it took about 50 million light years for that light to travel back to Earth. We're gonna get a really nice upcoming picture of it. You can see how, like, there's so many stars condensed in the core of the galaxy, for example. You see right in the center of the screen. Yeah, one could say it does look like maybe a UFO. Looks kind of like a UFO. Maybe it is, there's alien life out there. We don't know. Who knows? Interesting. Yeah. Look at that. You can kind of see some, like, color variation in the object. Woohoo! Oh, that looks amazing. That looks so good. Like, you can kind of see, like, you can get this, because this galaxy is sitting on it, has kind of a side view to us from Earth. And so you can see, like, the rim of the the type of the rim of the galaxy, and then the yellow kind of, like, center core of the galaxy. Like a little dust lane. The dust lane, like, crossing through the galaxy. Looks super, it's popping out really amazing. We've had a little issues with clouds tonight and such, like, especially early in the evening. And so we've had issues with clouds that have been kind of messing up with our objects, but it looks the sky is clearing up pretty nice, but it's still been kind of, like, iffy. The sky does what it wants and such. Yeah. So springtime is a great time for galaxies. So this is called galaxy season. We like to call it up here. And so this is the best time to view galaxies, because there's a lot of galaxies in the constellation right behind in the constellation of Leo, for example. And then we can go, if we get a nice view, this is our plane wave software that we've been using to tell the telescope where to go for the evening. So the plane wave is just the manufacturer company that rates these telescopes. These are really nice high-tech telescopes that we have. We have a couple on the site, and so we're using the 14-inch telescope that we have, and so it has a couple mirrors that focuses in the light and such, and so we can get our image. So we're taking this image through our Mali cam that we have here. There's an on the back of the telescope, there's an instrument panel where we can put in our camera, and so we can have it connected to the computer and take a picture of like our objects that we want to take for the rest of the evening and such. So we have right here, I think this is in the, you zoom out just a little bit. I think this is where, was it? Oh, Kansas. Oh, okay, we're at Leo area. Okay, perfect. This is the Leo area, and so we zoomed in a little more, and we saw how you guys kind of see like those NGC kind of like N numbers. Yeah, those are just objects out in space, and so this kind of software we can like go to make some like random objects in the system in the sky and just like see what it is. Most of these could be around like galaxies and such. We have the Black Eye Galaxy that's labeled in right there. Look at that. I was previously on the previous route, I was looking at constellations in the Leo area. And so Leo has so many galaxies. I've never seen so many galaxies until recently, especially like looking at all the pictures just for fun, just to like, look at galaxies because like they're so like interesting. Our closest galaxy to us is the Andromeda Galaxy, which is a little closer to us but it's about 2.2 million light years away, so it's a little closer than our previous galaxy, which was like 50 million light years away. Look at it. It looks so good. So we have a little request for NGC 1365. Let's go to that. Let's see what it is. So we put it in our little number, what we want to do. Let's see if we can go to it. Or is it below the horizon? Oh, so that galaxy is just very below the horizon. And so we can't take a picture of it, unfortunately, today. So we're going to NGC 40, it looks like 4565. Let's go to that. Let's see what that little guy is. So we're taking a picture of the galaxy. We're just waiting in because the telescope just moved. Oh, look at that. Looks good. Yeah, let's maybe increase a little bit of the exposure time, maybe pop out some oh, that looks, yep. Oh, that looks amazing. Looks like this galaxy is a very edge-on galaxy. So edge-on means it looks like it's like on its side, that it looks like it's on the side, like kind of like a plate. If you put a plate, like kind of like horizontal, and like you look at it at eye level, that's what an edge-on galaxy would be. Ooh. So cool. I love there's like the core is very condensed and like you can see it like straight on. Taking a couple more. Next photo. Oh, we just brightened it out. We just increased a little bit the inks. Get more of the detail of this edge-on galaxy of NGC 1365. 4565. This is in the NGC catalog, which means new. It means new catalog. Excuse me, my bad. It means new general catalog. And so also a lot of our Messier objects still have the more recent NGC numbers to them, but lot of the times we just use the Messier number because it's more easier to memorize. Because there's only like 110 Messier objects that we have here, but the NGC just beyond of thousands on them. Oh, look at him. He looks so nice and beautiful. Let's see. There it goes. We're on our next. Let's see. So we're going to do a couple more objects before we go on our break because we'll have our Twitch streamers twitching in for a couple hours. Also, speaking of which, we are streaming here on YouTube and Twitch, so check us out if you want on Twitch. So we're going to go to M84. I think we already went to yes, we are. We just flew to M84. That means we just moved we told the telescope to move to M84 in the region of the sky. So this galaxy is an elliptical galaxy in the Virgo cluster. So it's in the Virgo constellation and it's located in the Virgo supercluster. And so the Virgo supercluster contains clusters of the Virgo cluster and then the local group like our galaxy and then Andromeda. And so they're this is kind of our galactic neighborhood that we have, gotta be best friends in our neighborhood. Ooh. So we have the elliptical galaxy that we have right there. You can kind of see the very, very condensed galaxy of M84. And then we're going to go very, very soon, get a couple more photos of the M84 before we go to our final objects before we switch off is M86. Let's see this new photo. Okay. Let's try 2 more seconds of an exposure time. Let's see. So it looks awesome. We have a little companion right there, right below, and then we kind of maybe see a couple other galaxies in the same photo. So if we go to M86 to wrap up this final part. So M86 is host of a chain of galaxies. So we're probably not going to move really, really far. This galaxy that we're going to be looking at is going to be, it's going to be 57 million light years, away from us. So we're going to wait for one more second exposure picture of this galaxy. I think that's it, right about it right there. That is. And so M84 and M86 were just in the same kind of same field of view, but we just kind of center it. And there's also a little companion right below M86, right below it. And so these are just 2 elliptical galaxies that are in the Virgo area, in the Virgo supercluster. And so these galaxies are pretty, very condensed and they're very far away. So we're definitely going to log these up for the evening. So we just did M84 that we have, it looks like on the left-hand side, and then M86 on the right. So we're going to go to M84. M86, these wonderful elliptical galaxies. Here we go. Let's put you, perfect. Yeah, so these galaxies are very elliptical. They're very, very far away from Earth. Their light came from over 50 million light years away from us. So maybe there's dinosaurs on these galaxies, who knows? So before we wrap up, is there, I'm still trying to figure out with this little NGC little number guy. don't know at the moment. So if you have any like questions or like any comments, like feel free to ask in the YouTube chat and also the Twitch chat, for example, in the for now. We're just taking a couple more photos of more pictures of these galaxies. They're just hanging out. But they're at a really far distance from each other. I love how you can see like kind of like there's a glow to M86 for that. We got a comment from Bill McDonald on our YouTube chat. Do we have trumpets for the halfway mark? I think we need like maybe an air horn, go whoop whoop whoop. You know, the air horn thing. You know, and like maybe like a phone alarm or so. Yeah. So we're going to be wrapping up for these galaxies. The ones I just looked at is just going to be, we looked at M85, M101, M82, and then M84, and then M84 and M86. And so we are going to go on break in about a few minutes, and we're going to have new hosts, and we're going to have new hosts for the later the part of the evening. So thank you for everyone who's joining here this very late evening here in Flagstaff, Arizona. It's about to be the new day. There's clouds. Apparently there's clouds right now at the moment where the Sombrero Galaxy. Oh, there it is. Looks like it's kind of like upside down. Looks like, you know, like a hat. We did get a question from rent-free Corin. Do you think there's aliens that live in that galaxy? Which is probably like M86 I was talking about. Probably yes. Who knows? We don't know. So this is going to be our final object with me, and we're going to be on our Twitch with our Twitch streamers with Hannah and Jacob very soon. So we're going to take a little bit of break so we can transition to our new host and continue with more of our spring and summer sky later this morning, if you would say, because it's the new day in the next few seconds. Yeah. Thank you, everyone.
and welcome back to the Messier Marathon.
Okay, that was all right. So it had to be used. We had to have that be used because, of course, we did.
So you're here with your Twitch hosts. My name is Hannah Zygo, and
I'm Jacob Irish. Hi, how's it going?
And we are going to be your Twitch hosts for the next 2 hours. So from now until 2 a.m., we are all yours on Twitch. So first off, how's it going? How is everyone? Are you guys awake still? What time is it? How are you feeling, Jacob?
How am I feeling? I'm feeling all right. At least this wonderful paper that has basically those prompts on it tells me that, I could talk about this type of thing. So yeah, I'm doing all right. It's kind of nice. It was a beautiful day today. The weather was amazing. It got kind of cloudy though, but it got not cloudy.
It did. It did get cloudy.
Now we can get some good pictures, some good images of objects that are, in the Messier catalog, because that's kind of the whole point of this stream. And to start off, we got M87.
Yeah, so before we talk about M87, I do want to talk about a few things real quick. So first, if you guys just joined the stream, hi, welcome. We are doing a speed run of the different Messier objects in the Messier catalog. We are at the GeoVol Open Deck Observatory, also known as the GODO, and we are using our 14-inch plane wave telescope. And we want to thank our donors, the Don Neerling Memorial Foundation, for the Malencam, and Mark and Bonnie Howard, who donated for the Messier exhibit chart. So with that being said, the 14-inch was Don Neerling. So yes. But with that being said, thank you to our donors. And we can talk about M87. So behind me, I don't know if you guys can see this. I'm gonna bring it. But this is our Messier catalog, or our objects, our poster of objects. And throughout the night, we've had the different educators sign off on all the different objects. We've had the poster attack people. And so that's what we're going to be doing. So, Jacob, do you want to talk about the object we're looking at?
Sure, absolutely. M87. It's a super cool galaxy. It's a super giant elliptical galaxy near the constellation of Virgo. And there are plenty of galaxies over in that direction. You could pretty much point a telescope over there anywhere in the sky, and you'll see more than one galaxy altogether. In fact, you can even see more than one in this single view. But M87 is going to be the bright kind of headlight-looking thing, sort of near the center there. And it's cool. It's far away. It's about 55 million light years in distance from here at home. And it's kind of cooler than just all of those numbers in that we've actually taken a picture of this galaxy in particular's supermassive black hole. Now, this was an image that's been passed around the internet for a while. It's been a bit since this has happened, but yeah. It's a cool picture. I mean, being able to kind of put together the data taken from many different telescopes on Earth to be able to see something like that in a galaxy that far away, that's cool. That's crazy.
So yeah, that picture was taken with the Event Horizon camera, which literally was a bunch of telescopes from all over the Earth combined to make one giant telescope to get this picture. And so I want to emphasize that M87 is the 55th object that we're looking at tonight. So
there we go again. Cool.
Number 55 here. And so I'm gonna have Jacob talk about the black hole real quick, and I'm gonna mark it off on our little poster here.
Yeah, all right. So black holes. It's a really convoluted topic to talk about, but black holes themselves, they've always posed kind of this whole mysterious thing in all of astronomy and science as understanding kind of what they are beyond just what we see with our eyes, or what I guess we could try to see with our eyes in the case of something like a photograph. It's kind of unknown. it's kind of something that's left to be discovered, and all we could do is give it our best guess. And usually the best guess is once you pass that event horizon, that black shell that encompasses whatever's underneath, all of physics kind of just breaks, just kind of stops working. And that's kind of a weird thing to think about, because physics kind of governs everything that we do, right? You drop something on accident and you break it and you feel like a goofball for doing that. That's physics in play. That's something falling to the ground because of gravity. It's simple stuff, but it's also just a part of the greater system that governs the universe as a whole. And being able to say, like, that stuff doesn't exist anymore at a certain point, it's kind of weird to wrap your mind around. And in the case of black holes, pretty much anywhere in our universe, that kind of holds, where once you pass the event horizon, whatever could happen with physics probably does happen. But as to what happens, that's kind of unknown. There are great guesses out there, and there are people fighting to try to understand this. But as for how long it will be until we have a definitive answer, who knows? But we do have a definitive picture, and that picture is something that you can, look up on Google or something.
Yeah. Do we have a picture of it by any chance? I don't know if we have a picture of it pulled up or something like that.
I have no idea.
Yeah. Well, that is a really cool picture here. I think they're actually.
Oh, there we go. Here we go.
Did they get it?
We'll see. To Google in a way.
Well, while we're waiting for that, let's go to our next object. Oh, it looks like they're actually going to pull it up real quick here. Don't look at our.
We have time. We have time. We're good.
We have all the time. So we have so the object that we're looking at, M87, like Jacob was saying, is in the constellation Virgo, and it is. Oh my God! There's a black hole picture. Oh,
yes.
So cool. That's literally a picture of a black hole. And I used to always tell guests, like, oh, we can't take a picture of a black hole because it's black. Like, you can't see it. But we've done it. So.
I mean, yeah, it took a little bit of like big brains putting them together to try to simulate or emulate, whatever the right word is, whatever the right word is. A telescope the size of the Earth, or at least a sizable size, to even put together the data necessary to come up with a picture like this. And it's not HD. It's not like crazy or anything, but it is also super crazy because it's a picture of a black hole very, very far away, a supermassive one at that. So
we got people in the chat. So we have Pandemic Watch saying it was very close to the expected image. That was impressive. Yeah. So
absolutely.
The simulated image, or the simulated pictures that we have of black holes, look very similar to this if we bring the quality down. And so the whole reason why we can see this picture is the material that's around the black hole, right? So this is material being accreted into the black hole itself. And so it's just like gas and dust and really energized material around it. And so again, that's the whole reason why we can see it in the first place. And Softspun saying the famous black hole picture is so far away. So yeah, super cool picture. Thank you for pulling that up, operators. And so yeah, earlier someone was saying how we have a whole team of people working here. So not only is it me and Jacob on camera, but we have the telescope operators in the back. We have people monitoring and things like that. So we have a whole group of people working.
Yeah, lots of snacks actually too in the back over there for anybody who's working here tonight. So we're not going hungry, which is perfect because
here all night.
This marathon, we're finding a lot of objects. The operators are going through just a gigantic list, and anybody who's talking here, actually, it's Hannah over there who has the board behind her to mark things off that we've seen. It's kind of the way things have been going tonight. And I mean, it's been a beautiful night, actually, besides those clouds, but we were able to put out those dusk objects very, very nicely, or at least to the best of our ability, because sometimes the weather just doesn't agree and weather apps don't really work with us sometime. And that's just what it is sometimes. And you got to do your best to work around those stinking clouds. But it happens. And we were able to mark down 55 objects already, which is really impressive because most nights with just regular observing, you wouldn't even get close to seeing 55 objects. So this is neat.
Well, especially for this time too. I mean, we've been doing it really quick. I mean, we've had a lot of help with the telescope that we do have, but yeah, it's been really neat. Pandemic Watch on Twitch says, yes, it is a great run so far tonight. Indeed. That is so sweet. Thank you. And Softbun actually has a question for you, Jacob. How do scientists calculate the mass of a supermassive black hole?
To save everybody in chat 30 minutes, I'm just going to say with math, with mathematics. Just some nice, complicated-ish physics equations you can piece together. Then you can just, I guess, reverse engineer your way to a mass of a supermassive black hole, or any black hole for that matter. But that would be a mouthful. That would be a very, very long-winded statement and conversation. So I'll end it off with just math, or at least that question I'll end it off, because we're here for a while.
Yeah.
We have plenty of objects to go through as well. In fact, most of the objects tonight are going to be galaxies, so we're going to be able to get through plenty of them. But we're going to have some nice little talking points with even some special guests.
Yeah, so do we want to go to the next object?
Yeah, let's, why not? Let's go to the next object. M89 is next up on the list, and this is going to be another one of those elliptical galaxies, close enough in distance to M87. I guess they compare in distance, as this is about 50 million light years away, the next object we're going to.
Softbun says, math, the answer to life's most complicated questions.
Yeah, unfortunately. It's just, math is kind of everywhere, no matter what. And don't let anybody tell you different. You might not use your formulas that you learned in Calc 1 for going shopping or I don't know, putting Lego sets together, but you use some of them sometimes. You know, it's numbers. It's the universe.
That's great. That's good advice, Jacob.
Yeah, thank you. I'm a certified advice giver.
Big brain moments. So I'm going to talk about M89 really quick here. So is that it right there?
Yeah, that's it. It's an elliptical.
M89, yes. So it's another elliptical galaxy. And so all of the galaxies, literally all of the galaxies that we look at tonight, are part of the Virgo supercluster. So that doesn't necessarily mean they have to be in the constellation Virgo. But this supercluster, the Virgo supercluster, is this large cluster of galaxies that's part of our local group. And so what that means is the Milky Way, Andromeda, and all the other galaxies that are close to us, including all the ones that we're going to look at, all kind of live next to each other. So there's around 1,300 galaxies in this supercluster, which I think is crazy. So we have like 1,300 neighbors, like we live in a city. But there's a lot of really cool objects in this supercluster. And again, all the objects that we're basically going to be looking at for the next 2 hours are going to be galaxies in this supercluster. So you'll get a really good idea of what our neighborhood looks like and kind of the varying differences. So like this, M89, it's an elliptical galaxy, but the Milky Way, the Andromeda galaxy, are spiral galaxies. And so you get to kind of just see like how everyone looks and the diversity of the different galaxies. So I think it's cool. But yeah, Jacob already talked about this one pretty much. It's an elliptical and it's like 50 million light years away. And so I'm going to mark this one off on our poster board. What is it? M89?
Did it. Yeah. Yep. M89, another elliptical, and you might also get sick of the word galaxies for this leg of the night, because there is just so many to see, but it doesn't make them any less beautiful. Say that for sure.
No, we can say elliptical galaxies are not beautiful.
Wait, no, not me. I love them. Hello, that is probably one of my favorite things. They're awesome. Really? They're old galaxies. Yes, ellipticals are old. They are older galaxies. The star formation within them is kind of slowed down to the point where you don't really have those structures that you would see with spiral galaxies in particular. And they're awesome because they can have a lot of crazy stuff within them. And
well, I have a surprise for you then a little bit later. Some of the other galaxies, the spiral ones that we're going to see.
Yeah, we have a few spirals that we can actually get through as well. But yes, ellipticals are beautiful. Thank you, Jose. I agree. I 100% agree. Hannah, you are wrong.
Because I said ellipticals are ugly?
Yeah, pretty much.
They are a little bit. Maybe if they looked a little bit more like globular clusters where you could see all the sparkles and they look like jewelry. Excuse me.
It's just wrong.
No.
It's a wrong opinion.
Here, okay. While we're on this elliptical galaxies and black hole subject, Softbun asks, is it possible for a black hole to eat an entire galaxy? So, I'll talk about that for a second here. So, black holes live inside galaxies. So, there's some that are like the size of stars, so they're like, little, but then there's some that are supermassive that actually live in the center of these galaxies. So, the material that is around these supermassive black holes, they don't necessarily get sucked into the black hole like a vacuum. So I feel like that's a little bit of a misconception when it comes to black holes, because people talk about them being like vacuums in space and how they're like, if a black hole were to come by Earth, it's going to like suck us up and things like that. But black holes necessarily aren't these big vacuums. They don't suck everything around them. And that's why we can actually have material orbiting around it, like that accretion disk, because black holes are just really dense places of gravity, if that makes sense. So if our sun was replaced with a black hole, the Earth wouldn't get sucked in. The Earth would still be in a stable orbit. So something has to go directly into the black hole for it to get sucked up. So I guess theoretically, a black hole, I don't even know if I want to say that. I was going to say, possibly a black hole could eat material that's the mass of a galaxy, but again, I don't know if that's possible. What are your takes on that, Jacob?
I mean, I don't think really a black hole could ever really eat an entire galaxy, unless one got massive enough that it could just swallow one entirely. But then again, yes, you'd have to fall into kind of this gravitational orbit around it that would decay to the point where something could fall in. And to add in to what was previously said as well, like, you would definitely be able to have like a stable system if you replaced, some object such as our sun with a black hole of equal mass to the sun. Nothing would change. I mean, you wouldn't have light anymore, which would kind of suck, but like things would kind of go as normal. Planets would keep on spinning around what would now be a sun mass black hole. But black holes themselves are supermassive. Black holes in the centers of galaxies can actually contribute in small ways to the slowing down of that star forming production. Whatever. That whole process is a little bit convoluted, and I'm not even entirely too sure how it is all worked out. But I do know that those supermassive black holes, especially in things like elliptical galaxies, which are considerably larger and considerably more massive than something like our own supermassive black hole here in the Milky Way, a Sagittarius A star, those are kind of a telling sign just from their mass and everything as to like the attributes of something like an elliptical galaxy and what it may have in store, which usually is just that dim disk, that glow, the haziness of what are those ellipticals. And they're pretty, in my opinion, because they're kind of mysterious. Like you are able to other galaxies. In fact, we'll go to the very next one, M88. It's next on our list. Now this is going to be more or less your typical spiral galaxy of a sort of similar distance. Again, 47 million light years away. And those are a little bit more recognizable as galaxies. And depending on who you ask, such as Hannah, at least she's over in this direction on my screen. I'm not sure how it's set up for everybody else. I think maybe above me. Is she above me? Yeah, I think she's above me. These spirals can definitely be much more eye-catching because they have more attributes to them. You can see their arms. You can see dust within them. They're not just kind of hazy glows. But as for what's going on, it's on our standpoint, because from down here on Earth, when we look up into our galaxy, we see star-forming regions. We see things like the Orion Nebula, and when the summertime rolls around, or just, I guess, later on into the night and morning, there are other objects out there that do form stars still. And we're kind of this middle-aged galaxy that's still evolving and still working, for really lack of a better term, when those ellipticals are kind of just still hanging around. And M88.
Yeah.
Yes.
Yeah, I think you said that, but I don't know if the operators heard to go to M88.
Yeah, do it now. Absolutely. No. We're in such a rush.
No, just so we could have a picture to go with what you were talking about.
Yeah, absolutely. But yeah, beautiful, beautiful galaxies.
I know.
There are plenty to go around tonight.
Exactly. And I think it's so cool. So M88, like I was saying before, it's part of the Virgo supercluster, but this one necessarily isn't in Virgo. It's in Coma Berenices. So Kendall was talking about this one earlier, how it's, this is the hair of Bernice. So, yeah.
That's interesting. I honestly, some of these constellations, they just, because they're so small that, like, you don't really think about them often. But
oh, look at this. This is so cool. That's a really cool little spiral there. It kind of looks like the black eye a little bit.
Yeah, sort of similar to that. And also, looking back at the Twitch chat, what up, Art by Words? How you doing? And it's definitely fine. Like, don't get me wrong, spirals and stuff are beautiful. I just tend to gravitate, that was almost a pun, towards elliptical galaxies more, because they are, in my opinion, a little bit more interesting, but spirals themselves can be much more visually pleasing. And in the case of M88 here, being another spiral galaxy very far away, pleasing definitely is the right way to describe it. And with the camera that we have attached to the 14-inch Malin cam, we get a lot of view here. We got a great field of view to be able to see galaxies like this and kind of their surrounding area. And now we get to mark off another object on our.
Yeah, I wanted to point out the three ones that we just did are like right next to each other. We did M87, M89, and then M88,
we did that.
All three in a row right here. These are the ones we did. I don't know how well you can see that, but those are the ones we did.
Yeah, and I guess we could continue on that trend. Why not? We can go to M90 now. That's kind of the next object on the list. And I guess, could anybody guess what kind of object it's going to be?
Yes, guess
on the screen. It's a galaxy.
What kind of galaxy is it? Before it pops up on there, is it going to be a spiral or an elliptical? You have.
They have like 10 seconds to know that, or really just guess it. But it's coming into view there. I'll just I'll cut in spiral. Yes.
Oh yeah, someone says spiral.
What a winner. Intermediate spiral galaxy. Yes.
Dinner.
And this is going to be a little bit further than the other objects we looked at recently, the last three. This is about 60 million light years away, which is far. It's far enough.
Yeah, this one's interesting because compared to the other galaxies in the Virgo supercluster, they actually think this one is traveling towards the Milky Way galaxy, not away from it. So kind of like Andromeda. So it's not going to like crash into the Milky Way per se, but it's coming this way compared to away from it. So I think that's a really interesting fact about M90 here, which I'm going to mark off on, I think.
Yeah. Galaxies like this, especially galaxies that tumble towards us, are fun to think about. What's going to happen in the future whenever, we may collide with something like Andromeda. And the answer is not much. I mean, the sky will look different. The galaxies will collide, and the galaxies will age. But for the most part, you're not going to have anything exploding. You're not going to have stars crashing into each other because space is it's big. Space is big.
This is a really pretty picture that we have of M90, by the way. Thanks, Claire, our operator.
This is a beautiful picture. Like, Those spirals, I'm gonna lean closer and awkwardly like make everyone stare at my forehead
That's
here.
how I've been doing, because I don't want to put my glasses on.
Yeah, I don't want to like squint too hard to see this, but yeah, that does not look bad. That looks beautiful, actually. You can see just like kind of the darker lanes through it.
No, that's a really
awesome.
Nice one. So why not keep it going? You know what I'm thinking? Maybe we could do like half of the objects. We could do the rest of the galaxies until M68, and then we could take a break and like have like a guest speaker or something like that.
That's true. Yeah. Perfect. Absolutely. And yes, we are getting message that the moon is setting soon. Thank goodness. I don't like the moon at all. So hopefully we can get some better sky, and hopefully like for sure we'll get a better sky. The moon always fights everything we do, and when it's up, you know, it's not nice to us. It just wants to steal the show.
And we can get some better images of these galaxies too. Maybe we can head back. By the way, I totally forgot to mention this. If you guys have any requests or recommendations of objects that you would like to see in the next hour and 20 minutes, leave it in the chat and we'll try to get to it, because we have a lot of time to spare. So again, if you guys have any recommendations, we are in Flagstaff, Arizona. So if that's going to help you with your search of something that you may want to see, but that is an option. So if you have any recommendations,
yeah, it definitely is an option. We'll roll around to whatever works whenever we can, because that's just kind of how things go. But yes, even if you want to even talk to us in Twitch chat, feel free to mosey on over there if you're not there already, and just smack at the keyboard, say something, and then press enter. And as long as it's like perfectly normal sentence for us to answer, we will totally answer it. Because if you're just slamming your head on your keyboard and then you hit enter, then I don't really think we could do much to talk about that.
Yeah, Jacob and I are keeping a close eye on the chat right now. So
yes.
Again, we're looking at the Twitch chat. Sorry to the YouTube people, but we're giving some love right now to Twitch. So if you do want to talk individually to me and Jacob on Twitch chat, we can answer your questions there. So
head on over there to twitch.tv/Lowell Observatory, all one word. Make an account if you haven't already. Follow, show us some love there too. We do a lot of streams outside of these events, and we've been working with a new little camera, a new little toy that we were given to work with the Dyer telescope up here, and it's absolutely fun. It's a beautiful little camera, and we run it, I believe, every Tuesday that we can, and get some nice photos of pretty much any object in the sky, and talk about anything in the world too. So if anybody has like a conversation they want to start about their favorite food, or maybe some TV show that they love or hate, then it's all fair game.
Okay, so we already got someone. We have Amapreet from U of A. Hey everyone. Hi. I think I recognize that username. I think you follow me on Instagram actually. So hi Amapreet. Let's go to an object real quick while we're talking, so we can. It's M90. So let's
M91. Woo!
Oh God, I gotta get the air horn.
No.
M91. No. Give it up for M91.
It's not. Doesn't become funnier, but sure.
You love it. It's okay.
I do not love that at all.
So while we go to M91, this is another galaxy, and this one's a little bit different from the galaxies that we have looked at. So we looked at the ellipticals and we looked at the spirals. This is a spiral that's having a little bit too much fun. It's a barred spiral galaxy. So what this means is that instead of a spiral where it's completely like a circle, like a pinwheel, this one has a bar in the middle of it, a line, and then it has a spiral arm. So as you can see this picture, this very, very beautiful picture, there is that line through it, and then we got the spiral arms going around it. And so this one, again, is a little bit further. So this one's 63 million light years away. And this is a very interesting galaxy because it is galaxy, and that means that the spiral galaxy, which this isn't common for spiral galaxies, it has very little star formation and gas compared to other spirals. So spirals are very well known for their star formation, for the gas and dust in the spiral arms, and for this, kind of active regions. And that's why elliptical galaxies, we say they're older, they don't really have any gas and dust, very old stars. And this one, it's a very peculiar spiral galaxy because it has little star formation and little gas like an elliptical, but it's not. So I think that's very interesting for a spiral galaxy.
Absolutely. And I mean, this image here, again, just like the last, just entire set of images. Beautiful, stunning. M91, again, we're really just working our way up the list here, marking off all of the objects that we can get through this marathon. And yeah, it's a great image. And you ever considered a Caldwell marathon? TB Clarkson says that. No, I've never considered any marathon at all until I was given the opportunity to do this. I didn't even know that these existed. I had it in my mind. I was like, you could totally try to, speed run all of the Messier objects, or really any object list in general. But I feel like some of those have become so expansive that I just had to, like, if I was doing something like a NGC marathon or whatever, I would have to kind of just devote my life to that instead of having to, do it all in one night. And I'm sure the same would be said for something like the Caldwell.
Yeah, this is my first Messier marathon, and I think it's actually like a lot of our first Messier marathon.
Yeah, this is kind of new ground for a lot of people out here tonight, and I think it's neat. I absolutely love the idea of it. It's very cool. It's kind of like taking the interactive stargazing that's done and kind of bumping it up, not only with just 12 hours of content straight, but also like there's kind of a risk to it as well, because we have to catch all these objects before they set for us. So we're all assigned kind of our own little individual blocks, and we're working with kind of what's up in the sky for us right now. And questions like, is NGC 3553 above the horizon? I do not know if that is.
Where are you saying that? Is that in like the YouTube chat?
Twitch chat.
Oh, maybe my thing's not working.
Yeah, you're totally missing that. And is Jupiter visible right now? I do not think so.
Yeah, I think my thing's being slow. Let's see. Oh, well, the chat deleted, so I can't see.
Okay, well, the chat deleted itself. We'll come back to that. Absolutely no worries. But yeah, those NGC objects can be pesky sometimes, but they can also be very beautiful and rewarding. So we'll keep that in mind for sure.
Yeah.
And in the meantime, though, we could move on to our next galaxy on the list, M58.
Let's go. M58. So, M58, guess what constellation it's in? There's only really one or two options. It's in Virgo. So we got another supercluster object, M58. It's an intermediate barred spiral, so we have another barred spiral galaxy. This one is also going to be an anemic galaxy that has low star formation and very little gas. And they think that this galaxy doesn't have a lot of gas because of interactions with the other galaxies in this supercluster. So I think that's interesting. Oh, this one looks kind of cool too. Let me wait for this new picture to load up here. Again, but it says it has very little gas, but this picture looks like it has a lot of gas. So I don't know.
Probably considerably less than some others. So yeah, it's all relative in space, because that's how it works. Jacob, what's up, man?
Oh, hey, Jacob. Oh yeah, Softman says, what planets are visible tonight, and can we look at one? I don't know if there's any up right now.
Yeah, Mars was up earlier, and like it looks decent. Mars looks cool. It's kind of something that you'd like optically want to see more, I think. Actually, maybe the plane waves do justice for it, but I'm sure it's behind the trees, if anything. 3553. So yeah, NGC 3553 is actually up, and wow. We could take a nice little detour there before we get to our last two objects of this little section, and then we'll move on to having somebody talk about something. I don't know what they'll talk about.
We'll see. 1, 2, 3, 4, 5,
6, 7, 8. We have 8 things left, and we have an hour, so we could definitely get those.
Yes,
really
we got time.
There is one that we need to get at around 1:20, I believe, and that's just because it'll be at zenith.
Oh.
So, and that'll be the best time because it's fairly south. Let me see which one that one is real quick.
Yeah, I actually, NGC 3553, I don't think I've ever.
It's M5, so we have time.
M5. This must have been earlier in the evening then, huh?
Which
or
one?
Is it something in the future? What we're looking at now. The 3553, yeah.
Okay, so we just got a note that says Jupiter and Saturn are too near to the sun. Mars, Uranus, and Neptune have set. I'm so sorry, no planets. No planets.
Yeah, they're doing their own thing right now. It'll be a while and then they'll be back. But when they're back, they're there, which is good. It just takes time. And Mercury and Venus are also near the sun. So it is what it is.
Cool. Well, so this is NGC 3553. Is that what this one is? Nice. It's a nice little palindrome like my name. Haha.
Is your name a palindrome? Oh my, it is.
Oh my God, it's like race car.
Yeah, like race car or Taco Cat. Taco Cat also
Taco
works.
Cat, that's a good one. So, okay, so let's go to the last galaxy, and then I'm going to shout out all the people that have followed us tonight on Twitch. So
that's gonna be fun.
Yeah, let's go to M59, which is an elliptical galaxy, and it's 50 million light years away. So it's a little bit.
Did you mark M58 on that?
Yeah, I did.
Okay, cool. Honestly.
Once we get M59, I'll mark.
Okay, cool.
Yes, yeah, I'm keeping track here. You're gonna have to do this next.
Wait, what?
You're gonna have to do this next. You're gonna have to come in here. Unless you don't want to. I can stay in here.
Look, we're just like back to back at rooms here. My room
Jacob is literally right there.
Yeah.
Okay, so we have the door open because of like COVID and stuff. Jacob's literally right there.
I mean, like I'm outside and then just right around the corner in another. I can hear you too, but that's no order there. So
nice palindrome says pandemic watch. Thanks. Okay, so is this it? M59.
9.
Yeah. Nice. Guess what constellation it's in? If you guess Virgo, you're right.
You gave them no time to guess. You gave nobody any time to guess at all. Like that was just, guess what? What? Oh, it's in this constellation. Like I couldn't even form a tangible thought in that amount of time.
Okay, next time I'll be sure to count for at least 3 seconds.
Yeah, because that's enough time. Yes, this is another elliptical galaxy, another one of those. I think sweet galaxies to look at, and it kind of has like a nice little glow to it, and it is kind of more egg-shaped than the others. It's a neat old elliptical out there, M59, another for the lit.
So we got some more things in the chat. Okay, so we got why does the moon get bigger when it's closer to the horizon from Southbun?
Go for it, Hannah. You're the solar system person. Do it.
Okay, so it's kind of like an optical illusion, basically. So, gosh, I might have to have a guest speaker come in and explain this one. But
have somebody bail us out.
Yeah, can I call someone right now? Can I get a call in?
It's like is it what show? Calling somebody if you just
would you like to be a millionaire or something?
Yeah, I believe so.
All right. So my lifeline here is going to be Jose, but let me try to explain it. So it's like when it's closer to the horizon, it's going through a lot more atmosphere. And so I want to say it kind of acts like a lens to make it look bigger, but I don't think that's correct. So since this is
trial 1.
So since this is our last, it's not our last galaxy of the night. It's just the last galaxy of this half right now. We're going to be looking at
a little half, but real go right at the bottom. See a nice little edge on Galaxy 2 there. That's not
Oh
like
my
a
gosh.
smudge or anything. It's another galaxy, probably with like a barcode name, or most likely just an NGC number, but
Yeah,
it
that's
is
probably
there and
in
present.
the supercluster too. Okay. Well, we have, but Soft Bun says, I'm sorry, Hannah. And then Pandemic Watch says, the moon next to the barn looks huge. Up high, there are no buildings, as a reference.
Yeah, it's nice to have things of kind of to reference just how big the moon is on the horizon there, just adding back to that question. But as far as why the moon looks larger there, yeah, it's some optical trickery, and we have a lifeline, no?
Yeah, so do we want to call in and have Jose come in and maybe answer this question? And then they can also talk to us a little bit about what they do. And so, hi, Jose.
What up?
Hey, can you guys hear me all right? I'm outside.
Yeah.
Yes, you sound fine.
So here at Lowell Observatory, one of besides hanging out with all my peeps on the Godo doing this Messier marathon, I'm also a observer. So I get to do be on the research side of things as well, besides the public education stuff as well. And so I'm kind of used to staying up at these wee hours of the morning. This is not anything new to me at all.
You're an expert. You're an expert at staying up all night.
Insomnia.
Yeah. Absolutely. I know how to load up on the caffeine beforehand and all that, which is a necessity for observing.
Definitely.
But for those of you who are new to Lowell Observatory, we do research besides doing public education, and we have a separate facility where all of our data gets taken. We have actually two separate facilities that are outside of the city. And my primary stuff that I did was I would operate a telescope about 20 minutes outside of Flagstaff. It was a 42-inch telescope. It's about 50 years old, but it's still functioning like a dream.
That's a cool one.
Yeah. So this little 42-inch telescope, I've gotten to know very well. And so pretty much you go out at dusk and then you stay until dawn. So here right now for the Messier Marathon, we're taking shifts, and so nobody has to do the dusk till dawn except for some of our marketing team and our wonderful boss, Sarah.
Yeah, gotta have some caffeine with them probably. So that's absolute just.
I have so much tea. Sarah just said she had a lot of tea. If you didn't pick up on that.
No, we heard her. Hi, Sarah.
Yeah.
So, Jose.
Yeah.
We had a question that I don't think I explained it too well. Maybe you could answer it. Why does the moon look bigger when it's closer to the horizon?
It actually doesn't look bigger.
Oh,
so that's a little bit of a misconception. Yeah, and you can actually test this at home wherever you're at. In a couple days, we're going to have another full moon coming out. And what you should do is go outside at sunset, and you're going to see the moon on the eastern horizon. And just take your thumb and measure the width of your thumb against the width of the full moon, like what Jacob's doing on the screen and Hannah. And then you just measure, just eyeball it. It doesn't have to be perfect. This is astronomy. Everything is big estimates anyway. And but then go out at midnight. And at midnight, the moon is going to be high in the sky. And you're going to notice that it's the same width compared to what it was at sunset.
Wow.
And so it does seem bigger. It is a little bit of an optical illusion, but there's not actually a difference in how it appears.
Wow, thank you for explaining
I feel
that.
the same way when I look out, I'm like, oh, it looks so big.
Yeah.
But it doesn't actually change. But you'll notice the moon does sort of change color over the course of the night when it's full.
That is
At
true.
the very beginning of the night when it's first rising, you're going to see that it's going to be kind of a yellow or orangey color. And that's the same reason we have red sunsets and blue skies, is because of Rayleigh scattering. All of the light passing through the atmosphere, the moonlight passing through the atmosphere, is getting scattered. Those little short blue and green wavelengths, they go away, but those red wavelengths, they're bigger than the aerosols in the atmosphere. they're able to pass through quite easily. So it does look a little bit redder in the early night than at midnight when the full moon is high. It does look bright white, it maybe even a cool color.
Yeah, maybe that's why people might mistake it for looking smaller. Again, an optical illusion.
It's just, yeah, going back to the whole optical trickery thing. I mean, the moon's the moon. Like, it's weird enough having a neighbor so bright that it just shows up like that. But it definitely can get a little bit weird and confusing whenever it's near the horizon there. And as the color changes, I can definitely see how that contributes to the weirdness of the moon existing. And yeah, slap a text in there from the Twitch chat for anybody who didn't catch that. But yeah, I mean, people throughout history probably have had similar questions. And then these days we can just say, we're wrong because we're humans and we just think it does that. And it doesn't really. That's kind of that's the beauty of learning, is just knowing that you're wrong 100%. Because
I think some people can learn to admit it a little more often.
Absolutely.
Well, Jose, thank you so much for calling in. And Jose will be on a little bit later on during the night, showing objects. If you want to speak a little bit more on that, Jose.
I know that I'll be on at around 4 a.m. or so for those early risers. Yeah, 4 a.m. or so, and I'll be looking at a lot of clusters in the sky. And then I'll be the last person that's on when we're doing that last minute dawn rush trying to get these objects before the sun comes up. So
absolutely, that's going to be a rush to see too. I mean, it's going to be even a speedrunner's nightmare, because if you're going to try to catch all those objects at the latter half, it's going to be a little bit of pressure. So no pressure, Jose, but you got to get all those objects. You got to do it. No, you do your best there. And with that, I think we are going to get to switching myself and Hannah's position so that I can actually go over there and initial the board, so I can show that I was a part of this marathon and not just sitting over here in the room where there is, again, in the back, you can see there's bananas, there's chips, and I've only indulged in the bananas and chips. So yes, we'll do a little switcheroo.
Yeah, we're going to take just a 5-minute break. All right. So we'll be back in 5 minutes. So don't leave. We're just running around real quick.
Oh, I mean, you can leave if you want to. We're not holding you hostage. So
not
I mean,
at all.
Okay. Well, stay. Get cozy. Get comfy. I mean, it's like it's almost 1 a.m. here, so I don't even know what anybody was doing, and besides maybe falling asleep while watching, because it's late depending on where you are, or it's early if you're in a place like Hawaii. There's a place I'd like to be too. Tomorrow morning or something.
a little bit warmer. Flagstaff.
Absolutely. It's a little chilly outside. It's been a little chilly tonight, but we'll be switching. So see you all in 5 minutes.
Yes.
3 a.m. Oh, that's early.
Action.
Hi, I'm here. Now.
Hello, everyone. Welcome back after our 5-minute break. I hope that went by quick. As you can see, me and Jacob have switched rooms. I am now in the snack room, and Jacob's in the room with the telescopes.
I mean, yeah, there's telescopes behind me. They're pretty cool, but I think the board here is kind of what I'm truly here for. I'm gonna grab this Sharpie, and as soon as we get our next couple of objects, I'm going to mark them off like I did the work to capture them, when truly it was our wonderful operators out there working on it. I just talked about it. And I'm going to make my signature as obnoxious as possible, because absolutely.
Really?
Yeah. Why not?
Okay.
Right.
During the break, he was saying he was going to act like, what was it? A scratcher?
Yeah, like a scratcher ticket where you just like it's
completely
really
scratch it out.
ridiculous. I kind of want to just do that, but like I guess the opposite of a scratcher ticket. So like I'm filling out boxes, like a test.
Good job.
I'll figure it out. I do want to put my initials, but I think I'm just going to make them big. That's about it.
All right.
Yeah.
Want to go to our first one?
Yeah, let's go to our first one. Cool.
Let's do it. So this is interesting because this is our first non-galaxy of the past hour. So let's hear it for. Give me 1 second. For
M68. Beat you to it.
For M68. Let's see it for M68. Here we go. Which is a globular cluster. Let's see it. Globular cluster in Hydra.
33,000 light years away too. So we're going from like tens of millions all the way back down to just tens of thousands. So yes, drum roll as 15 seconds passes, and we'll get there. You know, we'll get that picture now.
Oh, there it is.
Beautiful.
That's a good one.
All right. M68, first non-galaxy. I have earbuds connected to this laptop so I can hear well. So I'm hoping that I don't pull the laptop down while I look for M68. Okay,
yes.
Awesome.
You know, I actually had luck where the poster didn't attack me like the other educators. So I feel a little lucky there.
Man, people have like really nice little signatures out here. Everything just looks like professional. And let me see.
Let's see it. Let's see it. I'm going to see if I can see it.
No, you're definitely not going to see this. Maybe you will.
I see it.
AI there where it's really huge.
Nice.
Up there.
Good job.
Yes, and it looks. The poster fell. It looks.
Did it get you? It didn't happen to me, but it happened to you.
No, and it's perfectly fine too, because that poster right there, absolutely loved it. I mean, it's going to be our little, I guess, thing for ourselves to show ourselves that we found all of these objects tonight. And my very terrible initials are going to be on there. So
yes. Okay. So real quick, I just want to say,
not in Virgo. Not in Virgo too.
Yes, this is in Hydra. It's one of the first non-galaxies. It's in Hydra. And something that I wanted to point out is that William Herschel actually wrote down this little quote about this cluster. And he says, he described it as a beautiful cluster of stars, extremely rich and so compressed that most of the stars are blended together. How poetic, man.
I mean, I guess that's poetic. That just sounds like a general description.
Literally just describing it.
Oh, stars!
I've had kids describe it more beautifully than that.
I had like one 10-year-old one time. I think it was before COVID really was like COVID. And it was, we were doing the public operations, and like this 10-year-old came up to me and was like, it looks like somebody spilled salt on this black cosmic table. And I stole it from them. I stole word for word that description because it was so beautiful. If I knew who they were and like saw them, because it's dark and I can't see everybody's face, I would have wrote that down on a paper and credited them, and maybe even like give them royalties, because that's beautiful. Like, that's great. That's poetry. But when you just say like, whoa, the stars are meshing together because they're so close, like, that's just really, Herschel? Really? Just
he had a way.
Much stuff for me to really dog on him. He's found more in the sky than I have, so I really do not have a leg up on this argument and or conversation.
Okay. Well,
unicorn snot. That's another one.
Yeah.
Sorry, I interject there, but unicorn snot. That's interesting. That's disgusting.
I actually don't know exactly what time we get off, so let's just do like 3 really quick, so we have more time to talk. Let's just get them done.
M5.
M5
is another one of those globular star clusters. It's going to be kind of similar to what we just saw, but this here is going to be considerably older. In fact, I believe this is one of the oldest globular star clusters in our galaxy. I had to confirm with my cheat sheet down here that was the case, and it is. This is one of the oldest globular star clusters. I believe there's 146 of them, and it's very, very beautiful. M5 is one that you absolutely cannot miss with a telescope whenever it's up for a reasonable time for you. For one of the people, 3 a.m. is not exactly a time to lug out your own personal telescope unless you're either crazy or very committed to doing that, which I could see myself as both because I used to do the same thing.
This is a good one. This one looks really nice.
Yes, it looks beautiful. And you know what it does not look beautiful is my signature and handwriting on that board. But that doesn't matter because I've made my mark on history. Cool. M5.
So, Pandemic Watch says, M68 and Hydra. Nice. Not Virgo this time. Wow, that's dense. Way, way more globular than most globulars.
True.
Yeah. That's why I like globular clusters. I think I do like them more than open clusters because they're so pretty and they're so globular.
Oh, I prefer them over open clusters. Like, open clusters can be pretty, don't get me wrong. Something like the Pleiades.
Yeah, I was going to say, that's like the only one I can think of.
That's like a staple in the sky. Mm-hmm. But still, these globs, like, if you could even see them with just a cruddy little telescope, it doesn't even have to be anything fantastic. Like, just the idea of what you're looking at being this ridiculous, that can sometimes make the difference in your own perception of what you're seeing and how much you're enjoying it, really.
Okay, 1, 2, 3, 4, 5. Okay, so I want to take this time really quick here to shout out all the people who have followed us on Twitch during the stream. We want to thank you guys so much for your support. So it's going to take a hot minute here real quick. But I want to, again, thank you guys again for all the support, for supporting us on Twitch and watching our live stream. We're trying to reach affiliate right now, so you guys are definitely helping us out there. So thank you to our followers. So thank you to JTrain1999, Cap Late Night, Pandemic Watch, Techie Matt 501, Sky Detective, Cedro, Mac, Beth Carr, Cowboy Tech TV, Ali L. Smith, Snowy Bullets, Fishenbach, Skywatcher Jim, Virtual One, Art by Words, Dammy Dome 07, Crimson Faded, Rent Free Corn, Haha Yeah Dude 1, TB Clarkson 3, a Vampire from U of A, RS Winter 45, In Camera Net, and Potato Sweets. Thank you to all of our new followers tonight. Thank you so much.
Yeah, if you heard your name, hit 1 in chat and then send it. Just do it.
Send a 1 in the chat.
Send a 1 in the chat very quickly if you want. That's up to you because you're the one sitting behind your keyboard and or phone keyboard. So that's on you.
Thank you to the people who were already following us and are watching tonight.
Absolutely. Yes.
Put a 2 in chat if that's you.
Already been here. Yeah, I'm in chat currently on my phone, so I can see everybody. So really quickly, I could also unfollow and then refollow, so I can be shouted out. But I don't need that.
Oh yeah, Pandemic Watch has such a sharp image. It improved at one point. The wind completely died down. There's like no wind right now.
I mean, it picked back up for a second. That's why it looked not sharp. But now it's back to normal because it's normal out again.
Whoa, it did die.
No more wind.
Okay.
It did die. True. Okay.
Let's go.
On to the next one.
Let's do. So this one, we're going back to the superclusters. So we took a little break, but we're going back to the superclusters now. So, to start off our trend of superclusters, let's go to M61. Give it up for M61. Here we go.
Funny. That's
M61. Guess which constellation it's in. I won't say it. Y'all gotta guess it.
I think anyone who's already stuck around long enough knows that yes, it's Virgo.
It's in Virgo. I didn't say it. Jacob said it first.
I had to say it. I mean, there was enough time for people to be able to make a thought in their brain as to where this may be. But M61, Hannah, I'm gonna knock this out on the board here. You wanna talk about it?
So M61, this is a little bit different. It's another intermediate barred spiral galaxy. This one's 52 million light years away. And this one's interesting because it has a little bit of like a little bit of tea behind it. So
what?
It was first discovered by Barnaba Oriani, May 5th, 1779, 6 days before Charles Messier discovered the same galaxy. And so Messier, he observed it the same night as Oriani, but he thought it was a comet. So
it was just a clash, and you refer to this as T because that's
it's a little bit of T because someone else observed it 6 days beforehand, and they both actually observed it on the same night. But Messier's like, "Oh, this is a comet."
All right.
What is a galaxy?
We're using the phrase T. We're appealing to younger demographics. Hello, fellow kids. I would never use that phrasing for any form of clash, but if you want to call it T and not a conflict, then absolutely.
I will call it T.
Sure. Sure, absolutely. Yeah, I mean, spiral arms themselves can sometimes be straightened, such as what you're seeing here, and it can cause for some really just unexpected views. And in the case of this galaxy in particular, it really is beautiful. And, like I said earlier, you could really point any telescope towards the Virgo supercluster area of the sky, and you'll find pretty much any awesome galaxy that you could imagine. And you could sit there and just scan the sky and see maybe not galaxies with such like intimate detail, but you would still be able to see like almost what looks like if somebody took a really bad eraser to a star and just tried to get rid of it and it just smudged. And that, another galaxy, one that's probably hundreds of millions of light years away, maybe closer.
This one's cool though. This one, I say that about all of them, but this one actually like has a really interesting shape to it. So it's a barred spiral, but like kind of like how Pandemic Watch was saying. I mean, the arms look very strange with this one.
Yeah, I mean, it
almost looks like a hexagon.
A neat kind of hexagonal shape there.
Do you see that? Strange. I like this one. Oh, we have a question. We have a question from Jonathan Walker. Better than a picture of a black hole, would you like to take a live look at a black hole before leaving? It's rising now in Perseus. I'm a little confused, I think, by that question.
Yeah. If you could rephrase that, if possible. Yeah, Perseus, from our perspective, from here where we're at, is well past set. That's something that's earlier on in the evening. And I mean, it's a beautiful constellation. There's plenty to see in it, but hit us with the rephrase. And, if it's something that we could work around, we'll get to it. But if not, then on to the next object then. Yeah. In the meantime,
Oh, this is a good one.
This is a great one.
I'll do the siren for this one. Ready? What is it? Oh, we didn't even say it. It's this one right there.
The Sombrero Galaxy. Yeah, for anyone who may have like a bad bit rate or something and can't see that little screen. This is a cool galaxy. This is a great galaxy because it's kind of named after what it looks like. It's a hat, and boy, does it look like a hat.
The sombrero look like
What? No, I didn't say that. I said it looks like a hat.
Oh, I thought you
It's a
said
sombrero.
why.
No,
does it look
no,
like a hat?
no, I did not. I did not say that. Don't.
Okay, good. Well,
Don't.
in case you are wondering why does it look like a hat? Well, Sombrero Galaxy is an edge-on spiral, kind of like this. So the edge is like facing us. And what we can mainly see with this spiral is the central bulge and the disk. And so that central bulge is bright that has a lot of dust and gas in it, is blocking out some of that light from the central bulge. And so it kind of gives the illusion that it looks like a sombrero.
Like a hat. And it's neat. And it's cool. And on an earlier note, Jonathan, no worries. No worries. I personally don't even know what constellations are really rising because like last year didn't even really exist for anybody. Like 2020, what was that year? Nobody knows and nobody ever will. So the stuff that's rising right now is really taking me by surprise. And it's kind of our first time seeing some of these objects through these telescopes in particular and camera on it. Like prior to, I guess a couple weeks ago, where people were staying out late, imaging, you weren't even able to see objects like the Sombrero Galaxy because they just weren't up yet. And now that we can, especially since we're staying up decently late to look, then we're able to see beautiful views just like this. And Sombrero Galaxy is just stunning. I mean, it has
it's
a
really
very
nice
discernible like dust lane across that bulge, and it's neat. It's a good galaxy.
Oh my god, Pandemic Watch says, hey, it's a UFO. It literally looks like one.
True.
That's that's a really good, oh my god, me never thinking that.
Actually, I've kind of thought it looks like a UFO slightly. I mean, it looks ominous enough to be one. It's kind of just there in space. It has
if you have like a good enough telescope and you're like looking for something and you find this, you'd be like, no, you have no idea what the Sombrero Galaxy is.
Absolutely, absolutely. That would be scary. Imagine being the first person to see like some of these objects and just try to like run it through your brain what you're looking at. I mean, at first it was like, oh, these are just nebulae within our own galaxy, within the Milky Way. And then after a while, with work that was also done up here at Lowell, we were able to, by we I mean earlier scientists.
Yes, long time ago. Actually, there's history with the Sombrero Galaxy and Lowell. Again, I might need a lifeline here, but I believe it was VM Slifer who took pictures of Sombrero Galaxy. Yeah, Joseph's giving me the thumbs up over here. Yeah, VM Slifer.
Yes.
Yeah, so we have some here, wait, we have a comment. I can't hear.
We cannot type. We're only audio over in this section here, but it sounds like everything on the other end, people operating, are getting the audio fine. Could be an issue for you though, which is unfortunate. I mean, the internet's the internet. I sometimes try to log on to just watch a movie, and then 3 seconds later, I can't anymore. It's the internet. It's not perfect yet, but we're getting there. We went from dial up to here very quickly. So maybe in like 3 years, we'll be able to load up Google quicker than we even ever imagined. Who knows?
I've been seeing people say really funny things on Twitter and stuff where they're like, on Earth, all there was water and rocks and dirt. And now we have like Wi-Fi. How did we get from that to Wi-Fi? I think that's funny.
A lot of thinking, hard work, and probably stress, I would imagine too. But yes, M104 again, the Sombrero Galaxy, a very, 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 very beautiful galaxy out there in our universe. 29 million light years of distance once again, and like again.
All right, so I think we should move on. We have 3 more objects left in this little Twitch segment here until again around 2:10. So. Yeah, let's go. So we're going to go to M60.
M60. That's it.
Did
M60.
Did you mark off sombrero on the poster?
Yeah, I did. I have my giant J-I right there on the poster.
Nice.
Yes.
Nice. Did you make the sombrero part the eye?
Oh. Actually, I could have totally done that. Oh,
missed opportunity.
I guess. Yeah, I guess I could have done that. Dang it. Okay, whatever. The past is the past.
The past is the past.
Yes.
Well,
best to move on and keep living than to worry about making a sombrero galaxy an eye.
So this one, I want to talk about it. I want to talk about this one. Okay.
You want to?
Yes, because this one is an elliptical galaxy that is 57 million light years away. But what's cool about this is so that bright dot in the center, that's the elliptical, but right next to it, we have NGC 4647. So they're like this twin pair of galaxies that live next to each other, except the NGC 4647, that's a spiral, and then M60 is an elliptical. And so this is actually a pair of galaxies called ARP 116. And I thought that was so cool that it's called ARP. So Kendall was actually talking about this earlier on in the night. And so there was an astronomer, Halton Christian Chip ARP, and he is known for his atlas of peculiar galaxies. And so he thought these were galaxies that were like interacting with one another or merging. And so he made this catalog, and it's called the ARP catalog. And so it's an ARP pair, 116.
I've heard of the ARP catalog, but I didn't know the person behind it. That's actually super interesting. Dang, that guy's my hero now.
The guy.
Yeah. Crazy galaxies like this, or really crazy galaxies in general, are super cool to look at. And one of those objects in particular, M82, which get earlier this evening. Let me look.
Yeah.
M82. Yes, M82. It's one of my favorites ever. And it is classified as kind of one of those peculiar galaxies just because of what it has within it. But I believe that was talked about back then. We can do M82 again if you like. I would love that if possible, because that's
why not?
My favorite galaxy to look at with optical telescopes, at least. It's very neat and very, very beautiful and peculiar in its own way.
Yeah, peculiar galaxies are really cool. There's some in the NGC catalog. I can't think of any. I think there's like I don't even know if this is a peculiar one, but like the antenna galaxy or something, or the tadpole.
I think it's the tadpole. They're like galaxies combining, but they look really strange. They look like hooks.
This is a good one. Cigar.
The Cigar Galaxy. Yes, this one is one of my favorites to view.
I have one that I think it might be up, but that I want to see. Is it a Messier object? I don't think it is. The Whale Galaxy. Let me look it up.
The Whale Galaxy.
Whale.
It definitely does not show up as the Whale Galaxy.
No, don't look up Whale Galaxy. No, it's not a Messier object. It's NGC 4631.
NGC 4.
There we go. Is it up? Is it up? Please tell me it's up.
It just said it was up.
Oh, I didn't pay attention. Pandemic Watch says, yes, I love the ARPs. I did not know where the name came from. Thank you for that. Yes. Oh my God. So the Whale Galaxy is like straight up right now. This is my favorite galaxy. I love this one because it looks like a whale.
Wow, I wonder how that would have been a conclusion reached.
Space whale. I love it. It's such a cool one. Yeah, this isn't part of the Messier catalog. This is just one that I wanted to look at while I was here. That's cool. Look at it. It's a little whale. Hitchhiker's Guide whale. Yes. Oh, that's such a good picture.
That is a beautiful picture, actually. Since it's directly up, there's like nothing that really the light has to go through. And by nothing, I mean a lot of atmosphere. It's just compared to when it's on the horizon.
Yeah,
we might as well consider it nothing. That is a beautiful edge-on galaxy.
Yeah, again, I love that one. So we kind of derailed a little bit from the Messier. but again,
absolutely.
we have 40 minutes left. So if people have recommendations or suggestions for objects, if you
just want to chat.
Yeah, or if you just want
to talk. We're here.
Yeah. So I think people, there's someone asking for a black hole. Again, we won't be able to look at a black hole, so we don't have a nice enough camera to do that. We have looked at many objects already that have had black holes in them. All the galaxies that we looked at, they have black holes in the center of them, but we won't be able to actually see a black hole with our camera.
I mean, that's true. I mean, we could always also point the telescope towards something where one of those radio sources may exist, and you might see just a star or nothing. That's usually how it goes. Something like, M87's central supermassive black hole that we had a picture of a little bit earlier, and I mean, it's a picture that you can find on Google too. That required a lot of data taken from many telescopes around the world, so it wasn't exactly like somebody sitting down at one single telescope and aiming 7 and just zooming in. There it is.
There it is.
That's a picture. Now that right there, that required work. That
took years of
and just deciphering data. And I believe there is so much data from all of these different telescopes that the entirety of like these data packets had to be transported on like hard drives, actual hard drives, instead of sending it to some cloud service where you can work on it with your peers. You couldn't do that because just to even process this lowly image here, you needed all that work, that's crazy. It's a lot of personal application to one very specific goal, and that is super commendable.
Well, what I like about this picture is that it wasn't like one, like you were saying, it's not like one person worked on this though. It's this whole team of people from all over the world, that came together to make this picture. So
absolutely. And there were some very specific people that played key roles in getting this picture kind of out there and even working with the data. And each of them are kind of recognized all on their own whenever you look up, the team, because there were team leads. Just like any team, you have somebody kind of the front of the ship or whatever. I don't even really know a good comparison there, so I'm not even gonna worry about it. But they did good. They did great, and there's definitely more to come in the future. That's for absolute sure.
Okay, so we have some recommendations for objects. So let's do the Owl Nebula. Owl Nebula. So yeah, earlier it was like really cloudy. It was like really windy. Couldn't really get a lot of like really decent images of some of these really faint objects. So let's try to get them. Owl Nebula is really cool.
Owl Nebula is neat. It was maybe one of the first nebulae that I looked at when I first started learning to use the telescopes here a few years ago. I think it's already been, 2020.
Yeah, it's been a long time.
So it holds a little special place in my heart in being something that when I saw it through the telescope, I was like, that's it. But whenever you're able to take pictures of nebulae with these cameras and not use telescopes that are not only ground-based, but ones that I have to move by hand. In fact, I think I actually used that telescope right there.
Look at
the Canon right there.
That's funny. That's a good one.
Yeah. I used that telescope by hand to locate this object, and I had a blast losing my mind because I didn't know whether or not I was seeing it, because I was getting used to actually using telescopes that weren't ones you can buy on Amazon. So it was kind of a steep difficulty curve, but it was really worth it, and I absolutely loved it. And I was like, wait, that is a nebula. And
it's so crazy. No, I totally understand what you're saying. The first object I looked at was the Ring Nebula through, what was it called? The McAllister. And I was like, oh, that is so crazy. That you're actually seeing that. I don't know. It just blew my mind. But Pandemic Watch asked for the Stevens Quintet. I can't.
That's a winter sky object, no? Am I remembering wrong?
Yeah, I don't know if it's up.
I swear. That is a really great thing to look at. And if I remember correctly, it's near the Deer Lake Galaxy, which, if I also remember correctly, set a while back.
Okay.
But going back to what you were saying about the Ring Nebula, Hannah, I'm not going to take credit for this because it's in chat for us. It's in our little secret chat that we have right here. That will be actually viewing at around 3:15 a.m. for us. So in a few hours.
Yeah, in just a few hours, yeah, you'll be able to see what I'm talking about. And when you see this, is the Ring Nebula is a really good object to see with your eyes, like through a telescope.
Definitely.
It's so crazy.
I mean,
Owl
is
number
still
4321 asks, anything observable to the south? I have my telescope, but from my balcony, I can only look south. So, there's a few things you could look at in the south, and it depends at what time you go out, because again,
and where you are too.
Yeah, exactly. So it depends on your location and the time, because early in the evening, you can get some of the constellations that are setting. So Pleiades are going to start to be setting that way. Same with Orion and Taurus. But if it's a little bit later, you're going to have a whole different group of constellations over there.
Absolutely. And if you're in good old Arizona at this time exactly right now, you probably could look at some stuff near Corvus, which is one of those greater constellations in the southern sky. And around that area, you're going to be able to find many galaxies, even some little star clusters. There are many catalogs that you can kind of peruse through at your own heart's will. And you can find a bunch of objects, even with a smaller telescope, that you could be absolutely wowed by. And I'm usually surprised myself at like how many objects within some of those catalogs that, don't fall in line with Messier, you can actually see quite nicely with just some telescope on a deck. And yeah.
Oh, they say my biggest issue is SoCal light pollution too. Yeah, that's true.
That'll absolutely do it for you. Yeah. I think some of the star clusters should be able to come through at least a little well in the Southern California area, but
yeah,
to what extent I may not know. I've only been to SoCal like twice in my life, and it's only like a 4-hour drive away. So I should, like, as soon as the pandemic's over, I totally want to go back and just like walk around in a place that isn't here. So that would, it's kind of the dream right now.
Well, what I would recommend is to, I don't know how achievable this is, but just to drive a little out of town somewhere where you're completely out of the city, and then you'll get less light pollution. That's the biggest
recommendation. That is, if you want to lug your telescope around with you, sometimes it absolutely is worth it. Like if you can get out to those deserty areas in some safe location where you can just set up shop with your little telescope and just look around the sky. I mean, it could even be a big telescope. I don't know. You can see so much.
Yeah.
It really is incredible just like stepping out of the city, what you can actually see. And here in Flagstaff, I mean, we are able to take for granted.
Top of the mountain.
Yeah, we're able to take for granted not only like where we're at just as a matter of geographic location, but Flagstaff as a city actually has many requirements in place for businesses, homes, etc., to kind of manage their light output so it keeps the sky dark.
That's really nice about Flagstaff. We're so spoiled here, really.
We absolutely are, and there's a lot of folks, including me, who take it for granted, and wow, do I really regret it when I go literally anywhere else.
Anywhere. I know I go home, sometimes I go home and it's in the city and I'm just like, wow, like I miss the sky in Flagstaff. I can't see anything at all.
So we got a question. What keeps the North Star stuck at exactly north? Hannah, you want to?
All right. So that's a great question, Stockman. So the North Star is called Polaris, and the reason why it's called the North Star because it's in the direction of true north, and that's because the North Pole or axial tilt of the Earth is just coincidentally aligned up with Polaris or the North Star. And so like, okay, here's planet Earth at a tilt, and it just so happens that the north of it is pointed at Polaris here. But over time, the Earth has a little wobble. So it does this little wobble motion. So Polaris wasn't always the North Star. And so it won't actually always be stuck at Polaris. It'll move around to, a blank area of the sky or to another star. So I believe at one point it was at Vega. And so again, it has this little wobble here, this little tilt. And so that's the reason why Polaris is the North Star, really, is just because of that tilt of the Earth. And it just so happens right now to be pointing at Polaris. But what's really cool about it being the North Star is that if you can find it. So if you can find the Little Dipper and figure out which one is Polaris, you know where north is always. That kind of orient yourself at nighttime if you have a clear sky. But also, I think it's cool that because it's true north, if we were to point a telescope at it 24/7, like all day, all night, it wouldn't move. And that's because it's like true north. So all the stars in the sky move around it. And so, yeah.
At least from our perspective.
Yeah, from our
it's all relative to where we're looking. And yeah, we got Vega coming up kind of next in our I guess queue of stars be in that area for us, but I think that's like 20,000 years down the line or something.
Yeah, it's going to be a while. It's not like something that happens regularly. It happens in 1,000 years.
That would be crazy if it happened regularly. Our
Earth's like wobbling
like crazy. So luckily that's not happening because I do not know the implications of that.
It's going off. It's popping off.
At all.
Yeah.
So
I'm excited. Vega
get-
is my favorite star. So I'll probably tune in for that. I love Vega.
Let's get to our next galaxy.
Yeah,
Let's do it. Last galaxy in Virgo too. So we don't have to ask that.
Stop! I didn't get to pull up my horn.
M49. I'm going to say it before any horn goes off because it's not funny.
Nice.
49. We're going to it. This is again the last Virgo galaxy. So we also won't have to ask that weird running bit where it's like, where do you think this is? Because I told you. I already told you, and that's all that matters here. That's all that matters right now. I see.
Yeah. So this one is an elliptical galaxy.
Another elliptical. No, that's not true. Ellipticals are fantastic and great, and I love them, and I will die on that hill. That's all I got to say. I will die on that hill.
Well,
and let's see.
What's special?
Million light years in distance.
What's special about this one is that instead of it just being a regular elliptical, this one's a giant elliptical. Wow.
But that's awesome. That means that there is a lot of mass attributed to this galaxy, and its supermassive black hole is most likely proportional to that galaxy's mass. So something like our own Milky Way supermassive black hole is going to be relatively small compared to something like this galaxy. And ellipticals come in various sizes, as I think there's a galaxy out there, if I remember correctly, IC 1101. It's either 1101 or 1011. It's numbers. I haven't seen it in a while. I do not think it's anything that really can be seen from here, but I'll tell you the story of it. I think as of right now, it's the largest galaxy in the universe that we know about, at least. And I totally forget its proportions, but it's something like a few million light years in diameter compared to something like our Milky Way, which I believe is around 120,000 light years in diameter. So kind of just putting something like our Milky Way in comparison to a supergiant elliptical like that, we are absolutely tiny. Like, it's scary because our galaxy is already huge. 1 light year, if this hasn't been kind of drilled into people's minds yet, is about 6 trillion miles. So being able to say, like, oh, we live in this neighborhood that's 120,000 of these light years in diameter, like, that's big enough that that light takes thousands of years from each end or even each little star to reach us for us to see.
Well, okay, let's put it in a different perspective, because I don't know if this has been talked about tonight, but when we're talking about these distances and like how Jacob's saying, how it's like thousands of and millions of light years away, that means that we're literally looking back into time when we're looking at these objects. These objects aren't even in their place anymore. They probably look completely different. They're not in that same place. And that's because we are literally like looking back in time. It's taking millions of years for that light to reach us. So.
And I'm going to excitedly interrupt because apparently IC 1101 is visible. Let's do 1101 because I believe that is the larger one, if I remember correctly. I just, like, as a kid would always look it up and I'm like, whoa, this is crazy. So yeah, we're going to give it a shot. It's a 14th magnitude object. So seeing this is a flip of a coin, but we've also really never gotten the chance to try. Again, pandemic. And that really shut down our operations last year around the time that these types of objects would rise up, because we're looking kind of outwards towards this supercluster of galaxies. And these ellipticals in particular are plentiful out in that direction. But yeah, it's really far away.
Well, again, there's so many galaxies in this supercluster. There's 1,300, and that's just an estimate.
And that's plenty.
That's plenty. Yeah, that's a lot.
It was IC 1101. Cool. Okay. Let me look up some nice little facts about this real quick, because I've totally forgot. And
this is a cool one, though.
Wow, distance from Earth about 1 billion light years. Like it's
really
far.
1 billion?
1 billion light years away. A magnitude 14. Wait, is that it?
Yeah, that's it.
Oh my.
1 billion? We're looking 1 billion light years into the past.
This is the furthest thing we've ever seen. This is the furthest thing I've ever seen.
This is the furthest thing that Lowell has ever seen.
Wait, no, that might not be a true statement, but that is definitely the furthest thing that I've ever seen in my life. That is 1 billion light years away.
The Mellencamp.
Wow.
That is crazy. That 1 billion light years, that's crazy. I'm over here, like, in this little red room, like, just thinking about 1 billion light years away.
That is incredible. So yes, that there is one of the largest known galaxies, if not the largest known galaxy in the entire universe, to the point where from 1 billion light years away, like this light took a fraction of Earth's entire lifespan to reach us. You can still see the elliptical glow. I'm actually blown away by this, and this is probably the coolest thing that I've seen in a very long time. Wow. That's all I've got to say is just wow. Like that little kind of that little elliptical glow, that lenticular-like disc, it's far away. And,
all I want to say right now is elliptical galaxy. Boing, boing, boing.
That would ruin the moment. Yeah, as said, like
that's all I can think about right now.
1/14 of the way to kind of our universe's inception was this galaxy's light. That's ridiculous. Okay, sorry, that was a really humbling moment to be able to even see this in the first place. That's crazy. That's incredible. Wow.
Well, I'm glad we got to look at that. It looks like people are super excited about that in the chat too. Everyone's like having a blast.
Jeez. Okay. Yeah, that was cool. Can you guys snap that out there? Can
take a little
snap that for me. I kind of need
a little
that.
picture.
I need that for later. That's crazy. Cool. Awesome. Wow. Okay. Well, wish I could mark that on here, you know?
Yeah.
Saw something 1 billion light years away. Cool.
Jacob in chat says, I am super excited about that.
Oh, you're telling me.
There's blank squares at the bottom of the poster.
There are blank squares. I'll maybe I'll write that later. Who knows? That's crazy though. Okay.
So
awesome.
Soft Fun says, are you guys getting tired yet? Not at all. I'm wide awake. I'm so excited.
I'm all right. I had like enough caffeine to probably like just put a small animal to rest. So I'm chugging along. I'm having fun. And seeing something like that really just gets me. Like I woke up. I had a second wind from just seeing this object.
Yeah, I was gonna say I definitely got energy looking at that object too, but that's so funny.
Absolutely. So M13 is going to be kind of our last object of our chunk of time.
Yeah.
Here. So let's get to that so we can talk about this, because this object in particular is it's very beautiful as well. And the Red Bull Observatory run. I think Red Bull's too chemically.
The Red Bull Observer. That one science kid says to rest, like permanently. Tranquilizer caffeine.
You take it as you want. I would say tranquilized, because that's kind of the context that I'd like to put out there. But
okay, well,
This is the Hercules Great Cluster. So there's some really interesting facts about the Hercules cluster. So for one, this is up right now because that's blows my mind. For one, that Hercules is up, that we can see this. Two, the 1974 Arecibo message. So, okay, rest in peace, Arecibo. Yeah.
That happened recently, right?
Yeah, that happened really recently.
So just cable snapped and then bam.
Yeah, that was so unfortunate. But there was this message that Arecibo sent out to the, and it contained information about the human race, DNA, atomic numbers, Earth's position, like all this different information. And so they like beamed it to M13. But the funny thing is by the time that information gets to M13, M13 is probably not going to be there anymore.
Yep. And
it's 22,000 light years away, by the way.
It's far enough. I mean, it's still gonna kind of be there.
Yeah.
I guess, you know?
Was Carl Sagan in on that message? Yes, I do believe he helped like write some of the things. There was lots of things that was all that, but
I mean, I was gonna say too. Also, Carl Sagan was involved in a lot during that era. Yeah. Like anything involving space, really. Like Carl Sagan at least knew about it. I mean, that dude. There's a reason why he's so influential, and it's not just because of his show.
Carl Sagan filmed an episode of Cosmos here at Lowell Observatory.
True. I
in
totally
the Clark.
That. In the historic Clark telescope.
Every time I think about that, I go into the Clark and I'm like, I touch the chair. I touch the chair and I'm like, Carl Sagan said.
Yeah, it's easy to get starstruck when you realize kind of just the personnel that have come through here at Lowell and just either like even walked around or worked on some handful of projects here, especially with things like the moon mapping that went on here on campus.
Yeah, there's lots of things.
Apollo mission.
Yeah, there's there's So I used to TA for some of the astronomy classes at NAU here, and I recently guest lectured one of them. And when I was a TA, I didn't realize all the history that Flagstaff, Arizona has with astronomy and just everything. And so I always tell the students, I'm like, you guys don't know how lucky you are to be in Flagstaff with this rich history. You know, you have Cinder Lake with the Apollo missions. We have USGS who helped out with literally the Apollo missions. You have Lowell that did all, again, the Apollo missions, that did the dark matter stuff with Vera Rubin, and VM Slifer with Andromeda and the expanding universe, and like all these different things. So it's just like, there's so much. Carl Sagan, I mean, all the Apollo astronauts over here, like there's just so much. So
I mean, even beyond that, we still get people up here that like just kind of takes me by surprise. I think it was like a few months ago for one of the private programs, we had some guy. I'm terrible with names, so hey, astronaut guy who came up here a few months ago and said hi to me and like told me about this. I'm so sorry. I don't know names. I forget Hannah's name sometimes, and that's just how it is. But yeah, I mean, it's very easy to, again, no pun intended, get starstruck whenever you get to meet people who are of such influence to just a lot of people. And it's great to know that kind of like those ideals and kind of that those personalities have kind of been passed on through generations. Because, you know, Carl Sagan, that guy taught. Like he was able to teach, and there are a lot of people out there that can convey information well. Don't get me wrong, but being able to really enjoy the entire ride is something that's special to a select few, and that's kind of where you get your big science personalities from these days. And you know, there's a lot of people kind of carrying on that legacy, and being able to meet them or be a part of something that they're a part of, or even just like knowing that they've been here or said hi or even just know somebody here on campus. It's kind of weird. It's kind of strange. Kind of awesome too.
I know. I've met a lot of astronauts being in Flagstaff. It sounds so weird. Like,
I just met one,
I've met a lot of
I thought he was just a
astronauts,
regular guy. I was like, "Hey, what's up? Welcome up here. We got some awesome objects to see." And then after a while, he's like, "Yeah, I've been on the ISS," and I was like, "Okay, I've been to like 3 cities in my life, so you're way ahead of me."
Oh my God, Jacob in the chat says you guys are my big science personalities.
I wish.
Oh my God, that
Maybe
was
someday.
so sweet. That is so sweet. Thank you, Jacob.
Absolutely.
Yeah. But so I think we're going to be wrapping up here in the next 10 minutes. So again, if anyone has any final thoughts, any final requests, more than happy to address them. But we have hit all the Virgo super cluster things. Oh my God, what was that? Percival's ghost right there. Something.
So I don't know what you're talking about.
JB was in the background. Sorry.
Okay. It seems like we've got some homemade Mexican hot chocolate waiting for us after this. So I am more than happy to get a sip of that afterwards. But yeah, I mean, any questions, any final thoughts, any conversational topics that you want to take in the next 10 minutes, this is up to anybody at all. If not, we could awkwardly stare here at the screen until something is said. And
again, follow us on Twitch. And so I'm going to shout out the few people who follow. We had one person that followed us since I last shouted them out, which is lost number 4321. So. Oh, and Pandemic Watch says Armstrong gave his final talk there. You know what? That is true. Watch says Armstrong gave his final talk there. Oh, I can hear myself echoing. True.
That's scary.
Was I talking too loud? I could hear myself talking there. Thank you.
I think somebody in our secret chat was unmuted.
Yeah.
Temporarily. So shame on you. Just kidding. I've done that while in Zoom classes. So it's all right. You know, everybody.
Yeah.
I mean, I mostly make goofs. So.
No, but so what I was trying to say, but then I got distracted because I could hear myself. When the LDT was being built, I believe, I think it was Armstrong was really interested and involved in the LDT. He was really excited for it to be built, and so I think he came and visited it, and then he passed away a week later or something like that.
Yeah, I mean, just having people come up here in general, really, to oversee certain projects like that, like the LDT, that was a massive project. That is a ridiculous telescope, kind of just overshadows pretty much any of the telescopes we have here in size, but for good reason, because, there is a lot of research being done on that telescope in general. But our little scopes here are absolute just little powerhouses that I love with all of my heart, because we can get images like this. And we saw a galaxy that was 1 billion light years away with our scopes here, which, you're never going to hear the end of that one, Hannah. And it was an elliptical galaxy too. And that was probably the coolest thing that I've seen all night. So yeah, elliptical galaxies rule. And that is the correct opinion.
Well, that is an opinion. That is definitely an opinion. So thank you so much for everyone in the chat leaving such kind words. We really appreciate it. And, we're so happy to be here to be doing this stream. And again, we have such wonderful educators coming on after us. We have Claire, we have Jose, and we have Ariel. So I think those are the other half of the educators there. So yeah, we have another great group of educators coming in to talk to you guys about the cool objects coming up. And so again, not to be a hater on elliptical galaxies, but there's some really cool nebulas coming up here in the early morning. So I would definitely tune in to those because there are some really crazy objects.
And then, yeah, for my little half of that as well, yeah, thank you everyone for joining tonight. And yes, seeing that in the chat as well, Kevin Schindler's books. I mean, Kevin Schindler is just the best. I'm going to put that out there. Kevin Schindler is just, those books are filled with so much information that like I could read them 50 times over and still get more information. It's ridiculous. And yeah, I would just like to thank everybody for coming out tonight, all the night owls. You guys are awesome. You guys are awesome. And yeah, we got some objects as well.
Yeah.
And I love nebulae. I think they're great. But
They are
to
cool.
kind of start to wrap things up, always remember that liking elliptical galaxies is a valid thing, and you're all right for liking those types of objects there.
Well, we're at 68 out of 110 Messier objects. I think that is so crazy. So thank you everyone for sticking with us so far. We're going to take a 10-minute break here, again, to switch out the next group of hosts. Please give these hosts your love and support. They're going to be here until so show them love. And thank you guys again for staying with us.
I'm happy that didn't pick up. The audio didn't pick up the air horn there, so life is good. We go to something on a high note. So perfect.
But thank you, everyone.
Okay, hello everyone. Welcome back to the Messier Marathon of 2021. So Lowell Observatory's Messier. I'm Claire. I'm coming in on the second half of the night. So this is my first public-facing shift. So I'm super excited to be here. A bit of a recap for the night. And so we're at about 68 out of 110 objects. So making some pretty good progress so far, which is exciting. And so we can go ahead and just jump into a pretty nice galaxy here. I know the past couple of hours have been galaxy-centric, but they are just so amazing. So I'm happy to start with one. So this is what we call M83, or the Southern Pinwheel Galaxy. That's because it kind of looks like the regular pinwheel galaxy M33, which has already set, but it's a really nice spiral galaxy with a nice bright galactic center. So this galaxy is located in Hydra, and it's about 15 million light years away, so a pretty good distance. And it's at about a magnitude 7.5, so not super bright, but it's actually one of the brighter galaxies out there, especially compared to some of the magnitude 14 galaxies we were just looking at. So this one's well within reach. And this was discovered by, it wasn't actually discovered by Charles Messier right off the bat. He actually added it to his catalog after someone else discovered it. Nicholas Louis Lacaille, I believe in 1752, was the one who discovered him. So some of the objects Charles Messier, at least on the Messier catalog, wasn't always the first one to actually observe them, but he was kind of the one to really catalog them in a major way. So that's why we still call them Messier objects. So this is a Bayard spiral galaxies. This one's pretty cool because there's hundreds of supernova remnants, and we've observed 6 supernovas within this galaxy alone. So this one's pretty active in terms of supernovas, which is pretty cool. And when we look at these supernova remnants with telescopes such as the Hubble Space Telescope or things like that, they kind of look like little bubbles in the galaxy. So if we have a really high-powered telescope like the Hubble, we can get into a little bit more detail than what we're able to do here. But they kind of just look like little bubbles of gas and high energy in those areas, which I think is pretty cool. So that's with the Southern Pinwheel. Another cool area with this galaxy itself is that NASA's Galaxy Evolution Explorer, which is one of the 2008 missions, found a lot of star formation happening in the outer regions and dust-thick areas of the galaxy. So that whole mission and scientific investigation was looking into, well, galaxy evolution, as the name implies, but star formation for galaxy evolution is one of the most important aspects. So we look at we kind of combine the science of stars and then galaxies together to kind of understand how galaxies evolve over time. So that's kind of what we did with NASA. But we wanted to get this one right off the bat because this one is, again, more southern. It is called the Southern Pinwheel Galaxy. So we wanted to make sure to start off real nice with this one. And it's really pretty. For me, these barred spiral galaxies, they usually have a little bit of purple and blue colors, which I think is really nice, and you can definitely have a nice, clear, distinct shape. And with this galaxy in specific, and also which relates to the actual pinwheel galaxy, again, M33, we're looking at it more face on. So we're looking at this galaxy kind of as you would stare down at a pancake on your breakfast dinner plate, and instead of just looking at the pancake from the side. So we're looking at it face down. We can see the entirety of the galaxy, which is really, really nice. So yeah, I love galaxies. They're super fun. Just to warn you, the next couple of objects we have are mostly all globular clusters, but globular clusters are always great and amazing. So I'm going to go ahead and sign off on M83 on our little sign back here, just so we can add another number to our list. So M83, the Southern Pinwheel, I believe it's just over here. Sweet. Always fun to do that. Super excited. For those of you still sticking with us at this 2 a.m. mark, let us know if you have any questions. And if you have any questions, any requests too, we still have some time in between objects that if you have a unique galaxy to look at or any other of these objects that happen to be up at this time, we're always happy to take your requests and find new objects. So most of us haven't looked at the objects that you guys usually request, which is kind of fun. So we get to explore things together, which is really cool. But let's go ahead and move on to the next object, which is M92. So this guy is a globular cluster in Hercules. So we left off the Twitch chat with M13, which is the Great Hercules Cluster. I guess we can call this one the less cool glob in Hercules, although I'm sure it's still pretty cool, but it's not the main known one in Hercules, not the M13 Great Globular Cluster. So this guy is about 26,700 light years away, which is a pretty good distance. Sounds exciting. So just a little info about kind of the telescopes that we're using. If this is kind of where you're just jumping in here and you haven't gotten the initial spiel yet, so we're using our plane wave telescopes out on the Giovanni Open Deck Observatory. And so we have a couple of our telescope operators doing that for us. So I'm out here just kind of in a warm room talking to you guys right now while someone else is braving the cold and doing all of this for me. So big shout out to them. But you might notice that when we move the telescope, the stars become streaks. And that's just because we're taking a picture while we're moving the telescope. And so that's what will happen. And that's what's created by that. But sometimes it's kind of fun to see the patterns that happen with that, but that's kind of just what that is. So yeah, here's M92. This is a pretty good globular cluster. It looks pretty dense in the middle. There's a lot of stars kind of out in the region. So this one has about 330,000 stars in it. Now, to go back a little bit, a globular cluster is different than different clusters in the skies, such as an open cluster of stars. So an open cluster of stars is usually loosely gravitationally bound or not really gravitationally bound at all. And usually those stars are pretty young and formed from the same gas cloud or stellar nebula. So they kind of start off as like one like young, tiny, happy family of stars. And then over time, these stars grow up and spread apart from each other, just like siblings in a family would grow up and then move to different parts of a country, kind of like that. So they kind of just move apart over time. But these guys are definitely gravitationally bound to each other. So we use the term globular to kind of connote that idea that these are really compact and dense and much more compact and dense than open clusters. And they kind of look like diamond-y baseballs in the night sky. I've also heard the term frozen fireworks or like little droplets on a spider's web. So if you have any ideas of what a globular cluster looks like to you, put it in the chat because I'm always happy to find new ways to describe these things. Globular clusters are definitely some of my favorite. So this guy was discovered by Johann Albert Bode, who discovered a couple of other of the famous objects in the sky. This was in 1777. And this is one of the brighter globular clusters in terms of magnitude. It sits at about 6.3. This globular cluster is just barely visible to the naked eye in really, really good sky conditions. So you'd have to be way outside of a city in order to see this with your naked eye. And even then, I'm sure I probably wouldn't be able to see it. So really good sky conditions. You can just faintly see this, which is pretty nice. So we believe this is actually one of the galaxy's oldest star clusters at about 11 billion years old, which is pretty old. So an interesting thing about globular clusters is that we have a couple theories of how they came about in the first place. So unlike open clusters, which again form from those stellar clouds of gas or stellar nebulas, these guys really, we think, shouldn't really exist in the galaxy at all. They're kind of an anomaly. And so actually the remnant cores of galaxies that our Milky Way galaxy has cannibalized or eaten over time from these smaller galaxies. So these would be just the remnant cores of those galaxies, and they're spread across our galaxy right now, and these are basically just what's left. So that's one of the main theories of this, and I think it's kind of cool. We have a couple astronomers here at Lowell who study galaxies and galactic cannibalism, and if you go back to the YouTube after this, after you're done with the Messier marathon, perhaps tomorrow after you've taken a nice long nap, but we have an astronomer, Michael West, who about this on our Meet the Astronomer. So if you're interested in learning more about galactic cannibalism, that's a really good resource to check out. So this globular cluster has about 109 light years in its radius, so it's pretty good. That's a pretty good radius for that. And kind of an interesting thing too, I'll kind of mention this throughout the night, but both Johann and Messier call these objects nebula upon discovery, among many other objects such as galaxies and other star clusters in the sky that were called such nebula, but now that we know them quite distinctly from what we would call a nebula nowadays. So it's kind of interesting. I think this is a bit of a remnant of the type of telescopes they were using, so maybe a little less magnification and technology that we have now, so we can resolve things a little bit more, but to them a lot of things probably looked like nebula with stars like interspersed throughout. So that's kind of something to keep in mind, because they often called things nebula even though we wouldn't really call them nebula right now. So it looks like we have a request for the let's see, the Tarantula Nebula. I think that's the name of one of the objects that was requested, the Hani's Bohrwarp, the Quasar Ionization Echo. So it looks like it's not up, it's in the southern hemisphere, so we won't be able to catch that here in Flagstaff. We are in the northern hemisphere, so I believe it's in the Magellanic Cloud, so we probably won't be able to get that. I just got word that Hani's Bohrwarp is up, but the Tarantula Nebula is not. Sorry, that was my mistake. So I think we're gonna try to look for that. We're going to NGC 2497. So I think that's where we're going, or IC 2497. So we're just gonna search for that object. We have a couple different search features on our plane wave telescope. So that's what you can see our operator doing, is just kind of going through those search features in order to get the correct object for that. So I've actually never heard of this object before, so I'm interested to see what it looks like and if we can capture a pretty good image of that. So we can check that out. Let's see. So I think we're gonna increase the exposure a little bit, play around with the settings just to see if we can get a little more detail in here. See what we can find. But yeah, I think, again, this is a quasar ionization echo. So I'm not entirely sure what the exact science of that is about, but I'm sure it's a pretty energetic type of thing. So it's apparently a magnitude 8, so we should hopefully get it. We just have to figure out which one it is. So yeah, looks like a fun thing. Let's see. Yeah, so I don't know if we know exactly which one we're looking at, so we probably have an image of it. We just don't know exactly which one to point out, but yeah, I've never heard of this object before. I don't think our telescope operators have either. We're just going to increase the exposure one last time and see if we can get a little more detail to see if we can figure out which one it is. But it's always interesting to explore these new objects when we don't know quite what they are, so this is quite fun. Yeah, so a lot of the times we stick to Messier objects or some of the brighter NGCs just because when we have guests around, we want to be able to look at something that's bright and understandable for them, but this is always fun to take a look at. So I'm still not sure if it's which one it is in there. You could always put it in the chat if you know, and let us know too, because I'm definitely interested to know what this is, but maybe the one in the center. But yeah. Let's see. So we have a request for Nebular Galaxy M83. So we just went to that one. M83, the Southern Pinwheel Galaxy. I believe that's the one that we just did. So I guess we can go ahead and move on to one of the next globular clusters for us. This is going to be M12. So we're kind of doing a string of globular clusters. This one's in Ophiuchus, the constellation. So I probably haven't looked at M12 before. Usually I stick to brighter globular clusters, so I'm definitely interested to look at what this one is. And this object was discovered by Messier on May 30th, 1764. And here's that nebula type thing. He described it as a nebula without stars, which is interesting because it's, now we know, made entirely out of stars. So I think that's kind of funny to make that comparison here. This is a nice globular cluster. So it's a little less loose, densely packed than the one that we just looked at, the the M92. I'll make sure to sign it on the board as well. So it looks like it's a little less densely packed, but we can definitely see that globular shape here. To me, it kind of looks like actually like a crawling bug in the sky, kind of like sideways, or like maybe kind of a spider's web. It has like those little tendrils coming off. I think that's pretty cool. This guy is about 15,700 light years away, so a pretty good distance, not as far as the last one. This one's a magnitude about 7.68, so definitely a little fainter than the last one. And it's about 3 degrees from M10, which we'll be looking at in the next object, but we can wait a little bit on that. With binoculars, you can actually see M10 and M12 in the same field of view, so that's kind of cool. You can knock out 2 at once if you're doing the Messier marathon with binoculars. Always a nice thing to save some time. And an interesting feature about globular clusters is that they tend to travel around in the galaxy in elliptical orbits. So that might be a remnant of how these globular clusters exist within our own galaxy, and that we think there are remnants of these older galaxies that have slowly been cannibalized by our own. So that's kind of an interesting one. There's a study that was done not too long ago on this globular cluster, and it's that interesting thing is that there's a low number of low mass stars, so lots of lows. So we think that this might have happened. So a lot of the stars in this cluster are really heavy, so probably heavier than our sun. So we think that these low mass stars were maybe stripped away when it was passing through the plane of the galaxy, and these lighter mass stars kind of just like got brushed away. Which is interesting to think about, and maybe that's why this globular cluster is a little less densely packed than some of the other ones, but that may not be true. So there's still so much active research going on with these types of things, so I think it's always interesting to see what astronomers are up to these days. So I'm just going to go ahead and sign off on M92 and M12 on the board. Before I forget, let me see if I can find them. Let's see. M92, here's this guy. And then M12 should be just up here. Here we go. Nice. So knocking a couple more off, which is super exciting. Yeah. So any last looks at this one? Again, if you have any questions or requests, put them in the chat. But I think we can go ahead and move on to the next one, which is going to be M10. So this is another glob in Ophiuchus, so we're just going to move just a tiny little bit in the sky, so it won't be too far. But I'm excited to see what shape this one takes. So again, it's another globular cluster, but maybe it'll have an interesting shape like the last one. I think globular clusters are some of the prettiest things to look at. Whenever I have guests up here, they're always a little skeptical about looking at globular clusters at first, but then they're like, wow, that was so pretty, and I never knew that these types of objects existed, which is pretty interesting. So this one was, again, discovered by Messier, just like M12. He discovered it on the same day, May 30th, 1764. So like many of the objects he found, so Messier, a little bit of background on him. I'm sure we talked about it earlier in the night, but for now, Charles Messier was a French astronomer, and he was looking for comets in the night sky. So one of the main things is that back in those times, looking for comets was kind of more sought after types of research, and everyone wanted to find a comet because it was so cool. And so Charles Messier was one of those people. So he basically he looked all across the sky trying to find these comets, and in the meantime, for finding these comets, he found just a wealth of other objects, such as these clusters, such as galaxies and nebulas, basically everything that we've been looking at so far tonight. We put them in the Messier catalog. So that's kind of the background on that. And of course, if you're looking for comets and instead you find a globular cluster, it probably isn't of much interest to you. So to be honest, a lot of these globular clusters and much of the objects themselves in them were to Charles Messier himself, which is kind of interesting because he was so sought after with comets, which is cool. And so this is another one where he described it with a nebula without stars, which is interesting because it is all stars again. So this one is a little smaller than the last one we looked at. It has a diameter of about 83 light years and is about 14,300 light years away. So a little bit closer than the last one that we looked at. So it's a still pretty good distance. This one is it's a pretty diffuse globular cluster in the night sky. So that's kind of an interesting thing. And again, if you're using binoculars, you can see this in the same field as M12. And this has a magnitude of about 6.4, which is a pretty good one. And so sometimes astronomers also categorize stars based off of what we call their metallicity. And so we can say that entire clusters are metal poor or metal rich, and that's basically just characteristics of the stars within that cluster of whether they have elements within them and around them that are heavier than hydrogen and helium. So astronomers basically call everything else besides hydrogen and helium some sort of metal. So it's not like the metal like that we think of like steel or something like that. It's something much different to astronomers, much of a looser term. So I might be throwing that term around, but that's just out there in case you hear me say that, that these stars are pretty metal poor. So there's a lot of hydrogen and helium in this cluster itself. And in general, globular clusters are some of the oldest stars within our galaxy and that we can observe. So that's kind of just a general trend. So with open clusters, those are usually really young stars. Globular clusters are really pretty old stars. Yeah. So let's see. We have a comment from Pandemic Watch, I believe from Twitch. It says, "Nice with stars." This guy's been vibing with us like the whole time. Yeah, so it's pretty fun. Let's see. So we have a couple more globular clusters in line. I'm just checking the time, making sure we're not running too far ahead. Making sure that I cover everything in my notes too, so I can give you all of the information about these. I guess we can go ahead and move to the next one. So the next one will be M107. I'll go ahead and check off M10 on the board while we're looking for that. It's always so fun to check off the objects. Let's see. Like it got caught. There we go. Let's see. M107. Okay. So here we go. So it looks like it's basically in our field of view. So this is another globular cluster in the same constellation, Ophiuchus still. So this one looks like it's probably our loosest packed one so far. So not as dense as the other ones we've been looking at, but still a really nice cluster. I think we can get towards the left side of the cluster. There's a little bit more densely packed stars, and we have some nice foreground stars as well for comparison, which is nice. So this was actually one of the last objects to be found on the Messier catalog. Not all of the objects traditionally were discovered by Messier alone. Some of the objects, such as M104 through M109, were discovered by another astronomer with the last name McCain. And were a time actually considered McCain objects until they were formally added to the Messier catalog in 1947. So that's a bit of history about the Messier catalog. It's not all of them are traditionally Messier objects, but we formally added them quite a lot later afterwards in 1947. So this is the last object to be found in the Messier catalog, the traditional one with Messier himself. So this is, overall, there's about 150 globular clusters in the Milky Way. So this is one of them, again, one of the more loosely packed ones, which is kind of interesting. McCain was a French astronomer and colleague to Messier. So that's kind of how they were correlated. And I don't know their exact relationship, if they were just they were colleagues, but I don't know like if they're collaborating on this project, looking for the same thing. If McCain was looking for comets, I'm not entirely sure, but this is, again, one of the last ones. This is a magnitude of about 8.9, so this is a pretty faint globular cluster, but well within reach of probably binoculars and definitely a telescope for sure. And so there are actually quite a few variable stars within this cluster as well. So astronomers like to look for these variable stars because for some of them, we can use them as standard candles in the universe, which is a pretty interesting topic. So when astronomers use the term standard candles, basically what it is a type of object that allows us to measure distances in the universe. So a couple of examples of the more traditional standard candles are like Cepheid variable stars or type 1A, I believe, supernova. And then we can also use redshift as a way to measure distances in the universe, but those are some of the main ones where when we're looking at these objects that are incredibly far away from us, millions to billions of light years, well, it's kind of hard to, first off, find that distance in the first place because it's hard to compare with anything around it. I mean, space is so vast. And so we use these types of objects called standard candles because basically what happens is that we know the exact luminosity of these types of objects. So with a type 1A supernova, we know that every time that type of supernova happens, it should have this exact luminosity. And so we can use that idea of luminosity to kind of reverse engineer and say how far away it is based off of how we perceive that luminosity and match it up with how bright we know that luminosity should be. So that's kind of how we use these types of objects in the universe. So Cepheid variable stars are really nice for looking at things that are more local to our galaxy and around the solar system, but we use these type of supernovas for things that are outside our galaxy just because they're bright enough for us to actually pick up and observe. So that's kind of an interesting thing with that guy. But yeah, still just let us know if you have any questions, comments, or any requests while we keep going through. Check at the time again. We're going to go ahead and head to M14, which is still one of our globular clusters. I'm going to go ahead and check off M107 real quick. Find it on here. All the way at the bottom. Sweet. So we head there. See what this glob looks like. There we go. Nice. So this is a pretty nice little small glob out there. This one's still in Ophiuchus, so we're still within the same constellation. There's just so much, so much here. So this is a nice little one. Let's see. So M14. This one's about 30,000 light years away. This one has about 150,000 stars in it, which is just a pretty good amount of stars. So usually globular clusters can have around like 100,000 to perhaps around 500,000 or 500,000 stars, sometimes more, sometimes less, but that's kind of the ranges that they occur in. And that's different than open clusters, which usually have only a couple thousand stars at a time. So these are just, again, much more densely packed. They have just so much more stars in them than these open clusters as a comparison. So this one's a magnitude 8.3, so still a little bit on the fainter side. Let's see. And this is a host to a nova, so not a supernova, but a nova, which are pretty rare events in globular clusters. So that was kind of an interesting thing to observe. That happened in 1938. And it's a nova is when a star's brightness increases by a factor of over 10,000, which is just an incredible amount. So they become some of the brightest things that we can ever observe anywhere. And so they're pretty awesome to see these types of events. And again, one happened in this cluster in 1938, which is interesting. So it looks like we have a request for interstellar bubble N44. So I haven't looked at this object before. I'm not really familiar with it, but let's see if we can do a quick search. It might take us a little while just to figure out where it is and if we can get it, if it's up enough for us. So stay tuned for that. Sounds pretty interesting, interstellar bubble. So interstellar is between galaxies in a general term. So yeah, I'm definitely interested to see what this is, but our telescope operators are just checking. Oh, okay, so we just got word we won't be able to take a look just because it is too low for us to see. It's in the Large Magellanic Cloud, so us up here in the northern hemisphere don't have access to the really pretty Large Magellanic Clouds. We'd all have to take a trip down to Chile to see that, but that's a great request. Keep them coming. Again, we'll just check to make sure that they are available. So let's hit our last glob, and then we can look at some other objects for fun while we wait. So this one will be M9. And let me just make sure I sign off on M14 real quick. Here we go. Sweet. So M14 is the last globular cluster in Ophiuchus that we're looking at, as far as I know, which is exciting. So we've been kind of on a run for globular clusters right here. But again, they're some of my favorite objects to look at, so I'm always always happy to see them. This one looks pretty small, but let's take a look on what some of the interesting things are. So this one was discovered by Charles Messier in 1764, so this is one of the original discoveries. Has a magnitude of about 7.0, so a fair amount, still kind of faint, and it is pretty small in the sky, it looks like. It's about 26,000 light years away from Earth, so one of the farther away globular clusters that we're looking at. And M9 is actually fairly close to the center of the Milky Way. And so the Milky Way is, the center of our galaxy, the Milky Way, is the dominating gravitational force for this object, which has caused the cluster to have a bit more of a warped shape. So that's an interesting observation that I've read about. And to me, it looks kind of more spherical. I don't know where that warped shape comes from. I don't know if it looks like maybe more elliptical or something like that. I might be interested to compare this to other ones. But that's kind of interesting. So it's about 5,500 light years away from the core of our galaxy, which is pretty close. So it does apparently have a slightly more warped shape just because it is so close to the core of our galaxy, which just, again, has our Sagittarius A star, the black hole at the center of our galaxy. So some of that gravitational influence might be affecting it a little bit. So that's kind of an interesting thing. And an interesting thing about this as well, that it apparently lies atop a dark cloud of gas designated as Barnard 64. So there's another catalog of objects called Barnard's objects, which usually deal with dark nebulas and things like that. So this apparently lies on the top of a dark cloud of gas. So that's kind of interesting that we found that out. I mean, dark clouds of gas, I mean, what it sounds like, it's probably kind of hard to find just because they're dark and astronomers like to look at things that are light. So it's always interesting to see those different types of catalogs. But yeah, this is a nice one. So that kind of wrapped up our short little run on globular clusters, mostly in the constellation Ophiuchus. We did hit one in Hercules. So, so far, within this little segment, we've hit 1, 2, 3, 4, 5, 6, 7. We've hit 7 more objects, which is pretty good, not too bad. It's definitely easy when they're basically all within one constellation, so we can just kind of go to one at a time, which is nice. But let's see, we have another request, which is pretty awesome. So we have NGC 6543. So we're going to check to see if it's visible, and I'll let you know. I don't know what type of object this is. Oh, it looks like a planetary nebula. Nice. Oh, the Cat's Eye Nebula. Okay, yeah, I'm familiar with this object. We're just going to check to make sure it's up right now for us. For most of the time, I'm not used to being up at 2:44 a.m., but some of the summer constellations are up, and it's kind of interesting because for most of us here in Flagstaff, we're used to looking at these summer constellations in the nice warm weather, and it's kind of weird to be seeing these constellations up, and it's almost freezing cold outside. Yeah, it's kind of interesting to have that like weird relation and being like, oh, it's really early in the morning and this is weird, but yeah. So this is a Cat's Eye Nebula. This is a planetary nebula. So a planetary nebula is the remnant of a dead star similar in mass to our sun. So it's a remnant of a star that is not massive enough to explode, but instead, basically what happens is that it runs out of fuel, becomes unstable, and kind of just puffs this gas out, kind of like you're blowing up a balloon, and it kind of just slowly expands outwards. So it's not a fiery explosion like these supernova, but instead they're a little more gentle. And the term planetary nebula comes from when early astronomers with the first types of telescopes, so people around William Herschel's time, were looking at these objects, and they looked vaguely spherical and not quite like a star. So they thought, well, add sphere, add not a star, 2 and 2 together, maybe a planet. But we now know that they're not planets, and instead just just a really nice nebula. So we have, it does have a nice, really beautiful azure hue. That's a great description. I love that. The color of this is just really awesome. And sometimes the color of some of these planetary nebula don't quite come through quite as nice as this. And this just has a really, really pretty color to it. So I'm currently studying geology, and so I'm totally a nerd and I'm into weird gemstones like that. And I think it looks like a cool, rare gemstone that you'd find, but that's just me. So this is a great object to look at. And it's called the Cat's Eye Nebula, I'm sure, because it has that kind of like diamond-ish shape to it, which might be reminiscent of the eye of a cat, which is kind of interesting. Definitely, again, a really pretty color. So let's go ahead and move to M51 just for fun. I believe that's a whirlpool galaxy, but could be mistaken about that. And it's just a great object to look at. So we'll just do it for fun since we have a little bit more time while we wait for the next set of objects to come in. So as tempting as it might be to do all the Messier objects at once, it is impossible because we have to wait for the Earth to turn. So that's kind of why we're asking for your input to see if there's anything that you'd like to look at, just because we need to fill some time while we wait for the Earth to turn so that we can get to some of these objects that are a little lower on the horizon. So we're heading back to the whirlpool, I believe, just to for funsies. Let's see. So it looks like we kind of got it in the center. We're starting to get it. So we have one major galaxy, kind of that top one, and then we have a smaller little galaxy down on the bottom. And so this is a really great example of what we call galactic cannibalism, because that bigger galaxy is slowly eating and incorporating that smaller galaxy, and we can see this in a really cool photograph. So how astronomers study galactic cannibalism is that, well, first off, they can use computer simulations to kind of run what will happen over time so that we don't have to wait millions of years to actually observe it. But we can also look at different galaxies in the night sky, such as this one and other ones that we can see, and look at the different stages that they're in terms of their interaction with each other. And so we can put all of these different ideas of interactions with these different galaxies into one big picture of, well, this is probably what galactic cannibalism looks like. So that's kind of an interesting thing that we do. So to me, astronomy is always a really creative science, just because we don't have access to a laboratory. I mean, planetary science in some ways does, because we are now sending probes to other planets and rovers to other planets where we can actually have these types of mobile laboratories on them. But for the rest of astronomy, we can't take a black hole or we can't take a star and put it in a lab. We have to observe these objects as they were probably millions to billions of light years ago. And one of our astronomers, Michael West, studies these cannibal galaxies. So I think I mentioned earlier that we do have a really great Meet an Astronomer episode on our YouTube channel where Dr. Michael West talks about this in really great detail, and he's just a fantastic resource, and he's great at explaining these types of things. So if you're interested in the topic of galactic cannibalism and just general research in galaxies, modern research in galaxies in general, I highly recommend checking it out. It'll be on the Lowell YouTube channel basically forever. So you can just search Meet an Astronomer and you'll be able to find it. It's definitely well worth a watch, one of my favorites for sure. So the whirlpool galaxy is a really great example of how we can see the spiral structure of galaxies as well. So it has one of the brighter spiral, a little more has a little more contrast, in my opinion, than some of the other galaxies, such as the Southern Pinwheel Galaxy. We can actually pick out these different things as well. So that's kind of a fun one to look at. So just a warning to you guys, we are going to take a break in about 10 minutes, just so we can change shifts again and make sure our telescope operators aren't getting too cold outside, and that we can switch objects so you don't have to listen to me talking for the next 5 hours, because I'm sure you'd get so tired of that. But we're gonna, let's see. Yeah, in there. So that's just a warning, but we still have 10 minutes to fill. So if you have any more objects, it looks like we did have a request for the Hubble Deep Field. So that's a pretty good question. So, or at least an object type thing. So I guess for reference, why don't we go to one of the galaxies back in the Virgo supercluster, just because there's lots of different galaxies in that area, and it can kind of give us a sense of what the Hubble Deep Field was like, at least kind of what the picture gave us. But the Hubble Deep Field is unique because we used it, which I'm not sure which one I want. Let's just do, look back on here. Let's do M89. Let's just look at that one. Or M66. I'm sure my telescope operators know a little bit better. But the Hubble Deep Field again was taken by the Hubble Space Telescope, which is definitely a little bit better of a telescope than the one that we're using, just because while it's above the Earth, it doesn't have to deal with atmosphere, and it's able to take really, really long exposures. So that's a pretty important topic as well. But with the Hubble Deep Field, it's kind of an interesting background to it. So usually when we think about looking at objects, we want to find areas in the sky where we think it's really interesting to look at. So we always want to look at interesting things. For example, on Mars, we send these spacecraft here to look at the most interesting things on the surface. And so when we think about the Hubble Deep Field, how it was taken is that we basically pointed the Hubble Space Telescope to an empty patch of sky. And why would we do that? Well, we don't know if there's anything there or not, but what we actually found is what we now call the Hubble Deep Field. And so we pointed the telescope to an empty patch of sky, and instead we found just a wealth of galaxies that we really never knew were actually there. They were kind of just hiding, and it kind of just opened our eyes to just how big space is and how many galaxies are out there, and really just opened our eyes so much to that idea. And so we aren't quite able to grab a picture of the Hubble Deep Field right now, just because we'd have to probably wait several hours to get even a little bit of those galaxies in. They're just pretty faint and far out there. So we'd have to have a really long exposure for that, and we're sticking to around 20 to 30-second exposures at the moment. But I figured I'd at least talk about it, but that's a good response. So we did have another one for M57, and I believe M57 is coming in the next round of objects. So if you just hold on tight for a little while longer, we should be getting to it soon. It is in the next one. So M57 is the Ring Nebula. So we will be getting that next, coming around 3:15 a.m. And so we moved to another one called M105, which has lots of galaxy neighbors, is what we call them. But it kind of just evokes that idea of the Hubble Deep Field of just looking at galaxies and then finding more galaxies and then more galaxies after that. And it's always just so fun to look at that. It looks like some light is getting into our camera, which is kind of like what that blue haze is like up there. So that's just a remnant of our telescope and camera. It's not actually something out in space, but we can start to see some of those galaxies in there, which is pretty cool. So again, just a warning, in about 5 minutes or so, we will be taking another break just to change shifts, but keep the requests or questions coming. I'm always happy to take them on. But for now, just while we're waiting, let's go to a cool binary star. So either Alberio or Epsilon Lyrae. And yeah, so right now we are at 75 out of 110 objects, which is so awesome. That's pretty cool. So we're making our way pretty well, which is awesome. So we're looking at a binary star right now. I believe we're on Alberio, which is probably one of my favorite in the night sky. So binary stars are two stars that orbit around each other in a center of mass over a period of thousands of years. So Alberio is a great example, not only for an example of a binary star, but also just a really nice close comparison of the different types of stars in the sky. So one of the stars, the bigger one, is going to be more orange, a little more red, and then the one just a little bit more down, kind of around 4 o'clock, it's a more blue star. It's a little bit smaller as well. This is interesting because the colors of stars can actually tell us quite a bit about the nature of these stars. So red stars are going to be, on average, older and colder than stars like our own, and then blue stars will be a lot younger and hotter. So if you think of like a candle flame, the blue part of the flame is much hotter than the red part of the flame, and so that's kind of where that idea comes from. Unlike where the little taps on the faucets say red is for hot and blue is for cold, where that doesn't make much sense to astronomers. So it's a little bit opposite to our daily lives, but in astronomy and most of science and chemistry and stuff like that, blue means hot, red means pretty cold. So that's kind of an interesting one. But there's so many binary stars in the sky. We think that perhaps 30 to 40 or maybe even 50% of the stars in the sky are binary pairs. It's pretty prevalent, and binary pairs often form when these stars are born. Sometimes they can kind of get a binary pair along the way, but that's kind of how they happen. I mentioned earlier that we're 75 out of 110. That's 2/3 of the way through of the 110 objects. So again, that's really great. That's really great headway, and I'm so happy that all of you guys have joined us for 2/3 of it so far. So only 1/3 ways to go, which is pretty exciting to think about. I'm super excited. When Lowell Observatory said that we were going to do this, I was like, sign me up, because this just sounds super awesome. We have a question. Do the telescope operators read this chat? Yes, they do. So they're the ones who actually look at the objects and look up the objects for me. So when you guys ask a request, and when we're checking to see if it's up, when we're checking to see if it's up, they're the ones who are the ones looking it up for me, and I'm just kind of commentating what they're saying back to you guys. They do read it, and just so they're on the same page as I am and everyone else. So it looks like we can get one more object in before we take a break. Let's go ahead and go to Epsilon Lyrae, which is another binary star, I believe. It looks like we have a hello operators from Mojo66, so they say hello. And the operators say hello back. So yeah, always nice. The operators are out in the cold right now, so always a hard part of the winter job in March is you brave the cold, but they don't mind it for too long, as long as we switch them out in a little while. So we're looking for the object, just trying to find the right search pattern in order to find it. Sometimes the plane wave software that we're using doesn't have all of the objects in colloquial terms that we usually use, or just different types of spelling or things like that. So we just might have to look up the catalog numbers and stuff like that. But we'll get it before we take the break, because it is a pretty bright object, so we should be able to get it. So we're going to go out and do it manually. So this is our sky finding software. This is just our plane wave software is what we're using, and so we're just manually doing it because the search function was just taking too long. So I'm going to go ahead and go there. There we go. It looks like we got it. So we're going to change the exposure a little bit, see if we can get all of these stars in here. Mojo66 says, greetings from Germany. Oh, that's awesome. We're getting some international people. That's super cool. So we say hello back. Welcome to the Lowell Observatory YouTube. Happy you could join us. Yeah, so it looks like we're getting them here. I think this is Epsilon Lyrae. I think this is the double. I could be incorrect. So we're trying to get them. The atmosphere is a little wavy tonight, so it might be hard to pick out both of the little stars, but you can kind of get a sense of them. You can see two distinct dots. They're just kind of dancing around in there. Always a good object to look at. There we go. Yeah, if we look in, you can kind of see those two separate pixels. Again, it's kind of hard to just get them sometimes, but that's a great one. So we're at about 2:59, so we are going to go ahead and take a break so that the next operators can change out, current operators can get warm, and then someone else will become or so and check off more objects as we make our way into the early morning and start getting towards the end goal and sunrise, which sounds crazy, but of the Messier marathon. So I think we're just going to take about a 5-minute break or so. So we're just going to take a pause, and then we'll see you back here in just a couple of minutes.
Hello, and welcome back to the Messier Marathon. My name is Ariel. I'm an educator here at Lowell, and I'll be your host for the next 40 minutes. I was also the previous operator, so hello. The people on the screen also have faces. I believe the person operating right now is Jose. Hello, Jose. Now, to start on off, I believe we are at 75 out of 110 objects. So we are officially 2/3 of the way through our Messier Marathon. It's currently 3:06 in the morning here in Flagstaff, Arizona, and I am wide awake. Yeah, so to start off, if we could run on over to M80, Messier 80. So the image that we just had on the screen was Epsilon Lyrae, a double-double, or like a two binary stars real close together. So Messier 80, or M80, is a globular star cluster in the constellation Scorpius. It's about 32,000 light years away. I like globular clusters. I think, like most of us have said, that globs are some of our favorite things to look at because they're pretty, man. Like, I don't know, they just never get old. So yeah, about 32,000 light years away and around 95 light years across. So it looks like this really, really dense area of sky in there. Now, globs are some of the oldest things in not only in our galaxy, but also in our universe. So these are usually really, really old stars, meaning, billions, over 10 billion years old. So this guy has several 100,000 stars, and you can see that he's one of the most dense globulars in our Milky Way. If we could actually zoom in a little bit more, we can see that it just looks like a white smudge because all of the stars are so densely packed together. Yeah, nice. One of my favorite comments for like globular star clusters way back when in like the pre-COVID times, I had a younger kid come up and we were viewing, I believe it was a globular like this, or like M15, the Pegasus cluster, another globular through the Clark. This little kid comes up, and I love asking kids, like, what do you see? What do you look? Yes, we are currently on M80. This is not M15. I was just thinking about this time we looked at another globular. But I was like, what do you think this object looks like? What do you think this globular looks like? And they go, it looks like unicorn snot. And to this day, I can't unhear that. So every time I look at a globular star cluster, like, yeah, that straight up looks like unicorn snot. That's like cool. Like, you're not gonna get that image out of your head. So this guy's M80, once again, globular in Scorpius. So now we're just going to jump around to a bunch of globulars in Scorpius. M4 is the next glob. Now, M4 is a very interesting object because it was the first globular star cluster where individual stars were actually resolved. So, again, way back when that Messier guy was first like cataloging all of these smudges in the sky that were not comets, looking at M4, this was the first smudge that they could actually see individual stars in. So we can see, the difference in how dense those stars are packed between M80 and M4. This guy's a little more spread out. So this globular is only about 7,000 light years away, or 7.2 thousand light years away, and it's 75 light years across. And the other globular was 32,000 light years away, 95 light years across. So we could see just how dense that guy looked versus this one. This globular, M4, is estimated to be about 12.2 billion years old. So I was saying, globulars have these really, really old stars in them. So this guy is, over 12 billion years old. Color of the stars here. Normally in space, younger, hotter stars are a white or blue color, and older, cooler stars are, a more yellow, more orange, more red colored. So that's normally we'll see more like red tinted stars in globular clusters like in M4 here. Also, totally forgot, I got to mark off these guys that we're looking at. So we saw M80 a second ago. Right behind me here, we have the Messier objects poster. We got M80. We're looking at M4 right now. So M4 and M80. Wow. Woohoo! Ah. So now we're going to jump on over to M57. I know we had a request to look at this guy a little earlier in the chat. So if you're still here, we're looking at him now. M57 is really neat because it is a planetary nebula, more commonly known as the Ring Nebula. So what that means, a lot of the Messier catalog has these, 110 objects, and a good chunk of them, I think maybe the brighter ones, the ones easier to find, or the prettier ones possibly get cool names. So since this one has a cool name, it's really pretty. Maybe top 10, one of my top 10 favorite objects to look at. But what we'll be seeing is the death of a sun-like star. So M57, or the Ring Nebula, is called a planetary nebula. And what a planetary nebula is it's the death of a low to average massed star. So are we able to see the white dwarf at all, too? Maybe if we lowered the gain a little bit. I don't know. Looks a little bright. But we're seeing, different colors. Nice! And we can see that white dwarf in the center there. So what exactly is going on? What is M57? So, a star is born from a nebula. I believe we may have run into a few nebulae earlier on in the stream. There's a difference between star-forming nebulae and planetary nebulae. So star forms, and for billions of years, it burns its hydrogen fuel. And once it runs out of hydrogen fuel, it'll start trying to burn elements that it's already created. All stars are these little element factories. And anytime the star tries to fuse anything that's not hydrogen, it kind of I think of it as the star kind of has an allergic reaction whenever it runs out of its hydrogen fuel. So it starts kind of not feeling too good, starts getting a little bloated, maybe, possibly. I don't know if that's an awesome way to say that, but that's how I see it. And once it runs out of all of its fuel, depending on how massive that star is, it will explode, it will die. So this is, again, the death of a sun-massed star or an average massed star. So what happened here is right in the center, we see this sort of a blue dot. That blue dot is a white dwarf, and that is the dying core of the star. So that dying core is expelling out all of the gases that star has created throughout its lifetime. So we see, these different colors in the Ring Nebula here, and those different colors are different, elements. So, since it's the death of a lighter star, we get lighter elements like helium, oxygen, and nitrogen. Now, what we could do is we could jump over to Antares real quick, as we're on the topic of star formation. So Antares is a red supergiant star, or a red giant star. So it is a star nearing the end of its life. We may be able to tell through this image that the star is the star is pretty red, and when you're looking at it in the night sky, we can see it with our naked eye here in Flagstaff, that is in fact a red star right there. So, I mentioned earlier, a red star means a star that's cooling down or nearing the end of its life. So, this star is about to as in a couple 100,000 years or so, will become a planetary nebula or a supernova. So that'll be fun. Now, I love Antares because of the story behind its name. So Antares, an older star, nearing the end of its life. When the like older astronomers, I suppose, were initially like mapping out, like ancient astronomers were mapping out, planets and stars that they were seeing in the sky. Antares sort of passes along the ecliptic, and the ecliptic is also the line where planets sort of pass along. So, this red star in the sky would pass along where Mars could be. So, older astronomers were like, okay, this one's Mars, but this one also kind of looks like Mars. And then, they figured out okay, this one is Mars. It's not twinkling, and this one is not Mars. We can tell, stars in our night sky twinkle, planets don't. So this one's not Mars. This one is Mars. So this star is literally named not Mars. Antares translates to not Mars. And I think that is just one of the funniest things. I don't know. Antares is about 600 light years away. It's visible in the southern sky, more towards the southern sky or around the ecliptic when we're viewing from the northern hemisphere like we are at the Lowell Observatory right now. But, this star, we can tell it's red. It's nearing the end of its life, and soon it'll become something like the Ring Nebula. Now, what we can do is we can go ahead and jump on over to M56. So, while we're doing that, I'm gonna mark off M57. Where is it at? This guy. Dang, I feel famous. So, we're getting some nice little guy. I like him. So we're up in our exposure to around 15 seconds. M56 is a globular star cluster in Lyra the Harp. It's about 33,000 light years away and about 84 light years across. Now, if you've been watching for a while, or if you've been on the stream for a couple hours, we may have talked about it before, but a light year is the distance that light travels in a vacuum through a year, or through a vacuum in a year. So a single light year is about 6 trillion miles. Now, a trillion is like a big number. Like if we were to count to 1 million, like one single million, like 1,000, 2,000, it would take you about 11 days. If you were to count to 1 billion, it would take you 32 years. And if you were to count to 1 trillion, 1/6 of a light year, it would take you 32,000 years. So 6 trillion miles is a big number, and M56, which is 33,000 light years away, is a very, very long distance. This glob is one of the older globs. I guess it's an older glob that we've looked at in the past 10 minutes, at about 13.7 billion years old, so nearly 14 billion years old. Now, most of the stars anywhere near the galactic center are like red giant stars and other redder, cooler, older stars. So it makes sense that this glob is nearby to the galactic center. This globular is about 32 light years away from the center of our Milky Way galaxy. So, we can tell that this, I said this glob was over 13.5 billion years old, which means these stars are probably pretty old. I see we have there's a request from before, which is the binary companion of the black hole Cygnus X1. We're going to go ahead and see. Ooh, fancy. Okay. So HDE 226868. So a binary companion of a black hole. I want to see exactly what this will look like. I think this is a request that we either missed earlier or we weren't able to grab because it wasn't visible in the sky yet. So I love when we take exposures as we're moving the camera. You may have noticed like we get these streaks in the images sometimes. Or anything, it's just the camera is taking a picture while we're moving it. So really bright stars, as they pass through the screen, will get these sort of streaks going through it. So the binary companion of the black hole is in there. Um, not, it is one of these stars. So, so since the companion is in there, that means black image as well, which a lot of which a couple viewers were requesting to see earlier. So Jack Morrow, I believe. So there's a black hole in this image. However, you know, we've got sorry, John Walker. You know, we don't quite have access to the Event Horizon Telescope right now, so we can't really get, you know, an awesome image like the image that we got of the supermassive black hole in M87. But I promise you, there is a black hole in this view right now. So let us see. We just grabbed M56 before we grabbed this binary companion. Let's run on over to M29. So we're going to switch up objects a little bit. We just looked at a bunch of globs. We looked at the ring nebula. Now we're going to jump on over to an open cluster. So there are two like main types of star clusters in the sky. There are open star clusters and globular star clusters. Open clusters, like M29, which we're zooming over to right now. Nice. So pretty like a spread out area compared to those globulars we were looking at earlier, right? So that globular looks like, you know, that unicorn snot or salt spilt on a black piece of paper or like dewdrops in a spider web or a firework. But open star clusters, to me, they would just look like diamonds thrown up into the sky, if that looks any different than like all those other things that I said earlier. Open clusters, they look a lot more spread out. And that has to do with, you know, their name. They're called open clusters because they're formed from a nebula, so a star forming region. And these stars didn't form a very strong gravitational pull to each other. So, you know, they're sort of drifting apart from each other because of this weak gravitational pull. So it's like they're opening up, versus something like a globular star cluster, like all the few globs that we were looking at earlier. These globs, all of these stars formed pretty close together. They formed a pretty strong gravitational pull to each other. So scientists got together and they named them the very sciencey science term glob. So we have all of these, you know, globular star clusters as Messier objects. I believe we mentioned like the amount of globs in our Milky Way earlier, but like a couple hundred globular star clusters in our Milky Way. And I believe there are more open star clusters than there are globs. But anyways, M29, the guy that's on our screen right now, is around 3,700 light years away. And this one is also only 10 to 13 million years old. So while we were looking at the globs earlier, you know, they were 12 billion, 13, 14 billion years old. And this guy's only, you know, 12 million. So not only are open star clusters less densely packed, so only, you know, couple tens of thousands of stars rather than hundreds of thousands and globs. So open clusters have less stars, they're drifting apart from each other, and they're usually younger stars as well. So, you know, those globs have those really, really old stars that have just been stuck together for forever. And open clusters, they form and then they slowly drift apart from each other quickly after they form. So, if you guys have any requests or anything, feel free to put it in our chats and we will try to run on over to them. But before that, I'm gonna cross off the goods that we just looked at. So M56, the globular cluster. Don't fall. And then M29, open cluster. Oh, cool. No. My biggest fear right now is smearing someone's signature on the Messier board. Oh my God, I just quit. Let's see. Is there anything neat up that I want to take a little peek-see at? Is M82 still up? Or, ooh, sombrero would be pretty cool after. Let's see if M82. Yes, yes, yes. Love that guy. So M82 is, I believe, the cigar galaxy. I mix up M81 and M82 pretty often, but I just love how this guy looks. The other day, we were viewing M82 through, to run up the exposure a little bit, we were viewing it through our 32-inch star structure here at the Godo, and like I've never seen it so sharp before. Like I'm pretty sure I've viewed it through the 32-inch before, but it was just like mind-blowing. Like the other day for some reason. I don't know what was going on, but I've developed like a newfound fascination with this object. So yeah, if we can like zoom in and then we can kind of see what this galaxy looks like. So we see those sort of those gaseous regions where like nebulae are hanging out, these star forming regions. We can see those fuzzy areas where stars are, and we can see those really bright areas where a lot of stars live and a lot of star formation is occurring. Now, Jonathan Walker says, now we, all your viewers who stayed up this late, thank you guys also for staying up this late. You guys are radical. Now we can say that we are the very few who had a live look at a black hole tonight. Even though it's invisible, no accretion disk is bright enough to see. Yeah, absolutely. And, technically you're looking at a black hole by looking at M82 as well, by looking at most normal galaxies where, we have black holes keeping together all of these stars. I see that we had a question earlier. Is the camera running at full resolution 4096 by 2060? I believe the camera is running at 6224 by 4168, but the stream is limited to 720p. Now, before we head out, I do want to look at the Sombrero Galaxy again, because I think it looks really cool. And it's so neat because, all of these globular star clusters look so different, even though they're the same object. These open star clusters look so different, even though they're the same. And then looking between like M82 here and then, the Cigar Galaxy and then the Sombrero Galaxy, they're both galaxies, but they're so different. They just look so different. And I think that's the neatest thing. Space is so diverse. I love that. Yay! So, how, in the Cigar Galaxy, we saw more like these dark clouds kind of going across that galactic center, showing that star formation. Here in the Sombrero Galaxy, we can still kind of, it looks like we've got shooting stars in the frame that's just taking an image as the camera's moving. In the Sombrero Galaxy, we see the galactic center, and then we see sort of like that band around it, making it almost look like a sombrero or like a hat. And that band is, I believe, is where some star formation is occurring. I see a comment from Jody saying, if we were doing X-ray imaging from above our atmosphere, we'd see a hot spot around Cygnus X1. Probably, yes. Yeah, especially, X-ray binaries are super energetic. So, all right. With that, I think we are actually not going to take a break. We've got 10 minutes, or about 15 minutes until we take a break. So what we could do is, we could jump on over to the Needle Galaxy, or NGC 4565. So I think it's really neat to get these different like shapes of galaxy. So The Needle Galaxy is in the constellation Coma Berenices. Coma Berenices. I've always had trouble saying whatever that constellation's called. I think it kind of looks a little like the Sombrero Galaxy. We see like this bright galactic center, and then we dark streak sort of going through the view. And that dark streak is where that star formation is happening. All of this, all of this gas that's forming this galaxy is sort of hanging out. So I think we're up in the exposure, and then we might try zooming in a hot minute. While we are waiting for this exposure, real quick, if you guys don't know, Lowell Observatory recently launched a TikTok account. You'll be seeing a lot of me on there right now, but that looks awesome. Wow. On our TikTok account. Thank you for taking a Snapchat. But we're adding in a bunch of our other educators. So if you happen to be super bored and, up at 4 a.m. like I am right now, feel free to scroll through Lowell's TikTok, where we have even more space stuff. And it's only, 1 minute videos, little fun facts. This is the Needle Galaxy. So it kind of looks like a even bigger sombrero than M1 or the Sombrero Galaxy that we were looking at earlier. So this guy is about 40 million light years away from Earth, again in the constellation Coma Berenices. Nice little dude. Man, we got a really cool image of this through the Lowell Discovery Telescope. I think it might have been like 2 years ago. I wouldn't be able to find it, but man, maybe it's somewhere on our Instagram. We'll find out. This guy is estimated to be about 13 billion years old, so the entire galaxy, which kind of puts into perspective like the age of globular star clusters, or like the ages of these galaxies. Like globs were like the first things formed in these old galaxies. Cool. So the really cool image of the Needle Galaxy that I was just thinking about is in the LMI gallery, which is available to the public, I believe. Yeah, I think large megalithic imager. So we've got like a lot of really, really cool images taken with the LDT, the Lowell Discovery Telescope. That is a 4.2 meter reflecting telescope. So a very large research telescope that is available to Lowell astronomers for viewing through. What was that? Let's see. What's in the sky right now? Leo is set, right? Or Leo's just about set. The superior zodiac. I think Leo's butt is still up. So, was it? We could jump on over to the Sunflower Galaxy. This is, I think this is M63. This is also located in the constellation Coma Berenices. M63 is also known as the Sunflower Galaxy, is also known as NGC 5055. So hopefully we'll be able to get some of the spiral arms in the Sunflower Galaxy. So we're looking at edge-on galaxies here. So instead of looking at it, like the center is here and all the arms here, we're looking at it sort of turned. So we're seeing the center kind of blown up here, and then the edge sort of going through the field of view. Looking at M63, we should be looking like face on or plate on. So we'd be able to see like the core of the fried egg of a galaxy here. I guess the yolk of the fried egg of a galaxy here. Then the whites of the egg of a galaxy going around it. And those will be the arms of the spiral galaxy. Nice little guy. Sorry, y'all just got a real nice view on my forehead. Cool, man. Yeah, could we zoom in a little more? Maybe, or is there a possible way to get more definition in the arms? Yeah. Oh, yeah. Yeah, so we're seeing that core of that galaxy and then sort of spreading or, going around. Nice. So as we're working on longer exposures, we're able to see more of these spiral arms there. So we're seeing the core of the galaxy, and then, as that galaxy, rotates, all of these star-forming regions end up forming these arms going around, or they look like these spiral arms, and we're able to see some structure in those spiral arms as the exposure gets longer. So we're working on a 30-second exposure in here. So, did we do it? Nice. Oh, we're doing it even more. Heck yeah, man. So this M63, or the Sunflower Galaxy, has around 400 billion stars, meaning it's about the same size as our own Milky Way. We have about 400 billion as well, or estimated. So, let's see. Yeah. So if we don't have any more requests or anything, I think we are going to go ahead and give our telescope operator a break. We're cold. And we will be switching hosts in a hot minute. So be sure not to go anywhere, or do if you're tired, or stick around and look at more space stuff. I would stick around and look at more space stuff. And we will see you in a few.
All right. Hi, everyone. Hi again. So I'm Jose, and we are continuing with our all-night Messier marathon here at the Lowell Observatory. And for those of you guys that are just joining us, we've been up here since 6 p.m. and it is now 3:45 a.m. And we've got about 2 hours and 15 more minutes, probably a little bit longer than that, to go for this marathon. And what we're trying to do is we're trying to get all 110 of the objects in the Messier catalog. So Messier was a French astronomer back in the 1800s who was trying to discover comets, and he and a few people discovered a whole bunch of other things that were definitely not comets. So we've got a little bit of time to kill while we're waiting for some of our new Messier objects to rise. So we can also take some requests if anybody has anything that they want to look at, or if we want to look at something again, we can do that. Currently, the camera is pointed at a NGC 4889, which is part of the Coma cluster, which is a galaxy cluster in Coma Berenices. So this cluster, it's not part of the Virgo cluster. It's a separate galaxy cluster that's relatively nearby, actually, to the Virgo cluster. And what we're seeing here is there's a few of these fuzzy blobs that are kind of just right in the middle of the picture. There's also quite a few foreground stars as well. And those fuzzy blobs are distant galaxies. And this is an important cluster because this one was one of the ones that was observed by Fritz Zwicky to have dark matter back in, I think it was the 1950s. Fritz Zwicky was a prolific astronomer. I don't think that's a word. I can't think of the word. He was one of the astronomers back in the 1950s, and he coined the term dark matter. Prolific, that's the word. Thank you very much. And he actually coined the term dark matter after observing the galaxy clusters like the Coma cluster and several others. He was using different methods to calculate their masses, and he was finding that there was actually a discrepancy with the different methods that he calculated these masses. They were not coming out the same. So he was using the virial theorem, and he was also measuring their kinetic energies, and there was a big difference. So he theorized that there might be some unseen matter that was exerting a gravitational force on these galaxies that they couldn't see. But of course, Fritz Zwicky, he wasn't well liked by his colleagues, and they kind of brushed him off. And then it would actually be later on, probably more than a decade later, Vera Rubin, she found more evidence for dark matter actually here at Lowell Observatory by measuring the kinetic energies of stars and some spiral galaxies. And she was finding that the kinetic energies of the stars were not kinetic energies, the radial velocities, right? As they orbited around, she was finding that they weren't matching what predictions were telling them they should be at the time. And this led to an idea that there might actually be a more heavy matter that just was unseen. So that's kind of leads to our theorizing of dark matter. And so that it starts with the Coma cluster. So I was kind of excited to see that. Jody R has requested a star in Sagittarius. He wants another black hole tonight. So we're going to go ahead and we're looking at Sagittarius A star, which is actually the heart of our galaxy. I think that's what we have requested is for the supermassive black hole at the center of our galaxy, which is what I'm under the impression we're going to be looking at. So they're typing in the coordinates in right ascension and declination. That's pretty much the only way we can get it. Now, of course, we can't actually photograph a black hole. We don't have a telescope big enough. In fact, it took a telescope the size of the Earth to image the only black hole we've ever imaged. So I imagine that it should be close to being up. I know a few of the objects that we're going to look at here in a minute or so are in Sagittarius. We'll go ahead, and if we can get that in there for Jonathan. Then I have another couple Messier objects that we're going to try and hit. So they're doing some stuff on the, you can see on the image, the screen there, they're doing some stuff with the telescope trying to get it to a point. So as long as they type everything in accurately, it should be fine. And you can see the right ascension and declination is where they're typing. Those are space coordinates. So on Earth, when we try to measure our coordinates, we use latitude and longitude. Well, right ascension and declination are similar to latitude and longitude. Right ascension determines how far east or west something is. That's minutes and seconds. And then declination determines how far north or south something is. And that's measured in degrees, arc minutes, and arc seconds. And there are about 15 degrees in 1 hour. So we do have a exposure here. It looks like we're in video mode. So these are all the stars that are in these are all the stars that are in the field of view in Sagittarius. And Sagittarius A star is somewhere in this. I wouldn't be able to tell you exactly where it is. And again, it's invisible to us. However, generally speaking, most of our objects show up sort of in the upper center of the image. So you can kind of just eyeball it from there, I suppose. But yeah, that is the location of the center of our galaxy and the supermassive black hole that is located there, which is about, and correct me if I'm wrong, chat, if it's about 4 million solar masses, or 4 million times the mass of our sun. And that is the center of mass of our galaxy. Let's go ahead and move to my favorite object in the entire night sky, M27, Messier 27. We'll get started on looking at some of these Messier objects. So I say this is my favorite object, and there's quite a debate among my colleagues and I about what the best planetary nebula is. And most people will say, oh, it's the Ring Nebula. But I personally prefer M27, or the Dumbbell Nebula, over the Ring Nebula. I think it's bigger. It's a lot easier to take a picture of. Someone mentions that they love the owl, and the Owl Nebula is probably, it's pretty cute, I suppose. It's like my 5th favorite planetary nebula. But there's the Dumbbell Nebula, and as you can see, it looks like a dumbbell, like the weights that you lift. And it's got some unique red and green layering in the colors there. And at the very center, there should be a white dwarf. So a planetary nebula that is basically a gas cloud that is surrounding the core of a dying sun. So as stars get older, they go through their various stages in life. And after going through the red giant phase, a star will go through a phase where it is constantly like pulsating in size. And every time that it increases in size, it's going to push out a layer of gas. I like to describe these planetary nebulae, they're a lot like Shrek. They have layers. So you can see the outer layer is going to be lighter elements and some dust. There's always an envelope of dust around these. So that red, that's going to be some hydrogen. There's going to be a little bit of nitrogen in there, I believe. But then the green, that bright green, that's a lot of ionized oxygen. I believe it's singly ionized oxygen, as well as a few other elements. And then, of course, the white dwarf is this small, dense object that is about the size of the Earth. And I'm trying to remember exactly what the size of it is. Yeah, it's got about a half of it's actually about, this one's about half the size of the sun in diameter, but it's also got about half of the mass of the sun. So this object is actually located in the constellation Vulpecula, not Cygnus. It's near Cygnus, and when I try to find this with a manual telescope, I use Cygnus to find it. But yeah, it's Vulpecula, which is a fox constellation. So I'm going to go ahead and I'm going to mark off M27 on our little board. Once I find it, there it is. So, there we go. And yeah, so that's my favorite planetary nebula, and that's actually my favorite thing to look at in the entire. Oh, yes, someone wants to see the entire board. So let's go ahead and I'm just going to pick this up so you guys can see the board all up close. But everybody has initialed all the objects that we've already photographed. So you can see all of our initials. And by 6 o'clock this morning, we should hopefully have 110 initials on there. Hopefully. So. And then, all right. Yeah, so we can go on to the next object, which is going to be Messier 71. So M71. While I figure out where we're at. So M71 is a globular cluster. So we're going to be looking at quite a few globular clusters still. Now, if you guys were watching the chat when Hannah and Jacob were on, Hannah had some very strong opinions about elliptical galaxies, and I'm going to say in the nicest way possible, I have some strong opinions about globular clusters. They are absolutely gorgeous to look at, but I feel like they all look the same. So we're gonna power through these globular clusters, and I'll teach you about each of them a little bit individually. So this one's located in Sagitta, which is the arrow, so not Sagittarius, spelled similarly. This is M71, and it's about 13,000 light years away. Yes, 13,000 light years away, which is relatively close to us for globular clusters. Anyway, most globular clusters on average range between about 25 and 35,000 light years away. And just a little refresher, I know a lot of y'all have been watching this stream, and we have been looking at lots of clusters tonight. And just a little refresher, these globular clusters, they kind of hang out near the core of the galaxy, sort of above and below the disk, not necessarily in the spiral arms. So like we have our galaxy and globular clusters up here, and then down here in this area, which we call the halo. And there's a lot of debate as to where globular clusters came from. They're they're still a mystery. People aren't quite too sure whether these formed inside our galaxy or whether they were part of other galaxies that were then cannibalized by the Milky Way. And yes, it is called cannibalism when a big galaxy eats a little galaxy. So this particular one, this was discovered by, I'm not even going to say his name correctly, Philippe Loy de Chizot in 1745. So this one was probably one of Messier's colleagues, and then Messier would catalog this much later. And this one's an interesting globular cluster, actually, because you can tell even in the picture, it's rather loosely packed compared to other globular clusters. And even all the way up until about 2008, no one was really sure whether this was a globular cluster or just a densely packed open cluster. And some of the traits that it shares with open clusters was that it had a relatively high metallicity. And so stars that have lots of metals, and in astronomy language, metals are anything heavier than helium. I know chemists hate that, but this is going to have lots of metals in it, which is reminiscent of these stars are actually a lot younger. And these are some pretty young stars. They're actually not older than 10 billion years old. And on average, globular clusters are going to be much older than that, probably 11 to 13 billion years, depending on the cluster. So this is really young. And the reason that we classified this as a globular cluster in 2008, they actually
found that it does have it has a short horizontal branch on the HR. That's something that all globular clusters share in common. So that's going to have a lot to do with where these stars are on their evolutionary, on their track on their evolution, on how much they've grown. And one other interesting fact about this globular cluster is it actually has a bunch of millisecond pulsars. So that means that the rotation for these pulsars are they're very short. They're one rotation every millisecond or so. And they've had to photograph this in X-ray to be able to see those. So we have seen quite a few X-ray sources, probably about 5 of them in this particular cluster. So this one has that going for it. Let's go ahead and move over to M19 or Messier 19. And Ariel definitely lied to us when she said this was the last cluster in Ophiuchus we were going to look at, because I've got a couple that we're about to look at here. So shame on her. So we're looking in the constellation Ophiuchus at M19 now. Another gorgeous globular cluster, right? Yeah, this one's much denser compared to the other one. You can see that right away. We don't even need a good picture to tell. And so you can see some star trails, and that's because the telescope was moving while they were taking a picture. So here in a few seconds, we'll get a better picture. And this one's about 30 kilolight years, or 30,000 light years away. So that's on track with the distance that I would estimate for any random globular cluster. Oh, thank you. Someone just reminded me to sign off on M71, and I'm going to go ahead and do that. Go. Yeah, you guys got to remind me because I will already forget. And M19, see? There we go. Yeah. All right, so this one was discovered by Charles Messier. So this was one of the objects that he himself actually discovered. This is about 1 million solar masses. So that gives us a good estimate about how many stars there actually are. So many of these stars, there's probably solar mass size on average, maybe a little bit smaller. So probably about 1 million stars in that as well. And the radius of this is about 70 light years. So that means this whole globular cluster from one side to the other is about 140 light years away across. Now, with however, several 100,000 up to 1 million stars in that small of an area, and I do say 140 light years across is a small area when we're talking about this, because if you think about it, here on Earth, the nearest star to our solar system, not including our sun, is about 4 light years away. There's literally nothing between us and the nearest star. It's just empty space. And as it turns out, on average, there's probably about for every 300 light years of area, there's about 1 star in our galaxy, except for these globular clusters. There's about 200 globular clusters in the galaxy, and each of them containing thousands of stars, right? So you're now looking at stars that are so close they basically could be, they're not, but they could be close enough to be touching each other. And there are going to be a lot of stars that are interacting with each other. Those are going to be some more X-ray sources that we find in these globular clusters as well, when these stars are getting really close up in each other's space. So these stars in these globular clusters are doing the exact opposite of what we should be doing in the times of the pandemic, and that is not social distancing. So we want to be like the sun and Proxima Centauri and keeping very far apart for at least a little while longer. Don't be like a globular cluster. And so an interesting thing about this particular cluster I found
was that this is probably the most elliptical globular cluster that we have found. It's very oblate, or it's oval shaped, right? It's kind of flat. And you can kind of tell on the left-hand side of the cluster there, it is a little bit squashed looking. And yeah. So these things generally tend to be spherical in shape, but this one, it is relatively close to the center of the galaxy. It's close to SGR A star, which we just looked at a while back. And because of the gravitational forces undergoing it, is likely that this has been flattened out. I've also read that it's possible that this one hasn't been flattened all that much, and that there's actually some interstellar medium that is causing extinction in that general area, because when people have observed this cluster with infrared, they find that there is almost no flattening at all whatsoever. So I did get some conflicting information when I was doing my researches. So yeah. And this one actually has no observed X-ray sources at all. So this was M19. I see that someone did request for something, so we have some time to kill. We might as well head over to NGC 4438. This is some interacting galaxies, and if I am wondering if it was some that I was interested in looking at earlier as well. But we'll find out when we get a picture of it to see if it's the same ones. It's not the one that I wanted to look at, so never mind. But we're going to look at some galaxies real quick. TechieMat 501 asked how many globular clusters there are, and there's approximately somewhere between 150 and 200 globular clusters in the Milky Way galaxy. At least that's how many we've discovered, right? And all galaxies, or all really large galaxies like the Milky Way, they have globular clusters. We've found them in other galaxies as well, so I couldn't tell you how many there in those ones though. So we got those two galaxies. You can see, if you can hover your hand over each of those two, there's one on the top and then one on the bottom of those two galaxies. These are some interacting galaxies. I actually haven't heard of these ones, so I'm pretty excited to see some. Now, interacting galaxies means that they are gravitationally attracted to each other. They are influencing each other in some way. Stars might be moving around in ways that you wouldn't see with like the Milky Way. Well, the Milky Way is interacting with galaxies. That was a bad example. But in some of these grand design spirals that are not interacting, you can see the difference. So these will most likely affect each other, continue to affect each other for quite some time, until maybe they even merge together. Who knows? But yeah, so NGC 4438 and NGC 4435. And we are taking one more longer exposure for about 25 seconds, it looks like. So we will wait until that image pops up. Excuse me. I'm going to take a real quick sip. So, so someone asked if we could do some more stacking. And we're, just because we are trying to take quick images, we're not doing any stacking. So we're just going to be integrating for a period of time, one exposure photograph. Yeah, and it looks like we're getting some noise up in the top. That's actually coming from the camera. So we're not going to we're not going to integrate for any longer than the 25 seconds, because it's gonna, the noise is actually going to become more, what was the word? Prolific. Yeah, let's go ahead and head over to M62, which is another globular, also in Ophiuchus. So while they head that over that way, so this one has been given the nickname as the flickering globular cluster. So I really hope that I see some of that flickering. Otherwise, I will be sorely disappointed. And this one will be it's about 22,000 light years away. So on the near side of the black hole to us.
And this one is, again, about 1 million solar masses right there. And this is actually one of the 10 most massive globular clusters in the Milky Way. And you can tell just like how densely packed it is, that it's gonna have a lot of stars in it right there. So was this one? This one, yeah, was actually a candidate for having an intermediate mass black hole in it. So one of the theories on where globular clusters came from was that these were visitors from other galaxies. They might have been dwarf galaxies that got too close to the Milky Way. The Milky Way realized it. It took most of the stars, but it left these kind of chunks of these densely packed stars that couldn't be ripped apart by the Milky Way's gravitational forces, and now they're just kind of hanging around in the halo because they couldn't do much else. And if they were part of other galaxies, then there is a possibility of having black holes in them. And we haven't detected supermassive black holes, but we have detected several of these globular clusters. Many of them are candidates for having black holes in them. And so we have detected X-ray sources from this as well. So for Jonathan, who's been watching us, he's been requesting black holes. Well, you're looking at another black hole, probably somewhere in there. There's so many stars in there, they're probably in the way. That being said, but there is one in there somewhere, maybe. All right. This globular cluster is about 100 light years across, and it was discovered by Charles Messier, another one that he discovered himself. And he discovered it in 1771. So another palindrome year right there. My gosh, I need to sign the poster. M62, 69. There we go. I found M62. And oh, we got a little bit of a change. So we're not going to look at a globular cluster next. We're going to look at an open cluster instead. So let's go ahead and move the camera over to M39, which is an open cluster in Cygnus the Swan. And then, of course, while we're taking pictures, feel free anytime to send in any requests that you have, any questions. I'm going to be here answering those questions as well. So here's this open cluster. And this was discovered by Guillaume de Gentil in 1749. And then it was cataloged by Messier in 1764. This is an open cluster. It's pretty densely packed. It almost looks like a globular cluster. M39. This is about 1,000 light years away, and this one is actually really good candidate for wide field lenses as well. So binoculars and yeah, that doesn't look right, but now yeah, this one does look like a globular cluster, but it does say open cluster. We're just gonna go with it. I'm gonna believe the software at this point. This one should be a pretty wide field view object. And when William Herschel actually observed it, he didn't think that it was here we go. Now it's moving. As it turns out, we were probably just looking at M62 again and then thinking that was it. And once we get this image back, it looks like we're going to have to wait for this one. We might be looking behind the building still, which is totally fine. We can revisit this one here in a few minutes or so. We got a whole bunch of other globular clusters we can look at, so we might as well go over to M23 we'll head over to M23 and kick off an. Sorry, this is an open cluster, not a globular cluster. I got ahead of myself. We can see the stars moving in as the camera is moving while the exposure is taking. So, there it is. This is what an open cluster should look like. It's open, and they're not densely packed. And this one is located in Sagittarius, so this is, relative, like it's in the direction of the center of our galaxy, but it's actually pretty close to us, quote unquote close, because it is about 2,000 light years away, and 2,000 is actually close for open clusters. It's one of the fewer closest ones to us, and this is about 8 light years in diameter, and it takes up this wide field of view because it's so close to us as well. And these are some pretty young stars. They're going to be about 330 million years. I say all these big numbers when they sound like they should be small. But yeah, stars take millions of years to form, and a million years is a small number when we're talking about the age of a star. So these ones are going to be really young, and they, as it turns out, they are in front of an extensive gas and dust network. We're not going to get any of that in our camera. We're going to need infrared imaging to be able to see any of that. But there would be some extinction happening from the stuff behind that. But there is some gas and dust that is nearby to these. But as it turns out, it's not really just like with the Pleiades. It's not really related to the gas and dust. They just happen to be passing through each other, passing by each other at the same time. So, another interesting fact about this one is because this is within 5 degrees of the ecliptic. Now, the ecliptic is the line that the sun travels across in the sky, and so it follows through all of our zodiac constellations. And because it is within 5 degrees of the ecliptic, this object can be occulted by the moon, or the moon can pass in front of it. And that's always very interesting. When you watch occultations, you can learn a lot about the planet that's occulting, or the moon, I guess, or the object as it passes in front of it. So occultations are very interesting events that can happen in astronomy. And so this one's one of them that might be very interesting. And I got excited because there's a bright star down in the lower corner. I thought it was a planetary nebula. It's not. It's just a star. I got too excited for it. Let me go ahead and check off M23 before I completely forget. And then, yeah, there we go. And yeah, some of these stars, so these I said they were relatively young stars, but some of them are actually red giant candidates, which makes them a little bit older than older main sequence stars than you would find in some other open clusters. Clusters like the Pleiades, those are very young stars, and there's very few red giant candidates in those. And these ones are going to be a little bit older, and as a result, they're also a little bit redder and yellower than you would find with some of those younger star clusters. All right. So while we're waiting for the other open cluster, while we're waiting for M39, if you guys have any requests to send in, you can go ahead and do that. Another person has asked, Pearl Party Island has asked if I'm observing this live. And we're actually observing this live right now. We're here in Flagstaff, Arizona at the Lowell Observatory on Mars Hill. And we have this new, brand new, it's been about a year since it's gone live, this new facility with a bunch of like state-of-the-art telescopes called the Geo-Valley Open Deck Observatory. And we're using a 14-inch plane wave CDK telescope,
with a Melancam, a camera attached to it. And so we are feeding the images from the Melancam live on YouTube and Twitch currently. So we are streaming both on YouTube and Twitch. So if you're not on one, you should go follow us on the other one while we're doing that. But yeah, so we've been here since about 6 p.m. Last night. I guess it's last night. We started at dusk. We have been trying to get through all 110 of the Messier catalog objects, and we are most of the way there. We've only got maybe 20 or so objects left to get before we call it quits for the night. And which I'll be grateful for. I'm a little bit sleepy. But we have done 85 of the 110 Messier objects. And we're not going in numerical order because the objects weren't cataloged, and they weren't cataloged all at the same time, so they're kind of out of order in the sky. So we have to go from order from what's going to be rising or setting first. All right, so someone actually requested the jewel box cluster, so our Pana Basapa. So I'm going to wait until we find out if we can view that one or not. I personally haven't heard of this one, although it sounds like the names of some other, look, there it is. So this is another open cluster. So we're going to go ahead and get that in there. We might as well. And we might as well just see how this looks. I'm hoping for some multicolored, the stars themselves will each be their own color, but several different colors of stars. And so this one is actually located in the southern sky, which makes it very easy. We have a very good view of the southern sky here at the Giovanni Open Deck Observatory because we have no trees in the way, and the building that we store the telescopes is actually in the north. It's in the southern hemisphere. Yeah, we won't be able to get that. We won't be able to get that because we're a little bit too far north for that. That one is a southern object. So we won't be able to see the jewel box cluster, which I'm kind of sad about. Jody has asked, is the Melancam actively cooled? It's amazingly low noise. And yeah, we do have a cooling system, and I realize that you guys can't see the temperature that this is being held at all, but we do keep this at a really cold temperature. And every time I look at the temperature on the camera, I'm thinking, is that the temperature outside? Because sometimes it feels that way, especially in the winter here in Flagstaff. But we do keep it cooled, and we try to keep those hot pixels at a minimum. And this is a brand new camera. We just had it donated to us very recently, within the past couple of months or so. So it better be working like a dream, or else I would be asking for a refund. Pearl Party Island asks, can all of these be seen via a standard telescope? And yeah, all of these were discovered by Charles Messier. And this was back in the 1800s. And so he didn't have the best telescope at all. He didn't resolve these objects very well, but he was able to see them. A lot of these, this one in particular, is actually a binoculars object. If you had any kind of binoculars, you could go out and you could view this pretty easily. So you don't need a big fancy telescope to do viewing for the Messier objects at all. It certainly makes it nice. I feel a little spoiled being up here sometimes. But yeah, you could view these with a small telescope or even binoculars. And some of them, not necessarily this one, but some of them are even naked eye objects. You don't even need a telescope. However, you won't get the resolution with your naked eye that you would with, a telescope. So yeah. Let's see if we can head back to M39. I don't know if enough time has passed or not. But I know that I have about 5 minutes left before it's time to take another break or so. And I know that the telescope operator is getting pretty cold, and they're probably going to want to go inside again. I don't know if it changed or if it didn't change just now. I'm going to assume no until that 10 seconds is up. It looks like we're still not getting it. Still looking behind the building. We might have to keep this one on this a little bit later. Someone else is gonna have to get this on their round. If we can't get it, it'll probably be about 10 more minutes before we can scene. Pearl Party Island asks, what would I have done if it was an overcast weather night? And let me tell you, we actually had this Messier marathon scheduled for last week. Now, there's a few weeks where it's optimal to do a complete Messier marathon, and that's getting all 110 objects. And that's going to be based off of basically the season where the sun is, when the sunrise and sunset are, and also based on where the moon is. And last week was actually optimal for us because it was the new moon, and so we were gonna try that. But we actually had some pretty poor weather here in Flagstaff. It is known to snow all the way up through May. I know many people who have it snowed on graduation day for them, and last week was no different. It was snowing, and we had some really crummy, cloudy weather for pretty much the entire weekend that we had this planned. So we actually ended up just postponing it until this week. If it had been overcast tonight, which it was a little bit at dusk, we were cloud hopping, trying to get some of these dusk objects. We were cloud hopping like crazy, trying to get them all because we really want to win. And we managed to succeed, but if it had been too overcast to get most of the objects, there's only so often that we would be able to postpone the Messier marathon until we can't do it anymore, until it's too late in the year and we have to cancel it altogether. So we were pretty lucky that it did clear up when it did, and we were able to get some of those objects at dusk. So as long as it stays clear the rest of the morning, which it should, we should have no problem getting the rest of them. The only problem is going to be whether the sun comes up too soon. And then Pearl Party Island asking another question again, what is the first or easiest Messier chart image to view? I don't remember what the first one that we looked at today. I think I'm going to say the Andromeda Galaxy was, the Pleiades. I guess the Pleiades they're a really bright, close, open cluster of stars. You can see those with the naked eye, and you can see those before sunset. So that's what they got first. And I believe, it was the Pleiades. I was going to say the Andromeda because I know that one's pretty bright, and they got that one pretty quickly as well. Oh, they tried. Oh, we didn't get the Pleiades? Oh, someone signed off on it. So we did M52 first, but the Pleiades would have been best if we could get that one first, is what I'm under the impression of. Either way, we did get the Pleiades. We did get them. Again, we were cloud hopping, so it wasn't exactly as optimal as we wanted. That being said, I think at this time we're going to go ahead and take a break. We're going to let the telescope operator go inside and warm up a little bit. We're going to have Claire on next again, and she's going to be looking at some more Messier objects, telling you all about them globular clusters. And hopefully we can get M39 when Claire comes back too. So we'll go ahead and take a break right now.
Okay, hello everyone. Welcome back to the Lowell Observatory Messier Marathon. So I'm Claire again. I was here around 2 a.m. in the morning, so now I'm back at 4:30 a.m. in the morning. So we just took a quick break, but just a bit of a recap. We have about 85 objects checked off on the list, so we're over 75% done with the Messier Marathon. So we're getting pretty close. We're kind of in the long stretch, which is pretty exciting. So the first object I have up is one that we were just barely not able to get in the last session. It was just behind the building. This is M39, and this is an open cluster in Cygnus the Swan. That's the constellation. And this guy is about 1,010 light years away, so it's actually pretty close. And this one is about 700 or 278.6 million years old. So also pretty young. This one's kind of cool. I like all the different shapes and sizes of the stars and all the tiny little ones compared to some of the bigger ones that we can see in the foreground. And Messier cataloged this in 1764, but it wasn't discovered by him. So just some fun facts about this object. So yeah, so that's kind of a fun one. So before I forget to check this one off, I'm just gonna do that real quick for M39. I'll find it on here. Here we go. Okay, just so we don't forget. But now we can move into the next section now that we got that one checked off the list, which we weren't able to do in the one before. So the first object I'll go ahead and head to is M24, which is an open cluster in Sagittarius. So we'll go ahead and head there. So this guy is actually also classified as a star cloud, but it is not to be confused with the Great Sagittarius Star Cloud. That's a different one that we'll be looking at. This guy is approximately 600 light years wide. So as we start to get that image in the center, you can just clearly see just how many stars are in here. And so we use the term star cloud just to show actually compare it from just an open nebula, which could only just have maybe a couple thousand stars, to a star cloud, which just is next level. So this is definitely one of a great one to look at. And so this is really pretty. So a little bit more about this. Again, it's about 600 light years wide, so it's a pretty big distance that we cover. These stars, among other in the clusters, are part of the Sagittarius or Sagittarius Carina spiral arms of the Milky Way galaxy. So this is kind of an interesting view that we get. So this is kind of like a chance tunnel view perspective through all of the gas and dust of the Milky Way. So sometimes when we're looking at objects in the Milky Way, especially directly into the plane of the Milky Way, a lot of that bright gas and dust can obscure our view. And so sometimes we can just get these little tunnels to view parts of the other side and other aspects of the galaxy. And this is a pretty good example of that. And so this is a unique look, which is kind of fun. Has been termed, some astronomers have called this a virtual carpet of stellar jewels, which I think is kind of an interesting look at this. And the astronomer Edward Barnard has cataloged 2 regions of dark nebula within this star cloud, so objects 92 and 93, so just these little dark patches in the nebula that are obscuring some light. Barnard cataloged those. They're going to be a little bit harder to see again, just because astronomers like light things, but sometimes we study the dark things, so it's kind of interesting. Actually holds a planetary nebula, which is pretty interesting, NGC 6567. It's on the western edge of M24. So there is a planetary nebula in here, which is kind of cool. So we might be able to get that one specifically. I can call it out again, NGC 6567. So it's within M24, Messier 24, but maybe we can just zoom into the specific part. Let's see what that gives us. So while we're waiting for that, I can answer a couple of questions. So someone asked if we could see a few of the galaxies in the Virgo cluster. So we did look at those earlier, so we'd be able to go back and look at them now just because we still have some objects to go through, but If you'd like to take a look at them, you can always rewind the YouTube live stream and take a look at those, because we did hit them a little bit earlier, around the time when Jacob and Hannah, our hosts, were doing that. So that is a good one. Let's see. So someone has asked for M45, so that has well set. So if you wanted to take a look at M45 again, you can either take a look back once the stream is totally uploaded, or you can just rewind back to when M45 was up, but unfortunately it has set for us, so we won't be able to look at that at the moment. So yeah, this is still just part of the star cloud. It might be a little bit hard to find that that planetary nebula, but it is there. So that's kind of an interesting thing to think about. Let's see. There's another question from TechieMat501. What is my favorite Messier object? I'm gonna be super basic and say the Whirlpool Galaxy, probably like a lot of my other educators here, but that one's definitely my favorite. So here's a picture that we took earlier tonight, just as an example of what it is. So I think this galaxy is just wonderful. It shows some pretty cool interaction going on. But that's my favorite one to answer your question, but that's a good one. So we're gonna go ahead and move on to the next object, which is M25. And so while we're doing that, I'm gonna check off M24 on the chart behind me. Get that down. Here we go. Sweet. So M25 is another open cluster in Sagittarius. So this is kind of where we're sitting right now. Let's see what that looks like. So M25, I believe, has about 600 stars in it, so it's definitely a little less than the star cloud that we were just looking at. And it's about 2,000 light years away. But we should have some pretty bright stars in here as well, which will be fun to look at. So it's pretty cool. So let's see what that looks at. We're taking about a 20-second exposure right now, so we're kind of just waiting for the images to come through, and that's what those streaks on the images are. So when we take an exposure, sometimes we move the telescope while we're still taking a picture, and that's just an artifact of that movement. So here's M25. So we have some nice, really bright stars in here, but the one really cool thing about looking in Sagittarius in general is that we just get to see so many stars all the time, no matter where you're looking in this area. Sagittarius is just full of stars, mainly because we're looking towards the center of the galaxy. So wherever you look, you'll just find a wealth of stars, but sometimes we get these brighter little clusters that poke through, and this is an example of that. So this guy sits at about 2,000 light years away. And it's estimated to be about 67.6 million years old. So that's a pretty good age for this. And overall, this cluster spans about 13 light years across, which is also a pretty good distance. But again, just a really nice cluster in Sagittarius. I'm excited to be going into Sagittarius. It's a really nice summer constellation, which is weird to be doing kind of in late winter, early spring, out in the nice freezing cold. But some of the stuff in here is really cool. So I'm excited to be able to see this again before it's actually summer. It's kind of fun. A little sneak peek to the seasons to come. Also, yeah, it is, or yesterday, technically was the first day of spring. Now that we're in the morning, so the spring equinox was yesterday. If you're interested, we did do a live stream, so if you want to learn more about the spring equinox, you can check out that too. It's always fun to learn about how that works and what spring is like. So yeah, kind of a fun thing. So yeah, welcome spring. But let's go ahead and move on to a nice object, M16, which is the Eagle Nebula. And while we're doing that, I'll check off M25 on the chart real quick. Sweet. So now we're getting into some of the really cool nebulas, which is I'm really excited about. Some of these nebulas are definitely my favorite. And so this one will be the Eagle Nebula. Someone asked a question from Gerard Joseph. The Trifid and Lagoon Nebula, that will be in the next couple of sessions. So if you stay tuned, we will be hitting both of those. So we will be getting to those in a bit. We're kind of following a specific order right now, but they're coming up soon. So this is the Eagle Nebula. This is just an amazing nebula in Sagittarius, and it's part of a diffuse emission nebula in an H2 region in the constellation of, actually it's Serpens. That's the constellations in, sorry, not Sagittarius. But an H2 region is basically just a really nice star-forming region in the galaxy. So that's kind of how we classify that. Now, one of the more popular areas within this cluster is what we call the pillars of creation, which is kind of what we're centered on right now. So those dark little pillars coming up that are shadowing some of the gas behind it. There's a really famous Hubble image of the pillars of creation, definitely one of the most famous ones. And we're taking a look on that now, which is super cool. And they call them the pillars of creation just because this is a stellar forming region or a stellar nursery nebula. So this is where stars are formed in the night sky. So we say pillars of creation, it's definitely true because without stars, we wouldn't really have anything else in the universe because stars give us the heavy elements that we need for life and things like that. So this is pretty exciting to look at. So this is a nebula, and it also has a cluster in it, kind of towards the bottom left area. Those brighter stars are part of a cluster within this nebula. Yeah, right there. So another name for this nebula is called the Star Queen Nebula, which I think is super cool. And the Star Queen Nebula actually comes up from a suggestion of a former Lowell astronomer, Robert Burnham Jr., who is working here under the planetary or sky survey, some sort of sky survey project for quite a long time, for a couple of decades. And he was a pretty important astronomer. He's well known for his celestial handbooks. It's called the Proper Motion Survey, and he created a 3-volume celestial handbooks, and we sell the first copy, at least I know, in the gift shop if you're interested. And these are pretty well-known books, and he was a fantastic person, really well at his job, and he suggested the name the Star Queen Nebula, which I think is cool. And it comes after that these pillars, some of them can look like these majestic star queens around these nebula. So that's kind of how he got the name, which I think it's a cool alternative name to the Eagle Nebula. So this one sits at about 7,000 light years from Earth. So it's actually fairly close in terms of distance. But yeah, so that's most of this sky. I think there's lots of different names you could give this one. So with the largest pillar in this nebula, it's about 4 light years high, which is a pretty good distance. So 4 light years is approximately the distance between the sun and the closest star to us, Proxima Centauri. So that just puts it into perspective of just like how massive this structure is. I think that's a pretty good comparison, which is pretty cool. So I always like to make that comparison with here. This is just an amazing amount of gas and dust that is slowly forming stars in the night sky. So the Eagle Nebula is definitely one of my favorites. So we have a question from Pearl Party Island. So a star cloud is like a dense open cluster. That is kind of what it's like. So not quite a globular cluster where it's very compact and in a small area of sky. Star clouds take up an immense amount of area in the sky and just are packed with. That's what it is and what it sounds like. A star cloud, so like a cloud made of stars, just lots and lots there. So that's a good way of thinking of it. But let's go ahead and move to M17, which is the Omega or Swan Nebula. So while we're doing that, I'm going to check off M16 on the charts. So this is another really cool nebula to look at. This one is in the constellation Sagittarius this time. So there's 2 pretty well-known names to this. So M17 is known as the Omega Nebula, or I usually call it the Swan Nebula, as we'll see in a moment, because it does kind of look like a swan in the sky. So you can see kind of like the head and the curve of the body, and then the tail coming off the edge. It kind of looks like a swan, which I think is pretty cool. But the sky is about 5,000 light years away, and it's one of the brightest H2 or star-forming regions in the galaxy. So even a little bit comparable in brightness to the So this is just one of the biggest and brightest that we can see, and it's pretty nice to look at this. So this is on the limit for naked eye observation in really nice sky conditions. You want the least amount of light pollution as you can. You want your eyes to be well developed to the night sky by that point, and you can maybe just barely make out a smudge in the sky, but it is kind of on the limit of naked eye observation, which makes it at least really nice for looking at with binoculars and or telescopes. So it's a really good Messier object to look at, a really fantastic nebula. So this guy also contains an open cluster of about 35 hot and young stars that provide the energy to light up this nebula. So kind of what these stars are doing is they're ionizing the gas around it, or making it excited so that it gives off light and glows. So that's kind of how this gas and dust, which doesn't emit any light itself, except with these nice energetic stars, which are providing that energy to make this nebula glow for us, which is pretty cool. In this region overall, there are about 800 stars. So not, again, quite as much as a star forming or a star cloud, but still a fair amount of stars in this region. So this is also kind of interesting to compare to the Orion Nebula M42. So there's similar geometry to M42 or the Orion Nebula, but unlike the Orion where we see the nebula face on, so if you can think of like looking at a pancake face on, you're looking at it circular round, this one we're kind of seeing this nebula edge on, so we're kind of looking on that pancake on the thin side. So we're kind of looking into the nebula instead of face down on the nebula, which is just like galaxies, we can have these different perspectives on these nebulas, and it just creates a very 3D image for us and helps us realize just how big and expansive these nebulas are. Sometimes for me, when I look through a telescope or looking at images online, it can appear very one-dimensional or two-dimensional on the screen of what these nebulas look like, but it's always good to keep in mind that these are very 3D objects and they expand light years in 3 dimensions. So I'm kind of just thinking of all those layers of gas and dust that create this really cool image for us. It's pretty awesome to think about. And I just got the notification that we have just checked off at 90 for Messier objects. So we have now hit 90 objects, which is pretty exciting. This is a good one to start that off with. I think the Swan Nebula is pretty awesome. Yeah. So this is a pretty good one. Let's go ahead and move on to M6, which is the butterfly cluster, open cluster in Scorpius. So while we're doing that, I will check off the poster for M17. So we're moving from a nebula into a star cluster. Let me just check off these things on here so that I know where I am too. Sweet, so we're on M6 now. There we go. So M6 is an open cluster in Scorpius, also called the butterfly cluster, because it's supposed to faintly have an outline of a butterfly. To me, it looks more like a dragonfly because the wings are very elongated, not quite as much as a butterfly. So I think it's more like a dragonfly, but that's just my opinion. But it is the butterfly cluster. So it's possible that the first person to actually look at this may have been Ptolemy, one of the Greek astronomers of the ancient times, as Robert Burnham Jr., again, one of the former Lowell astronomers who was working on the proper motion survey, has suggested, because there is a cluster that we'll look at in the next section. So I think Ariel will be bringing you guys through this Ptolemy's cluster, but it's possible that he was looking at this cluster at the same time he was looking at what we now call Ptolemy's cluster, or M7. So we're not really sure if Messier was one of the first ones to look at this object. It could have instead been this ancient Greek astronomer, Ptolemy, because they are pretty close in the night sky together. And it's possibly visible to the naked eye as well. So that's just something to keep in mind. But one of the cool things I really like about Robert Burnham Jr., he creates this really nice poetic imagery for some of these clusters. And so I'm going to read off a little bit from one that he describes with this one, M6. So he calls this a charming group whose arrangement suggests the outline of a butterfly with open wings. And I think the word charming here just really makes it special because it is kind of charming. I think we can call star clusters charming. I think it's kind of cool. And I like the way he described it, so I wanted to share that with you guys. The sky is about 1,590 light years away. So a pretty fair amount of distance. And you can find this one pretty easily by looking at the second brightest star in the constellation Scorpio, which is called Shaula. I believe that's how you pronounce it. It's about 5 degrees north and about 1.5 degrees east. So you just go up in a little bit, and it's pretty easy to find. So if you're looking for this cluster, that's a really easy way to find it, is just by finding the second brightest star in Scorpio and kind of just moving up and across from there. So we have a question. So it seems the color is turned off. Could that be everything looks so monochrome since a couple of minutes? So we haven't turned off the color. It's just dark. So these stars are mostly just blue and white stars. We don't really have a lot of colored stars at the moment. So the color should still be on. It just might be the unique monochrome colors of this cluster in specific. But our colors should still be working. But that's a good question. That's a good observation. Let's see. Let's go ahead and move to M11, which is called the Wild Duck Cluster in the constellation Scutum, I believe. Yes. So we'll go ahead and head there. This was an interesting one. I always like looking at this one specifically through one of our telescopes on the GeoValley Open Deck Observatory called the TEC telescope. It is a 5.5 inch refracting telescope. It has a triplet fluorite lens, and it does a stellar job at this really awesome image of stars. So that's one of my favorite things to look at with that telescope. So this one's called the Wild Duck Cluster. Now this one always kind of cracks me up with the name because I don't know how they got it. Supposedly they got the Wild Duck name for the brightest stars in this cluster, which form a V, kind of like ducks flying south for the winter or something like that. But I never really got that. I can't really make out the V very well. So I think it's just a funny name for a cluster that to me seemingly has nothing to do with ducks. So I think it's kind of funny. But this, interestingly, is one of the few open clusters observed by the Hubble Space Telescope. So for the Hubble, usually it looks at galaxies that are millions to billions of light years away. It looks at nebulas, and it usually, when it looks at stars, it looks at stars that are in globular clusters, because supposedly that's a little more interesting. Sometimes open clusters aren't as interesting, but this is one of the few that Hubble has looked at in terms of what we classify as an open cluster. So in case you just joined on, an open cluster is a cluster of stars that has formed from the same gas cloud. So all of these stars are kind of in one big happy family. They formed from around the same gas cloud and are just loosely packed together in this nice little cluster from what we see. But they're not intentionally gravitationally bound to each other like a globular cluster. Eventually they'll spread apart from each other over time. So that's kind of a little bit of a different one. So this object wasn't discovered by Messier originally. It was discovered by a German astronomer, Gottfried Kirch, in 1681. And then later Messier moved it to his Messier thing. Someone said to sign off on M6. I will do that real quick just before you can have that cataloged. So do this. All right. Thank you for the reminder. I believed I signed off on M17, but I'll make sure in a moment. So this one's about 6,200 light years away, which is a pretty good distance as well. But this is a cluster, an open cluster that is fairly densely packed. It kind of has a reminiscence of a globular cluster, but not quite as much. There's just a lot of stars in there, which I think is really pretty. And it is actually one of the most rich and compact open clusters in the night sky that we can see, which is kind of fun. So it's about 316 million years is the estimated age for this open cluster, which is, I don't know, kind of young, kind of oldish in terms of stellar terms, but it's a little bit younger than some of the ones we've been looking at. And another interesting thing about this cluster is that it's relatively metal rich, which basically means that it has a high abundance of elements heavier than hydrogen or helium. So when astronomers use the term metal rich or metal poor, basically they're just referring to anything heavier than hydrogen and helium they consider metal rich, and anything not that, then they consider metal poor. So metal is a very loose term, as much so as in other sciences, but it works for us astronomers. So we kind of classify stars just based off of the type of elements that they have, whether they're metal rich or metal poor, can help us understand where these clusters came from and kind of the stars or star clouds that they form from as well, which is kind of interesting. So let me just check the time, see how we're moving along. So I guess we can go ahead and move to my last object and then make sure we have a little bit of time if we wanted to take a look back at any others. So we'll go ahead and move to M26. While we're moving there, I'll check off M11. Alrighty. And I did check off M17. I made sure to check that as well. So M26 is an open cluster in the constellation Scutum. So we should be heading there. So we'll have a couple minutes before the next change. So if any of you guys have one or two requests, we can get to those. But just to forewarn you that the next hour and a half or so will be pretty densely packed with objects. We're going to be moving pretty fast just because we have to fight the sunrise. So if we don't get to your questions or objects right away, that's just because we're trying to get all the Messier objects in for the Messier marathon. So that's just something to keep in mind. So yep, here's M26, so open cluster. This one's about 5,160 light years array with a radius of about 22 light years across. So it's a pretty good one. So an interesting aspect to astronomers is that this cluster has a low star density in the center of the cluster, which means that the center of the cluster seems to be like missing stars, kind of. And we don't actually really know why that is. We're still trying to figure out why there's missing low density stars in the center of this cluster, which is kind of interesting. It's always interesting to me to think about what astronomers are studying with these very specific clusters and just looking at their origins and try to put all of these pieces together to how these things actually form and things like that, which is pretty interesting. But this is also a really nice one to look at. There's some cool like little curving shapes going on all over the image. I think that's kind of cool. All of these stars are creating these nice little like curves and stuff. It makes it kind of look like maybe like another butterfly or something like that. That's what's just popping out to me is all these little curves of these stars, which is kind of cool to look at. But for me, that was the last object. So we still have plenty of time to look to see if there's any questions or objects. We have about 6 minutes before we'll probably take another break and then head into some of the more fast-paced things. So if you have any objects to request, now would be a really good time to do them because we probably won't be able to get to them in the next hour or so. So yeah, just a forewarning, but the next couple hours will be pretty exciting because it'll be high energy, moving pretty fast, but yeah, we're nearing the end. We're doing pretty good so far. So we have a request for a globular cluster in this area. So let's go ahead and move to a globular cluster called M3. And I looked at this earlier tonight through our Dyer telescope, and it was absolutely amazing. So I'm very excited to look at this through the plane wave. So this is a really rich globular cluster, not too far from Ursa Major, as far as I know. So we'll just wait for the image to get there. Let's see. There we go. Nice. Yeah, this is a great one to look at. So these look like fairly blue stars to me, but that could just be my eyes and maybe the telescope too. But this is a really, really nice cluster to look at. So this is one of the globular clusters. I would say one of the more rich ones here in the galaxy, but you can see how densely packed it is in the center. And this is a a good comparison to what we call a globular cluster versus an open star cluster. So again, globular clusters are densely packed. They're gravitationally bound to each other. And Joseph before me did a good job of saying how they probably came to our galaxy through galactic cannibalism. So that's one of our main theories about that. But M3 is a really great object to look at. Yeah, so thank you for that request. I always love looking at globular clusters. I think Ariel said earlier that if someone told her, I think a little kid told her that this looked like unicorn snot, that they described this as unicorn snot. I think that's super adorable and a great way to describe this, kind of fun. So just kind of, I always like thinking of more fun names to name globular clusters. Some people have called these frozen fireworks or things like that. So very inventive names. Someone has said this looks like glitter dusted on like a black piece of paper or something like that, which is kind of cool. But we still have a couple of minutes, so if you have any last questions or again objects, if not, we'll probably take a quick break at 5:10 a.m. and then we'll get into more of those objects starting around 5:15. And again, we'll just be moving pretty fast-paced from now on. So if you do have any questions that are pretty burning or requests that are pretty burning, now would be a good time to do that. So, yeah. Let me just check things. So I know with Messier marathon things, I can talk a little bit about the Milky Way and how to photograph the Milky Way. So to be honest, I'm not an expert astrophotographer, but some of the main points I want to give to people out there who may be looking to perhaps one day take a great picture of the Milky Way for the first time is that you want to go to a place where there's the least amount of light pollution that you can possibly get, because light pollution will never be your friend with astronomy. So that's my main tip is get somewhere outside of the city. State parks are a really good resource for this. You get to go to somewhere that's not only beautiful, but usually has protected night skies as well. So that's one of my main tips. And then the other one besides that is just get to know your camera, because every camera is different. And there's a lot of great resources online that can help you with how to focus your telescope at night for faint objects like the Milky Way galaxy or the band of the Milky Way across the night sky, and things like that. So I've always wanted to get into that, so hopefully I'll take my own tips with a grain of salt and actually go out and take pictures of the Milky Way. So yeah. But if not, we can probably just take a break now, and then we can head back in a couple of minutes to get into some more of the exciting things. So I think we'll go ahead and take about a 5-minute break, and I'll see you guys soon. And Ariel will be coming over next.
Hello, welcome back to the Messier Marathon. We are so close to finishing. What is it? We are 93 objects down and only 17 Messier objects to go. I'm very excited. It is currently 5:15 in the morning here in Flagstaff, Arizona, but I am pumped. So to start off, we're going to be jumping over to M7. I think Claire was mentioning Ptolemy's cluster earlier. So this is an open cluster in Scorpius. It is a little south, so we might have a little difficulty grabbing him. I guess we'll find out in a hot second, but it's visible with the naked eye, and it's around the stinger of Scorpius. This is the southernmost Messier object. Yes, he's visible in there. Nice. I love that. So this was one of the first Messier objects discovered because it was initially recorded by the 2nd century Greek-Roman astronomer Ptolemy, who described it as a nebula back in 130 AD. So a nebula translates to cloud. So initially it was seen as some smudge or some cloud in the sky. And back in 1764, it was cataloged by Messier as an open star cluster. We're able to resolve individual stars by then. The diameter of the open cluster here, or the diameter of Ptolemy's cluster here, is about 25 light years across, and it's only about 1,000 light years away. So this is M7. While I'm signing off on M7, if we want to jump on over to M18. So, wow, our poster's getting pretty full. We were just looking at M7. I'm so excited. Man, all right. So we were jumping over to M18. This is another open cluster in Sagittarius. So, we've been mentioning all the hosts, all the educators that you've been seeing. We all have different ways of explaining things. Open clusters they're younger families of stars, younger groups of stars that come from nebulae or giant molecular clouds of gas and dust, like the Swan Nebula we saw a minute ago, or the Eagle Nebula that we saw a second ago as well with Claire. So after those, we get these, occasionally we'll get these open clusters. So these younger stars, like M18 that we can see right here. So this is the an open cluster in Sagittarius. It is right between the Omega Nebula, or M17, and the small Sagittarius star cloud, or M24. This guy is about 33 million years old and about 4,200 light years away. So 33 million years old, again, an open star cluster being tens of millions of years old, versus a globular star cluster being tens of billions of years old. Open clusters are usually pretty young in, astronomical terms. M18, this open cluster, is orbiting our Milky Way with a period of about 187 million years. So it takes this open cluster 187 million years to orbit about the Milky Way. To put that into perspective, I guess our solar system takes about 250 million years to make a full rotation about our Milky Way galaxy. So a little bit of a difference there. What is that, M18? So while I sign off on M18, if we want to run over to M21. Let's see, M18. I'm getting emotional with all the boxes. Man, wild. Anyways, M21. This one's a more tightly packed open star cluster in Sagittarius. So we're still running around the constellation Sagittarius. I think maybe if we zoom out a little bit, or do that, we'll be able to see more of it. More of that tighter packed cluster kind of off to that left there. So in this cluster, a few blue giant stars have been identified, but it's mostly composed of smaller, young dim stars. This guy's only around 7 million years old, so younger than M18 that we just looked at. Yeah, we can kind of tell the blue hue in those stars. It means that they're younger, hotter. Usually blue means that they're younger and hotter stars. Sorry, it is 5:20 in the morning. One is also right next to M20, which is the next object we're going to run on over to. And while we're moving there, I'm going to check off on M21 if I haven't already done that, which I haven't. Okay. Forgot where I was for a second. Yeah. So M20 is also known as the Trifid Nebula or the Trifid Nebula. So there's M20 or NGC 6514 or the Trifid Nebula. This is a giant star-forming region made up of ionized hydrogen. Or those H2 regions that we were talking about. This is like one of my favorite nebulae. It's cool because, I said ionized hydrogen. We've been saying these H2 regions. What that means is that this hydrogen either has a negative or a positive charge by gaining or losing electrons. So just a different charged gas particle. And then these ionized hydrogen clouds are what help form little baby stars. So M20 is interesting because it's a combination of an open cluster, an emission nebula, a reflection nebula, and a dark nebula. Now, what that means is, we saw open clusters a little, I guess, throughout the past 10 hours. But, just a couple of minutes ago, we were looking at open clusters. An emission nebula is a cloud of ionized gas. So like I guess when you say nebula, that's probably what you're thinking of. A reflection nebula is a cloud of dust that are just reflecting the light of nearby stars. So I think in like the top portion of the kind of pink cloud that we see, we're seeing that bright blue star and the light in the background. And then a dark nebula, is also known as a absorption nebula. Those happen when they obscure or sort of cover up light from the stars or nebulae behind them. So we see that pink cloud and that blue cloud, and then we see what looks like these sort of like darker clouds sort of cutting in front there. And those darker patches that look like there's no light coming off there, those darker patches are the dark nebula or the absorption nebula. What are we doing? All right. Ariel and Joe should have a live debate. I don't want to do that. I would lose. Where are we at? We're at M20. Let's move on over to M8. The Trifid Nebula also is about 40 light years across and about 4,200 light years away. We're just on M20. Let's sign that bad boy off. Oh. Yes. Man, there's just no ugly nebulae, man. I'm trying to go ahead and take a peek at this. All right, this is the Lagoon Nebula, or M8. This is another giant star-forming region in Sagittarius. This nebula contains a number of Bach globules, which literally sounds like a fake made-up word, but that's just these globules are isolated and relatively small dark nebulae containing dense cosmic dust, so sort of like that dark nebulae looking feature in the front there. Now, The sky is starting to lighten up, so we're going to try to kind of speed through the rest of these objects here. So let's jump on over to M28. M28 was initially described as by Messier as a nebula containing no star. It is now known as a globular star cluster in Sagittarius, about 18,000 light years away, 12 billion years old. What was it? A millisecond pulsar was discovered in this glob. It was actually the first discovery of a millisecond pulsar was found in this glob, which is a pulsar is kind of like a star that spins really fast, looks like a lighthouse almost. And a millisecond pulsar is just a pulsar with a rotational period smaller than about 10 milliseconds. So it spins really fast, like a neutron star spinning really fast. Now let's jump on over to, M22. While we jump to M22, I'll sign off M28. I'm stressed. Let's get these objects. I'm so excited. All right, so M22 is also known as NGC 6656. It's an elliptical globular cluster. That's really bright. That looks pretty cool. I also don't know if that's the sun. M22 is one of the first globulars discovered back in 1665, and it was included in the Messier catalog back in 1764. It's about 11,000 light years away, and M22 is also one of only 4 globulars in our galaxy known to contain a planetary nebula. So we can't quite see the planetary nebula, but I promise you there's the death of a sun-like star somewhere in that smudge. With that, I think what we're going to do now is we're going to take a quick 2-minute break. I'm going to switch off with Jose, and then we're going to try to go ahead and grab the rest of our Messier objects within the next couple minutes. Also, we just hit 100 objects. We only have 10 more objects left. I'm pumped. I hope you are too. Wow, okay. We're going to take a quick break. We're going to warm up, and then we'll be back in a hot second. See you in a bit.
All right, so we're back after just switching places real quick. This is M69. I don't have a lot of time to really go over all of them because we are racing the sun right now. I'm going to check off 69 real quick.
Of course, there it is. Oh no! This is not the time for that now. All right. So that was M69. It's another globular cluster in Sagittarius. So that one just a little bit, 29,000 light years away, 1,000 solar masses or so, and they're pretty old stars. Let's move on to M70. So 69, right over to 70. Just another thing about 69 was in 1995, Hale-Bopp was actually discovered near M70. So that was a comet that had a close flyby to the Earth. It was one of the more spectacular comet flybys, and I remember it clearly. I was 6. All right, so in about 10 seconds, we're going to have Messier 70 up here. And that one is not too much different from 69. They're actually part of, they're within like arc minutes or so. So that is Messier 70. I already lost it. So we got 69 and 70 down. And you can see while we're taking pictures here. Let's move over to M54, Messier 54. You can see the image quality is going to start to it's going to go down quickly as we're racing the sun here. We're literally on our last stretch. We've hit 100. We're at 102 now. Once M54 comes into view, we're going to be at 103. And so we have quite a few that we have to get pretty quickly. Is that tiny little blob right there, and you can actually see our exposure times have to shorten as well, just because of the light that's coming, the noise from the sky. What did I say this was, 54? I can see there's so many signatures. It's actually, I'm finding it hard to find ones that don't have signatures anymore. So there's Messier 54. Guess what? It's another globular cluster in Sagittarius. Let's move on to M55 and comment what this is and what constellation it is in. I'll give you one good guess. It's it's a globular cluster in Sagittarius. We can see that. Let's get one more picture of that before we can actually say, yes, we got Messier 55 on there. I almost just want to stay standing. I don't know what the best choice is for my sitting or standing right now. And then 75, we're going to Messier 75. This one is another globular cluster in Sagittarius. There's a lot of globular clusters because they're always hanging out near the galactic core, which is in Sagittarius. So we're going to find a lot of them in just that general area. Is that it, or did it change yet? But that is M54. So we can. M75. Sorry, that is M75. Yeah. Okay. There we go. See, they just all look the same to me. You have to tell me if they're up or if the picture changed when I wasn't looking. Because I'm like, I don't know, it looks the same. Let's go to, we're going to go to M15. M15 is a globular cluster, but it's not in Sagittarius. It's actually in Pegasus. And on a nice fall autumn night, this is one of the brightest and best globular clusters to view. And if I had a lot more time, I would talk about it some more because it is a really nice globular cluster. We do have M15. 15 right here. I will say it does have a name, and it is the Great Globular Cluster in Pegasus. Then we're going to M2, which is also in Pegasus, I think. I didn't bother to write that one down, and so I've completely forgotten. It might be one over in Pisces. Pisces, I think. But that we're going to say that is actually M2 right there. We're going so quickly. We are racing the sun. This is like an action movie right now. And Messier 72, number 72,
Sorry. M2 was in Aquarius. Yeah. I don't have anything snarky to say about Pisces and Aquarius. So, one more picture. Come on. There it is. You can sort of see it. Messier 72 right here. And then I think we have, oh no, Messier 73. 73. Let's do this. So Messier 73, I think, was in, I didn't write that one down. But this is actually an open cluster. This is those 4 stars right in the center. Yeah. People have debated on whether it's actually a cluster or an asterism. 56, 53. So we're not actually too sure, but we're going to pretend that it's an open cluster. And then we do have one last one. I believe this is the last one, is Messier 30. And if correct me if I'm wrong, that this is the last one. But we kind of, at this point, I think we have to wait for Messier 30, which means I can do some talking. And we can talk about, we can answer any questions. Yeah, so we're still looking at the horizon here. That's what that mess is. This one is going to be the hardest one for us to get right after M74, which we got in the dusk time in the early evening. That one was a little bit of a challenge. So now at this point, we just have to wait for it to rise. So while we do that, I can go back and just answer any questions that anybody has about globular clusters in general. I know that we've been looking at a lot of globular clusters all night long. Someone's asking if we hit M107. Let me just double check. It has been signed off on the board. So we did hit 107, which is good. In fact, M30 should be the only one I haven't signed yet, but I can't find 30. Oh, there it is. M28 wasn't signed, so we should find out if we got M28. We did get 28, so I think that was Ariel, so she'll have to come in and sign it. I'm not going to sign it for her. That was hers. So we can see some stars in M30. According to our telescope operator, Claire, you can see one little speck right inside the trees. I am probably going to have to say that's it. That's what we're gonna say is M30 right there. We can give it a few more exposures as it literally moves out of the tree. But as you can see, it's really, really bright already, which is weird because I'm looking out the window. It doesn't look at all bright. But how did the tree grow? Did the tree grow? Jody R says thank you, and honestly, Jody and everyone else, Jonathan, I know that was I think Jonathan and I forget everybody's name, Mojo66, there was like Pandemic Watch. Thank you all for joining us tonight on this International Star Party on Twitch and on YouTube, as well as some of our other viewers. We had quite a few that were watching throughout the night. That's a star. That's M30. I'm signing it. I'm saying that it's M30. There we go. And then so as long as my colleagues also agree that we can say that we got M30 and that I'm not just cheating or anything, we got it. We're gonna give it about 2 minutes, because once it pulls out of that tree, it might be easier to photograph. So we'll just hang out here. We might as well just remind everyone to, if you want, Or if you can, please follow us on Twitch. We are now on Twitch, and we're going to stream every Tuesday for more interactive stargazing. Jacob and Hannah, they're going to be doing that every Tuesday night. And then also, we have to thank the entire team that pulled off this Messier marathon. We had Kendall and Catherine and Victoria at the beginning of the night, as well Jacob and Hannah, and then myself, Ariel, and Claire for the end of the night. And of course, we couldn't have done it without Sarah, Danielle, JB, Richard, Heather, Kevin Schindler. I'm just naming names at this, all the people that I know at this point. And then, of course, don't forget to, if you haven't yet, you should subscribe to Lowell Observatory's channel on YouTube, and hit that notification button so you can stay in tune with all of our live streams that we do. We do interactive stargazing on Tuesday, Cosmic Coffee on Thursdays, and then every someone suggests the tree down, and I'll go ahead and I'll get right on that right after we sign off. But yeah, I believe that I'm gonna say we did see that one little blob on M30, and then once Ariel signs off on M28 over here, we will have completed the Messier marathon, our very first live Messier marathon as well. Hey.
Where am I?
28. So
Is that it?
yeah, that's it. That's the only
Oh
one
my
that's missing.
goodness gracious.
Yeah. Yeah, we
Air
actually
five,
did it.
kid.
Yeah,
We
air
did
high,
it.
air high five. And honestly, yeah, this is a really fun night, and I can't wait to do it again next year, because this is gonna happen next year. I know for sure. So I think I'm gonna quit talking and rambling, and I think we'll go ahead and we're gonna call it quits for the night. Thanks, everyone.